I see two Caitlin Ahrens. One with video, one without video.
Yes, I'm everywhere and nowhere. Where am I today?
I'm everywhere and nowhere. Sounds like the beginning of like, what was that? It wasn't the Twilight Zone. It was not One Step Beyond. What was the other one? 50s sci-fi show.
Outer Limits?
What's that?
Outer Limits?
Outer Limits, yes.
Yeah, do not attempt to adjust
they didn't
your
say
Zoom.
that on the Outer Limits, but they could have.
Yeah.
Mm-hmm. What's that? Outer Limits. Outer Limits. Yep, Outer Limits. Okay, so which out of all three, Twilight Zone, Outer Limits, or One Step Beyond, which one freaked you out the most?
There's Lost in Space too.
Oh, it's Lost in Space.
That one didn't freak anybody out though.
No.
Yeah, the Great Vegetable Rebellion frightened me as a potential writer.
Really? As a writer?
Yeah. The story behind that is the writer said he was under contract, had to deliver X number of scripts. He had to come up with something. So he wrote something so ridiculous they would never film it and buy another script from someone else. He didn't know the series had already been canceled. They weren't going to buy another script. They took his, as absurd as it was, and filmed it.
Wow.
And it humiliated the actors who were on there.
I bet.
Yeah, but I will tell you, Outer Limits probably freaked me out.
Did it? Yeah.
As a young kid, yeah.
I was
Twilight
freaked
Zone
out by
never did.
One Step Beyond, you know. Because it seemed like something, that, you know, because they always had weird things, you know, like ghosts showing up on the side of the freeway or, you know, these kinds of things. And they always said it was true. It was real, right? So
based on a true story.
Well, that's the way you tell campfire stories, and that's true. And it happened right around here.
Yeah, that's right.
Just so happens to be on this night.
Yes.
That's right.
27 years ago. Yeah.
On a night just like this.
Like, who has not heard the claw?
Oh, yeah. That's true.
And it happened in everybody's hometown.
Mm-hmm.
Hey, we had Mothman, so.
Oh yeah,
I'm from West Virginia, so yeah.
Mm-hmm.
That was why the War of the Worlds was so shocking, right?
Yeah.
I have that radio play on CD, and it's really fun. Oh, I love radio plays. That's a dying art.
Yeah, I enjoy radio dramas as well. And but in the 1950s, my dad and I used to watch one of the earliest sci-fi shows, Men into Space, half an hour show, and pretty well done for its time. And it went through the Mercury program, the predicted Gemini and Apollo and moon landing and everything else. And
that's so cool.
You know, I was just captivated by that. I'd love to see an old episode, but they're just lost. I don't know if they exist anywhere. David, good to see you. Going to bring us some good poetry tonight, I know.
Hello, it's good to be here.
Hey, David.
Hey, David.
That's a cool
So
shirt.
sorry that I am late today, but I'm here.
Good to see you.
It's great to see you.
Thanks. Well, I'm all set.
Cameron is in witness projection again. He's hiding behind Messier objects.
Yes.
Actually, I'm just preparing some vegetables for dinner.
Oh, like Lost in Space episode.
There you go.
Very on theme.
Yes.
Actually, the scariest Twilight Zone episode I remember was that one with that where's that little monster tearing at those engines, remember? Or that was I forgot the name of the episode, but that was the one that freaked me out. It was like a lightning storm, and it was like working on the engines and taking them out. And it's like, oh my gosh, yeah,
Oh, right. Yeah.
yeah.
They
Forgot what it was
remade
called.
that into the movie.
Yes,
Tom Lithgow, and he played a great scene in that. That was really good.
gotta love the internet though. A lot of this stuff is still preserved and accessible now.
Right.
Well, there's also a comeback now to a lot of these older ones. I've been rewatching stuff lately. Tremors was on today. I was enjoying that.
Oh, I love that.
Love that. Yeah.
Ah, yes, every geologist loves tremors.
I'm working on the original Star Trek series, and I'm in season 3 right now. And I actually never watched all of them because they would never play in the right sequence. I'd always miss an episode or so.
Yeah.
I'm actually getting a chance to see every episode and see how bad season 3 is.
My
Well,
wife is doing a rewatch of TNG, of the Next Gen.
yeah, I grew up with Star Trek. It's all the premiere on TV. And so I recently did what you did, Cameron. I rewatched them all, including ones that I had avoided like the plague, ever watching again, like and a little the children will lead them or something like that, and Spock's brain, and they are every bit as bad as I remembered. But even season 3 had some great gems within it.
Yes.
And, but yeah,
Well, Spock's brain, when you mentioned that, I was like, oh my gosh, I couldn't believe it. I was like, already, you can give some forgiveness. There's some, nostalgia. There's some like period stereotypes or whatever. There's certain things that are kind of funny. You can overlook those in the first series. But boy, when you see this, the bad acting and the bad script of Spock's brain, it was like, oh my gosh, I forgot that they made this. Yeah, but it's, you go through it and it's fun. It's a piece of history.
It is, and I enjoy anything Star Trek, with the possible exception of the first animated series.
The first animated. I didn't even know they had an animated series.
Yeah, they had the original series, then they had an animated series not long after that, and the music is terrible. If you could just, in fact, I've even turned down the sound and just read the closed caption because I can hear the voices of the actors. But the music goes on and on. Bum, 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 bum. And it's over and over.
That would be hard to watch.
I was nuts. Can you hear my lightning outside?
Thanks. Oh yeah.
Here as well.
Yeah. Talk about the Twilight Zone and stuff like that. You just got to have lightning. It's rainy season here, so we're used to it.
Rod Serling shows up at your doorstep.
Yeah. Overlapping with hurricane season, which we put up with too.
Barry Allen says, thanks. Now I'm in need of a Battlestar Galactica binge.
The original or the reboot?
I don't know.
That's the question.
That's the question.
That is the question.
It'll tell us a lot about him.
Look, Davey says, if you like old radio shows, look up YouTube channel, The Late Horror Show. It's got all kinds of old radio shows on there.
All right.
Fantastic. Okay.
Harold Locke says Orson Welles was one of the best creative minds of the 20th century.
Yes.
Mike Wiesner says, oh, wow, someone who loves old time radio shows. I love them all.
There was an old series, Dragnet, which was on the radio before television. Yes. And in one episode, they spent about 5 minutes making a long distance call. And you had to go through the operator. And it was fascinating to me because they would say, do you want me to call you back or will you hang on, stay on the line? And the Dragnet Sergeant Friday would say, well, I'll stay on the line. And you could hear operator after operator going from California to Nevada to Salt Lake City to Nebraska and hooking up to the operator in New York City. And I was fascinated by that. Now we call one 404, whatever it is, and we just call directly. There's a little bit of history in some of those old shows.
Yes.
That is really cool. Yeah, I mean, when you see those, I mean, like our children, right? I mean, they don't know what a rotary dial is, right? I mean,
Right,
stuff like that. I mean, there's a lot of that, and you look at it, it's like, wow. They were actually, my daughter is she's 16, and she's really fascinated actually by some of that historical technology. So you can't believe that we were, it was only like, 30 years ago or whatever. So it's like, it's really interesting to see it through her eyes.
I don't know what story I was telling my son, but his response was, life must have been hard without cell phones.
Wow.
Totally.
No comprehension of it.
Oh no! Like
I started grad school before the internet.
Oh, wow.
I
I'm just
remember.
glad I did my doctorate with a computer.
Or
Yes.
Emacs and
So much easier.
Well, we had when I was starting grad school, our internet access was through Pico. It was all the text-based stuff where you would surf the other schools' library catalogs and just order stuff.
Yep, searching with VI, right?
Yep,
Using
yep.
VI editor.
Mm-hmm.
and Seth is on. Hey, Seth.
Hi, Caitlin. Oh, hold on.
Good to see you, Seth.
Does this actually work? Are you getting any audio?
Oh, it sounds great.
Yeah.
And
Sounds
video.
great.
It's amazing.
Audio and video?
Loud and clear.
Okay. There's also the smell-o-vision unit here.
I don't have that adapter on my Apple computer yet.
Yeah,
know.
the real problem is they tried it in the theaters, but they couldn't
Did they
get the
really?
old smell out in time to put the new smell in.
It would be so funny though if like this thing just like sprayed out like a skunk or something,
Yeah, no.
Well, maybe not. But.
No repeat business.
Yeah.
So we've got Goddard working on cloning, and we've got SETI working on smell-o-vision. This is already a very informative GSP.
And brought together the greatest minds to figure out how to. give you
It's
real-
something new in the air.
It's something new in the air. That's right. That's right.
Gavin, welcome, and welcome to the madness and chaos of the before party.
You got here just in time to redeem this group.
Redeem. No.
That's too much
We're
pressure.
beyond
I don't know what to
redemption.
call
We were just
So
talking
I-
about the pre-internet days. If you wanna pipe in with.
that. I can't remember much.
I will
of
say
it.
one- Yeah, I will say one thing in favor of pre-internet and pre-cell phone days. A day off was a day off.
Yes.
There's no
Valid.
such thing now.
Oh yeah. If you didn't want anybody to bother you, you just walked outside.
Yeah.
But
Or
in
just
those
Go to
days,
Green
I-
Bay.
phone. I guess we can still
That's
do
so
that,
true.
right? We can still
Yeah.
turn these things off, right? So,
which switch is that, Scott? Sorry.
well, yeah. So, I don't know.
Yeah, it's an interesting,
Just let the battery
I
die.
guess, social adjustment. I guess it's kind of similar to the cell phone. When everyone was thinking about the etiquette for answering a cell phone in a public dinner setting, for example, going out, you'd ring and pick up the phone. You see some of the old period pieces, of course, the phone is ringing and you want to answer it, but now I think people are learning how to just mute, let it go to voicemail, stuff like that. I think it's the same with the internet. Now with COVID, everyone's been, ironically, without travel, you don't really have a break, because travel gave you a natural biological transition to be able to kind of take a break, mental break from the day, the hourly or minute by minute stuff that's going on the internet. So I think that there's a big adjustment right now, and we'll find a way to filter through it.
We have been given the scientific knowledge, the technical ability, and the materials to pursue the exploration of the universe. To ignore these great resources would be a corruption of a God-given ability.
10, 9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running.
Well, hello, everybody. This is Scott Roberts from Explore Scientific and the Explore Alliance, and it's my very special privilege to introduce Dr. Caitlin Ahrens from Goddard Space Flight Center. She is a specialist in planetary volatiles and icy surfaces, and she's amazing to work with and just kind of be around because she's just she's just somebody that's so alive and so friendly, and definitely has a happy soul. So, and she's extremely gifted and smart as well. So it's amazing, and so it's a real privilege, Caitlin, to be with you today. Obviously, today is the anniversary of the landing on the moon, but it's also the anniversary of the first landing ever on Mars with Viking 1, and turned out to be the anniversary as well for Blue Origin, where Jeff Bezos flew the youngest and the oldest people into space ever. So for a space tourism ride, which is totally cool. We have a great lineup of speakers. Caitlin, I'm going to turn it over to you, but really want to thank you for doing this as our special guest speaker.
Well, thank you so much for having me co-host and guest host for this evening. When Scott and I were, we kind of do some fun behind the scenes work for the entire summer thus far. So when the Apollo anniversary was coming up, it's like, we should totally do something. We should have fun with this. And then it got kind of down to the wire, and we're like, oh yeah, okay. What are we gonna do? So we hope that you enjoy this evening's program tonight. We have some fantastic lunar loonies with us tonight as well, so get ready for that. Some of us lunar folks are also a little crazy and loony, as you might expect this particular week, because it is actually the NASA Lunar Symposium compared or bridged apart with the European Lunar Symposium this week as well. So all of us lunar people are just kind of focusing on that for the entire week, getting a lot of really cool lunar updates that I hope to share with you later this evening too. But Scott, you want to start us off then?
Okay, all right. So we will first off start with a great friend to all of us, a personal best friend to me, and that would be Dr. David Levy. And David is someone that has kicked off every global star party we've done. He encapsulates the spirit and the fun of and the knowledge of what we do on every global star party, and he does that at every star party he goes to. So if you're at a star party and you hear David's voice out there in the background, you should go and hang out with him, because the stories, not only of his friends, but his discoveries and all of that stuff just kind of makes you, if you don't have David Levy at your star party, there's a little thing missing. And so I'm so glad he's here with us tonight. David, I'm going to turn it over to you, man.
Well, thank you, Scotty. And thank you, Caitlin. And it's really going to be fun tonight to go over where we are. And I'm wondering, those of us who were alive on July the 20th, 1969, wondering where would we be now, 52 years later. 52 years ago, the United States government showed that it doesn't happen often, but when the US government decides to do something right and fast and bring all of their resources to bear to do it, it is absolutely breathtaking to imagine what can be accomplished. I know that a lot of us don't agree with that sentiment right now, but it happened 52 years ago. One of the exciting things about the moon landing and Armstrong standing on the moon saying that's one small step for a man, one giant leap for mankind, was that it was only 11 years after NASA was officially formed. And that's probably as exciting a thing as the moon landing itself. NASA was formed in 1958. 11 years later, Neil Armstrong and Buzz Aldrin walked on the surface of the moon. What was I doing that night? I was at Camp Minnowbrook, a summer camp in Lake Placid, New York. And I remember we went to watch the launching, just as all of us just did a few minutes ago. And then we came back again and watched the landing, which was a lot scarier in retrospect than it seemed to be at the time. And then that evening, things were getting all excited for the moonwalk. And I knew that it was on. And the camp counselor was announcing that after dinner, we're going to have free play. And then after that will be other evening activities. And just after he made that announcement, I left the table and went up to him and I said, don't you think we should have the camp gather after dinner in the social hall to watch the moonwalk? And the head counselor looked at me and said, Levy, get back to your table and do your job. And I said to myself, I thought I was doing my job. But it looked as though I wasn't the only one who heard that conversation. The camp director sitting at his table was overhearing it as well. I went back to my table feeling, I'm gonna miss the moonwalk. And then the camp director, Lothar Epstein, stood up and he called for everyone's attention and he said, evening program is canceled. After dinner tonight, we are all going directly to the auditorium. We're going to have a television on and we are all going to watch the moonwalk. He went on and said, this is truly a night where history is going to be made in every sense of the word. And we have to be part of it. And that's exactly what we did. So what was I doing 11 years earlier when NASA was founded? I was a little kid at another camp. And I was very homesick, but I also had a chance to look at this poem, an old Welsh poem, an old Welsh prayer. And I'm thinking that night at camp, when I sang it to the camp, to that earlier camp, and then 11 years later, when I actually watched the moonwalk, and then tonight, 52 years after that moonwalk, I'm sharing it with you. Sleep, my child, and peace attend thee all through the night. Guardian angels, God will send thee all through the night. Soft the drowsy hours are keeping, hill and vale in slumber sleeping. I my loving vigil keeping all through the night. While the moon her watch is keeping all through the night. And while the weary world is sleeping all through the night, or their spirit gently stealing visions of delight revealing, breathes a pure and holy feeling all through the night. Back to you, Scotty, and thank you.
Thank you. Thank you. I am going to turn this back over to Caitlin, and she will introduce Seth Shostak. One of the things I want to let everyone know, Seth is just an incredible guy. I don't know if you've seen any of his videos or any of that, but just an amazing speaker, an incredible sense of humor. And it is also his birthday today. So what a great birthday. How auspicious is that? You know, so Caitlin, I'll turn it back over to you.
All right. Well, it is my great pleasure to introduce Seth Shostak. He has written a number of books. He's currently the senior astronomer for the SETI Institute. He also hosts a weekly radio show / podcast called Big Picture Science. If you haven't listened to it yet, I highly recommend it. It is fantastic, fantastic guests, and really goes behind the science and the scenes of a lot of very big universe mysteries. So Seth, take it away.
Thank you, Caitlin. Well, listen, I didn't expect that Scott was going to reveal the fact that this is my birthday. But that means I'm going to have to bomb out after my talk, as you know, anybody with good sense would, simply because I'm being taken to Burger King tonight for my birthday. in 1969, I was having a party at my apartment there in Pasadena, and it was sort of an institute party. I thought that maybe not an institute, a school party, and I thought that the people would like to socialize, but they didn't want to socialize. They all sat in front of the TV all night long, all through the night, actually. Okay, I prepared about 427 slides, but given the limited time that I have for this presentation, I'm not going to show you those. I mean, who would want to see the aliens anyhow, right? They're on their way to Los Angeles. They're going to be flattening that city sometime tomorrow. But I will tell you a little bit about, sorry?
Not if the smoke gets them first.
Yeah, well, it might. But, those of us here in Northern California are actually not against the idea in any case. All right, I was going to say something about the UFO stuff, only because for the last 3 weeks, mostly I've been busy with the media because, they're all going non-linear because now we have final proof that the aliens are actually afoot in the land or above the land. And I just suggest to you that you can actually look at some of these videos that have been offered by the US Navy and look at them, and you can figure out what's going on there, even though the intelligence agencies of the United States weren't able to do that. In particular, remember that those videos were made with infrared cameras, and this crowd knows what an infrared camera is. So it's, it's sensitive to heat. And you see this sort of horizontally elongated thing, and occasionally it twists and whatever. And, nobody knows what it is, it seems. The pilots didn't know what it is. The people on the ships nearby use radar and they couldn't find it and so forth and so on. Might think that that's very mysterious, but just imagine that there was a twin engine or even a 4-engine jet 50 or 100 miles in front of the Navy jet, right? I mean, that's possible. You could see that. You did just some high school geometry. If any of you went to high school, you can figure out how far it is to the horizon if you're 22,000 feet up, like these Navy jets were. And the horizon is on the order of 180 miles away. So you could see an aircraft 100 miles away, or at least these infrared cameras could see the jet exhaust coming out the back. And of course, the resolution, it's not much better than probably a fraction of a minute of arc, not very many fractions. I mean, not a second of arc, but, maybe 0.2 of a minute of arc. And that would just smear it out into an elongated thing. And there it is. All right, there's an explanation. The alternative, of course, is that it's Klingons coming to visit. But in fact, you should consider these, less demanding explanations. All right, I'm going to just spend the rest of my limited time here telling you a little bit about what's going on in SETI, only because it might interest you. As you know, SETI is normally done by using big radio telescopes, big antennas, essentially. We point them in the direction of nearby star systems. And we try and pick up we try and eavesdrop on any signals that are coming our way, either deliberately transmitted or maybe not deliberately transmitted. But in any case, if you pick up the signal, and if it's a narrow band signal, if it's a signal that's at one specific frequency, no matter what that frequency is, then you can say, doggone it, that's not a quasar, pulsar, anything natural. That's a transmitter. Our definition of intelligence, when we're looking for extraterrestrial intelligence, is if you can build a transmitter, you're intelligent. So all the people on the screen in front of you have been asked whether they can build transmitters, and the results of that inquiry will be made public later on. Okay, so that's how SETI has been done for a long time. Okay, and we still haven't found anything, and some people think there's that means something, that we haven't found anything. It could mean that there aren't any aliens, but given that there are about 1 trillion planets in the Milky Way, and I think the latest estimate for the number of other galaxies in the visible universe is about 2 trillion galaxies, each with about 1 trillion planets. If you think that Earth is the only place where there's intelligence, then you have perhaps an inflated view of your own cleverness, right? It's probably not true, right? Every time you think there's something special about you, you're proven wrong, okay? This is where parents go awry because they convince their kids that they really are special when it turns out they're not. Okay, so that's the way we've been doing SETI. And of course, it's much different than it was even 5 years ago, simply because of the march of technology. We have much better antennas. Well, the antennas haven't changed all that much, but they're much better receivers. And in particular, there's much better digital hardware behind the receivers to slice and dice the radio spectrum into little 1 hertz channels, hundreds of millions of them, right? This is a man's dream. No longer do you annoy the woman in your life by, flipping through the channels on the remote, but you get to, watch 100 million all at once. Okay, now we only do that because the aliens didn't do us the favor of sending in emails suggesting where on the dial they might be. So the more of the radio spectrum you can look at in one go, the faster the experiment. That's the way it's been done. However, I point out to you a few assumptions here. Assumption number one is that they're broadcasting something, well, obviously, but how much power would they need for us to be able to pick them up? And it turns out it's not trivial, right? Unless they're deliberately sending a signal in our direction. If they're just broadcasting in all directions, here's the Milky Way weather report for next week, whatever. If it's omnidirectional, then the amount of energy, or rather, yes, the amount of power required is on the order of 10 to the 13th to 10 to the 15th watts. Now that's a lot of power. If you had to pay for that, right? Well, you wouldn't want to pay for that. That's a lot. That's more than all the energy use of Homo sapiens these days, including all the cars and the airplanes and everything else. Okay, so that's what would be demanded of the aliens. You could say, well, okay, sure, but doggone it, they probably built directional antennas, right? Arrays, maybe, or just giant dishes like we used to have in Puerto Rico up to about 6 months ago, right? They may have those things, and then they don't need so much power, and that's true. But then they need some reason to target Earth. And why would they do that? Oh, sure, they would know that there's oxygen in our atmosphere. So, there's biology on Earth, but it could all be, cabbage and lettuce, right? All they know is that there's something that puts oxygen into the atmosphere. They don't know that there's anybody clever here unless they're very, very close, within, say, 35 light years. Then there would have been enough time for our early high-frequency broadcasts to get to them, television, FM, radar, that sort of thing, to get to them and leave enough time for their response to come back to us. Hey, reality television probably causes cancer of the eyeballs or something. Okay, so that's a very small region of space, and the chances are that nobody knows that Homo sapien exists, right? So you can't count on a directed transmission. So the bottom line of this rather soporific argument is that while SETI is doing a good experiment in that it can be verified right away whether you found the signal or not. I mean, it is an experiment, right? Unlike the UFO phenomenon, this is an experiment. But on the other hand, it does rely on the signal arriving at your antenna just at the moment that you're listening. And the total amount of time spent at any given frequency in any given direction is about 3 minutes. So 3 minutes in a 13 billion year old universe is not a lot of time. So I suggest, and I'm not the first one to suggest this, many people have suggested it, that maybe a better approach, or at least a good complementary approach, is to say, look, it might be really hard to find other societies that are, leaking a certain amount of radiation into space, but, the amount of energy required for us to pick them up at these distances is so large. Maybe what we ought to do is concentrate our intentions, concentrate our efforts on the top dogs of the galaxy, the societies that are not just 100 years more advanced than we are, or 1,000 years, or even 1,000,000 years, right? There's been plenty of time for them to be billions of years more advanced. So the question is, what would a society that's 1 billion years more advanced than we are from a technical perspective, what would they do that we could see, right? And the answer to that is, well, we don't know, right? That would be like asking Julius Caesar, what sort of technologies do you think will be, kind of de rigueur, if you will, in the 21st century? He would have no idea. So I don't know that we have any idea of what truly advanced societies could do, but they could do something that is distinguishable from nature. Maybe they build Dyson spheres or Dyson swarms, or maybe they, flash stars, or maybe they line up stars, or maybe they corral stars. Maybe they do any of these things. And in order to find these things, it's a little difficult because you don't know what you're looking for. But it does require that astronomers pay attention to things that are unusual. Prime example of that is Avi Loeb. I think everybody must know of Avi Loeb. He was the chair of the Harvard Astronomy Department for many years. And he says that Oumuamua is not, this thing that looks like a cigar in space, but that's an artist's impression, right? Oumuamua was a 1 pixel dot somewhere. It could be that it's part of an alien spacecraft, or is an alien spacecraft, or is a solar sail from some used spacecraft of the aliens. His arguments for this are, you know, some of them are actually fairly interesting. Others are maybe less interesting. I'm not saying that Oumuamua was artificial, but what I am saying is that Avi Loeb is doing the right thing in saying, look, you should pay attention to the possibility that what you're observing is not some freak of nature, right? But is actually evidence that we have cosmic company. All right, I'm going to stop there. Thank you.
Wonderful. And happy birthday to you.
Yeah,
Happy birthday.
yeah. Stop them at 30.
Wonderful. Well, thank you so much. That was wonderful, Seth. I'm glad to have you on this program. It was a real honor. And I always love to hear your take on, you know, alien detection and, you know, and life in the universe for that matter. So, so I think that, you know, it was great. And we hope you have a great party tonight, wherever you're going. So
Yeah.
Wonderful. Wonderful. Thank you, Seth.
Yes, thank you so much for joining us tonight.
Right.
Right.
We had moved up the schedule just a little bit, but we are waiting for Bethany Ehlmann from Caltech, who should be coming on here in, I guess, a few more minutes. But I'm going to turn this back over to Caitlin. And Caitlin, what is your what was your go-to inspiration for learning about the moon?
Oh, goodness. Oh, it sounds kind of like how every kid gets started, in the sense, like, you look through a telescope. But it's the sense of wonder, where I didn't grow up with video games. So it was just like, oh, this is like something real. This is something so beautiful. It's in nature. And it's kind of sad that I've taught undergrads that they'll look through a telescope and there's like a barely a sense of wonder anymore, because their brains are so used to seeing video game renditions and beautiful 3D art and everything, and that's okay to the video game world. But in a natural sense, I've legitimately had undergrads tell me, like, oh, well, okay, I'm sure that would look better in a video game. It's like, because the video game's not real. There's a point. There's a point of why you're looking through a telescope. And so it was just so inspiring to see. In this case, I wasn't looking at a full moon. Full moons are pretty, but I like it when you have the crescents and you see the shadows. You see the terminus there. You see all the really cool mountains and how deep some of these craters are. You see the geology of it. A full moon is pretty, and you can very much blind your eye if it's like really bright. But it almost seems a little bit 2D. But when you really get to see the beautiful shadows and the geometry of the moon, then you realize that this was and still is a dynamic world of its own.
Very true. Very true. Well, I see that Bethany has logged in, and it's my first time to actually get to meet you, Bethany. Although it's just here on Zoom, but I've met a lot of people here on Zoom through the pandemic, and I have to say it's been really amazing. So, Caitlin, I'm going to let you introduce Bethany, but I did read up about you, and you know, I think that you're an amazing scientist and a leader in inspiring others to follow science. So that's great. Caitlin, you want to take it from here?
Sure. So hi, Bethany. Thank you so much for joining us this evening. So really quick summary that I'm going to explain who Bethany is here. So she is currently at Caltech in the Division of Geological and Planetary Sciences. So I've actually known Bethany more through her Mars research, but it's really exciting about what all she's getting into with the lunar research side of things. So you do more remote compositional analysis of planetary surfaces. You like to know how the chemical and physical weathering of these kinds of surfaces, certain kinds of biomarker preservations, if I can recall correctly in that as well, and certainly applications of remote sensing. So I'm so excited that you can join us here this evening, and floor is all yours.
Okay, great. Thanks. So just how long do you want me to? So I was going to talk about Lunar Trailblazer and our small satellite mission to the moon. That seemed the most appropriate given the Apollo associated celebration. So how long do you want me to speak for?
Honestly, we are really ahead of schedule.
Okay, I was going to say, I'm going 30 minutes earlier than I anticipated. I thought I was going to be on the line 30 minutes before speaking.
Yeah, no worries. So you take your time, and then Gavin is going to go right after you, and then we'll probably take a little short break and probably get back on schedule. So no worries on timing or anything.
Okay, sure. Well, let me share my screen here because I'll tell folks about the mission. Let's see. So can I confirm that you can see my screen and as well as hear me and all of that?
Yes, we can. To all of the above.
Okay, all of the above. Great. All right. Well, I'm thrilled to sort of share one of the most exciting things that's certainly going on for me professionally as well as my team, which is the Lunar Trailblazer, a small satellite mission to the moon to study lunar water and lunar geology. You can learn more about our mission at the website here. Follow us at Lunar Trailblazer. And I'll just say that, thinking about Apollo was certainly one of the things most inspiring to me, and that I think just the perspective that we get of our own Earth and our place in the universe when we are off Earth, looking back, is perhaps the best perspective in the universe, and that's what exploration provides us. So just a little bit about me. As Caitlin mentioned, I explore many planets, of which the moon is only one, and it's not even a planet; it's a moon, right? But any planetary bodies. So the moon being one, Mars, Venus, Ceres, and Enceladus are some of the bodies that I have projects on right now. And the other, and that's scientifically. So I'm a professor of planetary science at Caltech, and I have a full research group. The other thing that I do, though, and I'm super into is outreach for planetary sciences. So if you have a favorite 8 to 12-year-old in your life, there's a kid's book I've written, Dr. E's Superstellar Solar System with National Geographic. That Prof that has a comic book superhero that explores the solar systems, and then it intersperses with like actual information from actual missions in the book. And then I'm also president of the Planetary Society, which some of you may know as one of the principal nonprofit in support and advocacy of space exploration, defense of Earth, and the search for life. So I really enjoy doing talks like this to share the excitement of what we're doing, which for me at the moment, one of the excitements is Lunar Trailblazer. And so I'll go through 3 things kind of quickly, but people can jump in if there are questions, and I want to leave some time at the end for questions. Lunar Trailblazer is focused on water on the moon, but why is there even water on the moon? That was a surprising discovery in kind of the 2008, 2009. We'll talk about small sats, and then we'll talk about Lunar Trailblazer itself. So, just by way of background, I know there's, amateur astronomers on the line, right? So this is how the moon looks in different phases from Earth. It kind of wobbles a little bit on its axis, but not much. And because one of its faces is tidally locked toward Earth, the moon takes 28 days for one rotation, same as around its axis, same as to go around the Earth. So these kind of slow lunar days. And, when we look at the moon, we're seeing the ancient volcanic lavas or mare, and then the bright toned feldspar mineral rich ancient crust, rich in silicate minerals. Now, This lunar day, and it being 28 days long, has some, and it's an airless body, has some implications. I don't know how many of you looking at the moon think about what temperature is the moon when I'm looking at it. Well, this graphic, if you've never wondered the answer to this question, this graphic will let you find out the answer to this question. So these are actual a compilation of data from the Diviner mission, and what you're looking at is just a line of longitude on the moon. So you can imagine you're standing at the dot in the center here, so just above the equator, at about 45-degree line of longitude. And what you're seeing is the temperature over the course of the 28-day lunar day. And, so from the temperature scale here on an airless body against the vacuum of space, you actually get, you go really cold, on the order of 150 or so at the equator, Kelvin. But then at noon, it's up to 400 Kelvin. So that's 260 Fahrenheit, and that's well above boiling. So the surface of the moon is incredibly hot in the equatorial regions. It's the surface of extremes. Now, on the other hand, if you're at the pole, you may notice that it's quite a bit cooler. It doesn't, notch much over, 300 K or so. And one of the things that is the poles of the moon actually can really be quite cold. Why is this? Well, so now that we're, thinking of the surface temperatures and temperatures of extremes, let's think about it now in cross-section view. So the arrows are, imagine the light coming in from the sun, from the screen here, illuminating the surface of the moon. So on Earth, over the course of a year and a lunar day, the poles of Earth, right, sometimes are in complete darkness and sometimes see sun. But for us here, if we are, standing on the pole of the moon does not have tilt on its axis, or at least it's not an appreciable tilt. So consequently, if you're standing at the poles of the moon, there are places on the moon that are in permanent shadow that never see the sun because of topography. So this is a topographic map. Red is high, purple is low, and filled in black are areas at the south pole of the moon where, because they're at the bottom of a crater, there's a ridge there that keeps sunlight from ever reaching the surface. These are the PSRs, the permanently shadowed regions, and they're very, very cold. Why does this matter? Well, Lunar Trailblazer is about the search for water on the moon. Why would there be water on the moon? It gets it gets 400 K, it boils, it's in the vacuum of space. It would be lost to sublimation anyway. Well, not necessarily. And I love these kind of old but good papers. And this one's from 1961 and from some colleagues of mine at Caltech. I was not even born at the time, of course, but nonetheless, my Caltech colleagues. So Urey, big name in geochemistry, 1952, recognized that there may be depressions on the moon where the sun never shines. But he at the time concluded that no solid or liquid water could exist except for more than short periods. On the other hand, Watson, Murray, and Brown here argue with their calculations that water is actually far more stable on the lunar surface because of its extremely low temperatures in this shadowed region. And in fact, they go to calculate that water should be stable against sublimation, that is lost to space by going directly from solid to vapor, for billions of years. It should be stable. A more modern take on this was provided by Dave Page of the Diviner mission, which mapped the temperatures of the south pole of the moon. And here you can see in these permanently shadowed regions, some of these craters that are right near the pole of the moon. Indeed, the temperature is 75 Kelvin. So 75 down to even, there's some purpley tones here, down to even sort of 40 Kelvin. And the prediction here is that phases like water and even some other phases that are normally liquid or gas, methanol, ammonia, sulfur dioxide, carbon dioxide, they would be solid, frozen, and preserved for billions of years in these cold trap regions, these cold traps in the permanently shadowed regions. Now, what does this mean? Well, So here's the example of dry ice. They are slowly being lost via sublimation, just as dry ice sublimes. But because the temperature is just so cold, the rate of loss is low. So to test this, whether there's any ice or volatiles in it all, some of you might remember the L-cross impactor in 2008, where L-cross was a spacecraft with a intentional impactor into the surface. So there was like an impactor and then a chase vehicle, and then the plume was also observed from Earth. And so it was intentionally impacted into one of the oldest, coldest, permanently shadowed regions. And in that plume, spectroscopically from the spacecraft and also in telescopic data, was the signature that you see here in the black, the signature of H2O gas, where the arrows here are pointing out the lines of H2O, solid H2O, the absorption features due to actual water ice and not just water gas. So there's at least water one place on the moon. Where else is it? Well, so since then, we got great temperature data of the moon with Diviner and could make temperature maps where water was predicted to be stable. And basically everywhere that you see white on this map on the left was somewhere that, based on the temperature and based on the modeling, that it was anticipated that water ice would be stable. And then also neutron detectors were sent to the moon, and hydrogen is a good absorber of neutrons. So where there exists hydrogen, neutrons are low. So anywhere that there's a blue or purple color on this map, there should be elevated H. Is it H and H2O? But so these are interpreted as zones of elevated hydrogen, up to about 0.5 weight% hydrogen, which isn't all that much, but maybe there's water ice here. That's the most logical explanation. But interestingly, you see it's not really a one-to-one map. Yeah, there are places where the maps match, like some of the larger craters like Shoemaker, at the L-cross impact site in Cabeus crater. But there are other places where there does not appear to be a match, like over here just to the kind of north of the L-cross site. There's no sign of an elevated hydrogen there. So what's going on? What controls where there is water on the moon? That is kind of the state of the science. We know there's ice in some craters, but why some are full and some don't appear to be is a little uncertain. Meanwhile, elsewhere in the solar system, the MESSENGER mission coupled with Earth radar found that Mercury, warmest to, like closest to the sun, Mercury, boiling hot surface, actually also has ice in its polar regions, north and south, for the exact same reason. It doesn't have any tilt, so it gets these permanently shadowed regions. So Mercury, it was discovered, also has ice. And in fact, also just atop these ices are a layer of dark organics, maybe delivered from comets over time, maybe from Mercury itself, no one quite knows. But organics and ice sit in the polar craters of Mercury. So maybe there's organics and ice on the moon. This deepens the question of volatiles on airless bodies of the solar system. So stepping into this, what was then very surprising and was actually unexpected, the Moon Mineralogy Mapper, or M-cubed instrument, Moon Mineralogy Mapper, was a NASA instrument that flew on India's first planetary science mission, their mission to the moon, Chandrayaan. And M-cubed was designed to map like lavas and igneous rocks and do all kinds of things associated with lunar geology. But then in their data, they noticed this peculiar downturn toward 3 micrometers in their data. And it was especially pronounced as they got, here you're seeing the 3 micrometer absorption. It was mapped. It was especially pronounced at the higher latitudes, closer to the poles, where the temperatures are cold. And what is the cause of this? Well, the cause of this is OH or H2O. That's what creates absorptions at 3 micrometers. So it's either, so it's this particular feature here. Now, M cubed was not expecting to find water or OH or whatever on the moon. And so their instrument cut off at 3 micrometers, which if you were actually going to look for water, you would not do that, because to characterize the entire shape of the water feature would require going to longer wavelengths and to also differentiate ice from, for example, just bound water molecules. But they weren't expecting to find water on the moon. Why should they have? It was, 400K and the sunlit side of the moon, right? They also went on to discover that certain rock formations, in this case, I'm showing a central peak of Juliatis crater, were enriched in OH or H2O. So certain rocks appear to have more water. So what is this water? I'm using water kind of loosely. I'm talking about OH. Well, by water, sometimes we mean like straight up water ice, crystalline, solid H2O. Sometimes though, we probably mean something that's a little bit more geological, geochemical. And so I've drawn the little molecules here in my stick diagrams. Here's your water molecule on an astronaut's footprint. And so something that water does on Earth is water is sticky. It binds to surfaces. It binds to chemically to surfaces. So here I'm showing how water can hydrogen bond to, for example, any silicate in any rock anywhere. And so maybe what's happening when we see this water, maybe sometimes it's ice, but maybe sometimes it's also these, bouncing kind of loosely bound water molecules. Alternatively, water can also get incorporated in minerals in the Earth's mantle and coming out of volcanoes. There's actually water vapor. And so maybe it just gets incorporated to rock. It gets bound as OH. So no H2O molecules, maybe it's just, OH. So we don't know, because we can't tell from M cubed data, because M cubed data cuts off here, and you need to go to at least, 3,500 or so to be able to distinguish, well, where is the minimum of this band? Which form of water is it? How did the water get there? So, just to say, our understanding of the water cycle on the moon is just beginning. I think all of us are familiar with some version of the chart on the left. This is like the 3rd grade version of the water cycle on Earth, right? Sun heats the water, it evaporates, forms clouds, it rains, the water flows back into the sea, and that's the cycle. I think that there must be some sort of cycle on the moon to explain why there's ice in craters, why there is water on like the polar latitudes. Something I didn't talk about, but certain people have suggested based on the data, is it seems to change a little bit as a function of time of day as it gets warmer and colder. So what is going on? Is it comets coming in that are delivering the water? Is it volcanoes degassing and releasing water that then makes its way down to the poles and gets trapped as ice? Something else involving the solar, wind, hydrogen? What is really going on? So that's sort of the state of the science right now, I would say, about the water cycle on the moon. And enter into this picture a technology piece. And something I've gotten more and more into is the technology that enables our space exploration and all these innovations. So something that's happened is small satellites have come to the fore. So what is this? What am I talking about? The small satellite revolution. Well, some of you might recognize this picture. It is not the moon. It is not the Earth. This is a picture of Mars. And this is a picture of Mars that was taken by the MARCO small satellites, which launched with the InSight mission that got to the moon in 2018. So you see the solar panel of this little cereal box size guy. There were 2 of them that were launched at the same time. That the 2 MARCO spacecraft traveled all the way on their own power from launch to Mars, and they served as the relay for InSight. There were communication relays to bring back the data in real time, and they snapped this picture along the way, because when you're doing a planetary science mission, you've got to bring a camera along, right? It's just too cool not to. But so we can send cereal box sized spacecraft to Mars to take images. That is cool. And it's all part of the revolution that's kind of going on. Those were, I should say that these MARCOs were what were called CubeSats. CubeSats are measured in units of U, where U is a 10 by 10 by 10 centimeter cube. So this is 6U. Something that's going on also is that there are small satellites here, and you can see some of them attached to what's called an ESPA ring. Basically, what's going on is that the market has figured out that most rockets launch with excess mass capacity, because you have to, at the very beginning of your mission, buy a rocket that you are absolutely sure is going to have enough capacity to launch your spacecraft. And you don't yet know from an engineering perspective how big your spacecraft is going to be. So you have to, put margin on it. And then you have to put margin on how big of a rocket to launch the whole thing. And rockets only come in certain capability sizes. So, and you always have to go up. You can't ever go down and try to squish into a too small rocket. So most rockets launch with excess capacity to bring spacecraft into space. And that's how these CubeSats and smallsats have come to be, by the recognition that if you develop standard interfaces, either a box that you slot into, or a ring that is a very fixed size, and the ring is the same no matter what on any launch vehicle, then all of a sudden you can do an Uber pool or a Lyft pool to space. You can be like, well, I have a ride going in this direction. Well, I need a ride too. Can I, be your carpool? And so that's effectively what small sats are, is you're getting ride share to space by being able to fit on these standardized interfaces to take advantage of the extra mass. And this brings down cost a lot, because you don't have to buy your own rocket. You can hitch a ride on someone else's rocket and just pay them a little bit of gas money. So this is really kind of catching on as a market. So you can see the growth kind of really kicking in kind of 2017, 2018 and beyond. You're probably familiar with Starlink and the SpaceX constellations. They are of this flavor. They launch on these ESPA rings. They just populate stacks of them and then deploy off all of the Starlinks. And we're taking advantage of this now for planetary science, like by sending small spacecraft to Mars, and by NASA holding calls to the scientific community saying, hey, send us your best ideas for a ride-along mission, mass capped at a certain kilo of size, cost capped at a cost. $55 million is a lot of money, but in planetary mission spacecraft terms, it's actually not a lot of money. The Perseverance rover on Mars cost about $2.5 billion. So 55 million in comparison, you could do a lot of small satellites for the cost of a rover, let's put it that way. In a normal kind of orbiter mission, for example, the Lunar Reconnaissance Orbiter is something on the order of 600 million. So it's a factor of 10 less than even like a normal just lunar orbiting mission. Anyway, so there are certain science topics in the solar system that are amenable to investigation by small spacecraft. Rovers on Mars are not yet one of them. It takes more than enough mass and more than $55 million to get yourself to Mars, get yourself landed, and get yourself exploring. But for orbiters and for flyby missions, there's starting to be more and more of these opportunities, and that's where Lunar Trailblazer came in, because we proposed to one of these opportunities. There was a competition. There are 12 entrants, and NASA ended up picking three small satellite missions, of which Lunar Trailblazer was one of them, and we were confirmed as a mission in November 2020, and have been on our development path ever since. So in the final, 5-10 minutes or so, I guess I'll tell you about Lunar Trailblazer and what we're going to do and how we're going to solve some of the questions about the lunar water cycle. And as a fun fact, if you want to think about it and not, while you're listening to me, think about something else too. In our logo, the water actually appears in at least 3 different ways, maybe 4. See if you can identify in our mission patch here all of the different ways that water is represented. I'll come back to that at the end. And if I don't, someone needs to ask me a question. Okay, so Lunar Trailblazer, our mission. This is a rendering of our spacecraft by a beautiful rendering of our spacecraft by Lockheed Martin. When the solar panels are extended, they're about 3.5 meters about 12 feet or so in extent. Lunar Trailblazer is one of these simplex missions. it is a higher risk posture, which is otherwise known as class D. And we launch on one of those rings. We get bolted onto the side of one of those rings and launched. We're a chemical propulsion system, and we enter into 100 kilometer polar orbit of the moon for at least a science mission of over a year. And our flight system we're on the path to development now, and we're going to be delivering in the fall of 2022. I'm the principal investigator in charge of the mission. My deputy is Rachel Klima at the Johns Hopkins Applied Physics Laboratory. Our project is managed out of JPL. Lockheed Martin is building our spacecraft that you see beautifully over here. And the instruments are from JPL and then the University of Oxford over in England. One of the fun things about the mission is that, as a professor at Caltech, we're going to have students working our operations along with experienced personnel from Caltech's operation of space telescopes. So, all right, what does this look like? And so here's how we pack on one of those rings. We have the solar panels like folded in. They don't deploy until we're released from the ring. The key engineering challenges for a small satellite are fitting in your volume box. We don't have a problem with that. Fitting in your mass box, we're now okay with that. There were some challenges in the early part of the mission, but we're now good with mass. We fit in the box, and just getting all your packaging and components right. So we have two science instruments, the HVM cubed instrument here and the lunar thermal mapper here, and there's two apertures here from which they look down to the moon, and I'll give more info on them shortly. How we acquire data, though, is that we push these apertures over the surface. So, in contrast with a telescope, your telescope is fixed and the objects are all moving relative to you. Here, it's Lunar Trailblazer's motion actually sweeping out that creates the images. So we do what's called push broom across the surface, and we build up images line by line using the motion of the spacecraft to create the image, while that line of data is read back onto a detector and split spectrally. So we get spectra from each pixel using this technique, and we target select areas of the moon. In a perfect world, we would have enough communication where we would just, sweep over the whole moon and blanket the moon and image the whole moon. But our budget does not permit the kind of communication system that would let us do that. So we must choose wisely our target locations. What does each of our targets look like? Well, the footprint is here. So we have two instruments. They acquire data effectively simultaneously within milliseconds of each other. And so this is what's called a hyperspectral image cube for each pixel in the scene. There's an associated spectrum. That's what the rainbow colors indicate. And we go out to 3.6 micrometers. So we will be able to tell the form of water, whether it's OH, H2O, or ice, right? Which is a big thing. Simultaneously, because we're getting lunar thermal mapper data at the same time, we get the temperature. So we will be able to tell exactly the relationship between the temperature on the surface and whether there's ice or not. And all of that gets to the process of why is it there in the first place and how long does it last. We'll be able to do this also for multiple times a day to understand for a given target whether the amount of water is actually changing. For those of you who might be instrumentophiles, just a few more details. So this HVM cube, the high resolution volatiles and minerals moon mapper, is very much like the moon mineralogy mapper, M cubed, that discovered water on the moon, but we're higher resolution, HVM cubed. We're higher spatial resolution in terms of less than 70 meters per pixel. And then in terms of spectral resolution to be able to resolve those water signatures. But you can see the similarity between our instrument and the one that flew to the moon. A key difference is something that's inside the box, though. There's a cryo cooler there that will keep the detector temperature down to 140 Kelvin, meaning that we'll get very high signal to noise ratio, even at the long wavelengths, which will let us be very sensitive in the shadowed regions where we're having to use reflected light indirect reflected light to do our sensing. The second instrument from the University of Oxford is the Lunar Thermal Mapper. And so it reads onto a detector through a set of 15 butcher block filters. So light comes in the telescope, passes through the filter assembly, and then into the electronics. And there are 4 bands for temperature and 11 for composition of silicates. And the heritage for this instrument is actually a CubeSat mission. So those small satellites are added again. This was the compact modular sounder that flew as a demonstration mission for atmospheric science of Earth, actually. This flew in Earth orbit on a CubeSat. So what will we do? Well, we will be able to nail this water question. What is the water? Why do we get this signature from the sunlit part of the moon? Could it really be like maybe small amounts of ice, maybe in little micro cold trap shadowed regions? Is it ice that's creating the signature, or is it probably more likely water molecules bouncing on the surface or bound in rock? So we'll be able to do that on the sunlit side of the moon and figure out, is it more common in certain types of rocks, more common in certain latitudes? Why is the signature there? And then the polar side of the moon, the shadowed regions of the moon, we will be able to answer this question of which of these hydrogen enriched regions, which of these cold traps, which of them actually host ice and which of them don't. Which of them have ice, right at the surface versus which ones have buried ice? And is the ice pure? Or is it like mercury, where there are actually, organics or maybe, sulfurous compounds or other things that are in the ice too? So it's important scientifically, but it's also important for exploration. Water is one of the most precious resources in the solar system, not just because you can drink it, but because you can make rocket fuel from it by splitting into hydrogen and oxygen. And so, any nation's plans, the U.S. plans, and any national plans for the moon all involve the polar regions where these signatures of water ice have been detected. So the question that Lunar Trailblazer will do it's more than just a science mission. We really also help pave the way to go from Apollo on the left to maybe a future that's something like that on the right. So where are we in our process? Well, we just got out of our critical design review, a big milestone that happened last week, actually. So we're fresh out of passing the critical design review, which is great because that means we get on to fabrication and then the integration of our spacecraft. Our flight system is delivered in the fall of 2022. At the moment, NASA has told us our ride is in 2025. Which is an awful long time to wait for your Uber. So NASA is contemplating earlier launch options, which I hope is the case, because it would be great to have this data of water ice on the moon from orbit before, for example, sending the Viper rover, which is supposed to find water ice in situ. It would be great to send it to a location where we actually knew 100% for sure that there was water ice on the surface. So we'll see what happens. We'll be ready to go in the fall of 2022 and ready to embark on our 12-month science mission. So I'll close there. Lunar Trailblazer is driven by the questions, all of these questions and mysteries that we have about the lunar water cycle. We're really pioneering the use of small satellites and showing how they can do big planetary science. We're doing important recon for exploration for landed missions and involving students along the way. So it's an exciting journey. Thanks for listening to it, and happy to take any questions that you might have.
Thank you so much, Bethany. This is so exciting, and congratulations again on completing the CDR. I'm sure that was just a huge relief. I remember seeing at Lunar Trailblazer on Twitter, just going yay over it. So I'm sure such a relief for sure. Let's see. So while Scott gets some questions at the ready, I'll ask a small question here. So folks may not be aware of just the different calibers of NASA missions. In this case, this is considered a simplex mission. You want to give a short little spiel as to what Simplex was all about.
Yeah, so that's what we competed for. It was one of the first small satellite calls for planetary science, small satellites. Simplex is small, innovative missions for planetary exploration. Everything has to have an acronym. So Simplex, because it's NASA. Simplex is one of the smallest category, and as I mentioned, it's a approximately $55 million mission. The next that you can compete for is an investigator. The next class of mission that investigators can compete is our discovery class missions, which are usually between about 500 to 800 million. So that's a factor of 10 more. So examples of discovery missions include the InSight mission at Mars, include Psyche on the way to the asteroids, include Lucy on the way to the Jupiter Trojans. So those are some, the Dawn mission that went to Vesta and then Ceres. Those are just a handful of examples of discovery missions. And then there's another class in between called New Frontiers. And then there's the flagship class that are like, Mars sample return type missions that are on the order of, low billions of dollars. So small satellites are big science at relatively modest cost is the goal.
Sounds fantastic, and it's so amazing how small all of our technology can be nowadays. Some of the technology that would have been back in the 50s and 60s, like how tiny that we can make our technology now, and it's so fantastic.
That's right. That's the other trend. In addition to taking advantage of earlier launch, more available launch mass, small satellites take advantage of the fact that everything is driving toward miniaturization, right? Think about the size of the camera in your cell phone, right? Versus, the big camera that you used to lug around on vacation, even 15 years ago, right? So the drive to miniaturization is letting us do more in smaller packages.
Fantastic. Scott, do you have?
Yeah, a question from Book Davies is, I think a lot of us have kind of this question, any idea how much water ice might be below the surface of the moon or Mercury, where it's trapped in these eternal, shadowed areas?
Yeah, that's really the question. How much and how deep? What we've sensed so far, actually directly sensed, is not actually that much water on the moon, like in the sense of purity. The estimates are in kind of the max estimates are low tens of weight percents, which means that if you were to scoop up or chisel out, you'd get a mixture of mostly moon dirt with a bit of water ice in it. So you'd have to do some sort of purification. Now, the question, and we don't know the answer to this question, is if we just go a little bit deeper, does the story change, right? Maybe there's actually like slabs of ice there. There are reasons that people think that this is not the case. For example, the moon is continually pummeled by impact craters. The surface is gardened. How would the slabs stay intact? There are people that propose it could be the case because actually, if you calculate how much water was released from volcanoes, it's actually quite a lot of water. I don't know, Caitlin, do you know off the top of your head a good volumetric comparison? I'm not sure.
I don't think anybody from even the Lunar conference this week even
has great numbers, but think like a lake's worth of water maybe distributed in a slab. So this is really the open question, is how much water is there. So that's why I don't have an easy answer, because we don't know. That's why we're trying to figure out.
Great.
I've got a question, Scott.
Go ahead.
Bethany, I was wondering, what do you think the source of the water is? Is it from volcanism or is it from comets?
Yeah, it's probably
most of it.
Yeah, I mean, this is also one of the big questions, and the only way to know is to get there and take some samples of it, so we get like things like isotope ratios that will let us tell for sure. But I suspect it's probably a mix. I think that when lunar volcanoes go off, we know that we know from examination of Apollo samples that the moon's mantle actually does have a little bit of water, and some of that outgassed water is not just going to be lost to space. Some of it's probably going to get on the surface, like bounce its way down to those cold traps in the craters. So I think that volcanism plays a role. I personally think that a lot of it is probably delivered by comets and asteroids and impactors, right? Like comets are mostly ice. There are a fair number of asteroids that, you know, even as they're making their way into the inner solar system, are also still, you know, large fractions of ice or hydrous minerals. So I think it's probably a mix of these things for what's in the cold traps in the permanently shadowed regions. For the water signature on the sunlit side, I think it's going to be more complicated than that. I think some of it's going to be minerals formed from volcanism, and I think that the solar wind and the hydrogen coming in it plays a role as well in creating OH sort of signatures. But we'll see. We really don't know.
Is there a study going on as far as comets go, what direction they would need to come in to hit the moon, and where they would be? I mean, from the Kuiper belt probably, but again, it's got to be coming from a certain direction to be able to set water at that location, right?
Yeah, although once there's water in the moon's general, under the influence of the moon's gravity, what is generally going to happen is it's going to tend to migrate to the coldest places over time, like because the vapor might go. Remember, the moon, you know, has these day-night temperature cycles. So during the day, maybe it's sublimed off the surface, but it doesn't escape fully into space, and then it condenses back at night, but it goes to the coldest spot locally. So over time, what that does is it creates kind of a migration or a hopping to the coldest places over time, which are those permanently shadowed regions at the poles. So kind of regardless of where the comet smacks on the moon originally, there'd be at least some proportion of the volatiles that would migrate their way to the coldest locations.
And that's that lunar water cycle you were talking about, right?
Yeah, that we don't really understand or know what it looks like, but that this temperature cycling will tend to move volatiles around as they you know, sublime and condense, but they tend to go colder whenever they, you know, they pick the coldest spot locally.
Right. There's questions and comments about the you know, getting Lunar Trailblazer out there, and you know, and also the Planetary Society's involvement with the Solar Sail project. And maybe you can give us a little bit of background about solar sail propulsion or travel, and you know, and there was a question, somebody didn't catch it all, but they said that, you know, is this particular spacecraft hitching a ride on another spacecraft?
Yeah, well, okay, if I'm going to talk about solar sail, I should at least like show you a picture, right? So you can look at this on the Planetary Society website, because we have a continuous feed, but some of you may have already seen the pictures of Light Sail 2. So Scott asked, well, how do you get to space, and how do you get places in space? So Lunar Trailblazer adopts a conventional approach. As I mentioned, we hitch a ride on a rocket, and then we're a chemical propulsion system. We use hydrazine, so chemprop, to get to the moon from where our ride releases us. We then actually, before I show Light Sail, I should maybe show one of my backup slides, because I have Lunar Trailblazer's trajectory somewhere here. Yeah, so this is what actually happens. We launch from Earth out on, you know, we're currently on IMAP, that 2025 ride. We launch out from Earth, and then we're released, though. And so what we have to do is we have to loop back and come to the moon, and then catch up and insert into orbit. So that's what we do, and it's a chemical propulsion system. What I was just showing you is Light Sail from the Planetary Society, because, you know, one idea is that you can travel off of the pressure, the solar wind pressure from the sun. It's very analogous to, you know, the wind on Earth, right? Capturing the force of that wind on your sails. Well, the idea behind a light sail is it's very thin material that captures the solar wind and the solar wind pressure. And the idea is that actually over time, you can use this to accelerate to fairly high velocities and in fact, sail from destination to destination without having to bring all this fuel along. That's the beauty of it, is that you just keep going. You're in space. There's nothing to interfere with your motion once you start going. So people have even talked about using light sails to go all the way to like Alpha Centauri, for example. But exciting about the Planetary Society, and this is, you know, with my other hat on now as not mission principal investigator, but president of the Planetary Society, is that we, you know, it's all about getting people involved in space exploration. And LightSail 2 was a crowdsourced funded project. It was funded fully by donors, fully by people. It was not NASA. that we decided that we wanted to create a space mission to demonstrate solar sailing, and we did it. In LightSail is still in orbit. You can see the camera is deployed kind of under the one set of sails. And so you can, you know, check out on the website where it is now. But we're getting these beautiful images of Earth and showing how we can trim the sails to change the altitude of the orbit. And we're still going to be going for a few more months. And then eventually we're in an orbit such that we will not become space junk permanently. We'll burn up safely in the Earth's atmosphere eventually at end of mission.
That's good. Well, as someone who contributes to the Planetary Society every month, I give my little donation. So it's very nice to meet
you. Made it happen.
Meet you. Yeah, it's not much, but I'm sure me and along with all the rest of us that are donating, we're proud to see some of the results.
You're making it happen.
Well, then I haven't turned off the auto donate button yet. You had your logo back onto your mission control hat. Quiz. I'm here to remind you that I only have 2 possible of the 4 references to water.
But what have you got?
I've got the Earth.
Earth,
and the water that's on the Earth. I've got the teardrop shape, which is the shape of water. I'm not sure if those are clouds in space, those little puffs that are there that have something to do with water, but
does it help if I zoom in?
Water molecules.
Water molecule.
Would be a water molecule.
So okay, that's the third.
Yeah.
The third is water molecules. What's the fourth? You got anyone get the fourth? The fourth is kind of artsy, so it's a little tricky.
The wave there.
Yeah, anyone? Yeah, so the wave thing. Does that remind you of anything that I showed during the talk?
I forget.
Isn't that the spectra code?
It's a spectra of something.
Yeah, that's the
the
absorption feature.
Yeah, it's the artsy path to the moon, but it's also the 3 micrometer spectral absorption feature of water. So that's the fourth nerdy one, is the spectra in the rainbow. You got it. Good group. You're the first group actually that has, through your collective efforts, gotten all 4. Congratulations. I feel like I should give you a prize of some sort.
Well, I'll be sure to listen to the next podcast and listen to Matt Kaplan, who does a great job with who's been doing. How long has Matt been working?
Oh,
for
decades. He's a superstar.
And Bill Nye, his role, Planetary Societies, he's like the overlord,
is the CEO. We don't call him overlord.
I'm sure he does. The right word wasn't coming to mind, so I'm sorry, everyone watching.
But I'll mention that to
him. Yeah, okay. Well, you're the overlord that saves us all. Bill Nye saves us all. So yeah. Again, pleasure meeting you. Great presentation, and looking forward. I look at the moon a lot. I think we're all looking forward to knowing that there's something new up there that we can imagine flying around and gathering more data, doing more science, getting back to understanding what it's there and how we can live with it and expand where we live, not just confined to Earth. So we start there and we move on.
For sure. Thank you.
Okay.
Well, thank you so much again, Bethany, for all of you watching and listening out there. Be sure to just keep your ear to the ground for more updates on the Planetary Society, from Lunar Trailblazer through NASA websites, and also follow Lunar Trailblazer on Twitter. They have fantastic updates almost on a weekly basis too. So thank you so much again, Bethany, for being here and updating us on this fantastic mission that we are all so excited about.
Okay, thank you all. Thank you for your support and your enthusiasm about space. It's great to talk to you.
Thank you.
All right, be well.
Okay. Okay. So up next is Maynard Pittendreigh, and Maynard is one of the executives of the Astronomical League, and he is here to read off questions and answers and to make for the people who are trying to get the door prizes of the Global Star Party. So we're going to turn this over to you, Maynard.
Okay, Scott, thank you very much. And I would like, oh, excellent. We're got the screen share open up now. And let me share mine at this point. It's always a pleasure to be here, and we're excited with what you're doing, and just very pleased to be a part of it. And we can't be here without plugging in the annual Astronomical League convention. Well, almost annual. We didn't have it last year. Not quite sure why. There was something in the news last year, and it's still in the news, the pandemic. So this year we're having it, but it's a virtual convention. And it's August 9th through the 21st. And you probably want to take a screen capture of this slide right here, because it is chock full of information that you're not going to be able to read while it is showing. But we've got a lot of just outstanding speakers, and we've got door prizes valued at more than $7,500. The grand prize is Explore Scientific First Light. It's a great telescope valued at $750, and we always are appreciative of Explore Scientific. So you can go to Astronomical League's main webpage, very easy to find, and you'll find the registration information. I encourage you to do that. Oh, and the price is just right. It's free. What could be better than that?
It doesn't get any better than that.
It doesn't get any better. Who in the world would turn that down?
That's right.
And among the great speakers we've got an additional speaker that's just joined the team, going to be talking about the Perseverance mission and the Inspiration helicopter. And so we've got a slew of great speakers. We're adding to them even as late as or recently as this week. And oh, here's a slide. I've already predicted this, the grand prize from Explore Scientific. Some more information about that grand prize. The bad thing about my role in the Astronomical League, I'm the executive secretary, and the officers are not allowed to win the door prizes. Oh. Yes, that's awful. But hey, at least it's still free to register.
That's right.
And we do not do anything with the Astronomical League without giving you this warning. And again, if you have not been a solar observer and you're thinking about doing it, make another screenshot of this. A lot of good information here. You do not want to look at the sun without the proper instruments, and you need to be very, very careful. We hear about this every time there's a solar eclipse. Be careful with it, but we need to drive it home all the time, because the Astronomical League is nurturing brand new astronomers. And so we always take this opportunity to say a word of caution. Now, the answers from Global Star Party number 54 from July 13th, 2021. Question number 1 was, the 50th anniversary of Apollo 15 landing will be July 30th, 2021. Which of these mission highlights was not part of Apollo 15? And the answer is A, Tranquility Base. B and C were correct answers. The first lunar rover and the feather and hammer drop physics demonstration. What a great, I still use that when I visit schools today, especially elementary school kids. But establishing Tranquility Base was not part of Apollo 15. It was, drum roll, I knew somebody was going to do it, Apollo 11. And question number 2, which of these major bodies of the solar system is the closest to the Earth tonight? And the answer is the sun. Much to my grandson's dismay, who last night he and I were looking at Venus, and he said, it's just a star because it's so far away. But the sun is the closest of these objects right now. And question number 3, on the evening of July 18th, the moon hangs to the left of what wide double star? It will make an interesting sight in binoculars. Or rather, it did make an interesting sight in binoculars on the 18th. The star is a member of the Astronomical League's Double Star Observing Program. It's a great program if you're interested in double stars. And the answer is not Antares or Spica. It is, in the South, we pronounce this word B, choice B, Zubin al-Janubi. And that's an Arabic phrase meaning scorpion's southern claw. And so the correct answer is B. And the correct answers from Global Star Party number 54 are these names here, and these names are going to be added to the door prize list. Congratulations to each and every one. And what you want to do is to send your answers to the following questions tonight to secretary@astroleague.org. So get ready to send some emails very quickly to answer these following questions. Question number 1, which of the dwarf planets, oops, sorry about that. Which of the dwarf planets is the largest in our solar system in terms of diameter? And is the answer, I'm sorry, I keep messing up that slide. Is the answer Pluto, Aries, Gong Gong? And I can't see the bottom word on my screen. I'm getting some other information here.
It's Ceres.
Ceres. Oh, I should have remembered that. Yes. So which is the largest in our solar system in terms of diameter? And the constellation Camelopardalis, like many constellation, depicts an animal. And all of these animals, when you look at the constellation, you can, well, they're not quite that clear. But is it the camel, the lizard, the giraffe, and I can't see the last one, but I think it's the unicorn?
Yep, the unicorn.
The unicorn, thank you. And question number 3. What organization has the final word on what names to give to lunar craters, Martian mountains, stars, and asteroids? Is it A, NASA, B, the International Astronomical Union, C, the Astronomical League, or I believe D is the United Nations? And so those are your questions for tonight. Send in your answers to the Secretary of the Astronomical League and secretary@astroleague.org. And don't forget, the Astronomical League will be live on September 17th, 2021 at 7 p.m. And thank you again, Scott, for giving us the opportunity to join with you as the Astronomical League.
Oh, well, thank you. It's our honor.
Yeah, it's always a pleasure to be with you.
It's our honor. Well, that's great. Okay, so Caitlin, I'm going to turn this back over to you. Up next is Gavin Tolometti. He's a planetary scientist and I guess a PhD candidate. Is that correct?
You're asking me or Gavin? So
You.
yes. Me, okay.
Whoever wants to answer first. No, but I'll turn this over to you, Caitlin.
Okay, well, it is my extreme pleasure to introduce my friend Gavin. He is a PhD student at Western University in Canada. So he is actually doing some really cool stuff between Earth and planetary science, mainly using the synthesis. Oh my goodness, Gavin, I am so sorry. You're gonna have to explain this way better than I am right now. Synthetic aperture radar. So, but you mainly study how like Moon and Mars lava flows are formed, and then some really cool terrestrial analogs as well. So the floor is yours, Gavin.
Yes. Well, thank you, Caitlin. I'm just going to quickly share my screen, make sure everything is working well. So I'm hoping everyone can see it.
Yes, we can.
All right, awesome. So, yes, Caitlin, thank you very much for the introduction, and thank you everyone for allowing me to speak to you tonight. So yes, part of my work as a PhD candidate is using a technique called synthetic aperture radar to use Earth to try and understand the Moon and Mars. But I'm actually going to take us on a slight tangent on a different journey, which is also still part of work I do and involves more of using Earth to understand the Moon. But we're going to be looking at a completely different technique that does still use analog sites here on Earth. But before that, I kind of just want to bring us like this whole event is really pretty much just reminding us about what is it that birthed the start of lunar exploration and a lot of planetary science was when the Apollo missions began. And it's something that we always need to remember when we think about what lunar exploration and science that we're seeing today and will continue to see in the future. And this all becomes very important because if we're wanting to understand more about our natural satellites, we need to really understand where we visited, what we brought back, what data we have, and what data we still need. Because if we can't really answer those questions right now, we're never really going to know how to answer the questions that were actually left behind after the Apollo era was over. So like after Apollo 11, when it was just to show that we humans are capable of landing on a natural satellite and returning safely to Earth, we then moved to more of the technological demonstrations, putting on these ground penetrating radars and seismometers to try and understand what's the structure of the moon like beneath the surface. And then we started to move more after Apollo 13, which was deemed a successful failure mission. So still a huge, unfortunate incident, but still a relief that we were able to return the astronauts back home. But then we moved towards 14 and Apollo 15, where we started to focus more on the sciences and trying to bring back more and more samples to try and understand not only how our moon had evolved and formed, but also try to understand all these geologic processes that, as we can see, definitely happened on the moon, such as the very dark patches that are these seas of mare lava, trying to understand like what is it that really initiated all this volcanism and covered the surface, and try to understand all of these other features such as impact craters, and as Bethany showed in her previous presentation, how is it that volatiles such as water and ice can stay trapped in these cold regions for so long when we used to believe that the moon was once a dry, arid, dead place? And all of these really questions start to come to mind when we start to look at the roadmap of what we see lunar exploration, what it is now, what it has been in the past 10 years, and what it's going to be like in the next decade. So when we start to think of the technological advances, we also have to think of the science objectives and goals that we're still trying to answer that were left over since the 70s. Throughout the 80s, 90s, and throughout the early 2000s, a lot of these questions were still trying to be asked, such as how old is the moon? When did the moon form? How did the moon form? When did volcanism start on the moon? When did it end? How much did impact craters actually affect the moon and our own planet? These are questions that they were able to answer some of these questions, or at least tackle to try and understand some of these questions by using samples brought back from the Apollo missions. But the problem is that did limit what we were able to figure out. So moving into some of the work that I've been working on is that if we really want to try and understand the moon, we also need to try and look towards Earth and what our own planet is able to tell us about our natural satellite. And to do that, to try and answer one of the big questions for the moon is, if we want to understand its formation and evolution, there's one geologic process which I have mentioned that we need to look at. Impact craters. Now, you don't even need to use binoculars or a telescope. When you look at the moon, you could just see it covered with all these many bowl-shaped holes, which are all these different craters that form when a meteorite or a comet strikes the surface of the moon or any planetary body. Now, if you look at it, it just looks like a very giant ball-shaped Swiss cheese when you look at all of these different craters of different sizes. And I will guarantee you that it's all not made of cheese, unless anyone's seen the Pat's Wallace and Gromit episode, which probably misled a lot of children, especially my generation, to believe that it was maybe once made of cheese. But if we do think about trying to understand the formation and the evolution of the moon, it has been highlighted numerous times, not only by NASA, but a lot of scientific councils and panels and a lot of institutional research groups saying that this geologic process is one of the key targets for trying to understand how a moon formed and how it was created. But to do that, we really need to understand what exactly happens during an impact crater event. Now, it's not like when we look at volcanic events in Hawaii, where we can actually send helicopters, drones, even people to go witness what exactly is happening at this geologic process. So the problems of an impact event, it's very unpredictable. Even if we could predict it happening, we don't want to be anywhere near it when it does occur, because it's, depending on the size, it can dwarf the amount of power that one nuclear bomb is actually able to produce. And even if we did get close to it after the event occurred, there's no way for us to really witness a lot of the damage and modifications it actually does, because it's an instantaneous process. It happens snapping your fingers usually, or even up to a few minutes. But by then, you're not going to be able to see much there to be able to learn a lot about what actually happened when it formed. So when we think about this, we want to understand two types of key conditions of impact craters. What was the pressure condition like? And what were the temperatures like? To look at temperature, we look at this type of material, which is called impact melt, which is what forms when a meteorite or a comet strikes the surface of a planetary body. The amount of energy that's released is so intense, it's able to instantly melt surrounding rocks within certain regions. Like this little image on the left side, there's just like a small little red sliver here that's labeled melt. That's the material that will instantly melt as soon as the meteorite strikes. Also, some material will vaporize, but that's only if it's right next to the impactor itself. When you think about pressure, this usually happens when the impactor strikes the surface, a shock wave is released into the ground. Think about when you throw a pebble into the water and you see the ripple effect. Those ripples are those shock waves that are passing through the rocks, and eventually those ripples dissipate, which is the same thing that happens during an impact event. But trying to record these conditions using lunar craters is actually a little bit challenging, because, as I mentioned before, we are limited to what science we can conduct based on what samples were returned from the Apollo missions. A lot of them weren't able to be collected at particular outcrops. This is where we know a rock actually formed or was moved to geologically. A lot of them were either picked off the ground because it's easy for the astronauts to collect using the materials and equipment they had, or there was very rare occasion they were able to go up to a boulder that they could presume roll down a hill, which may have come from the top of a mountain or a massif. So they could think like this had to have come from here, so the sample could tell us a lot about this large area, which is really good, but still limits what we could actually know. And even with remote sensing data, even with global coverage of the moon, remote sensing has its limitations. It can't tell us as much as being on the ground to study all this material. Now, the best way to overcome this, we need to look towards our own planet. At the same time, it was formed only just before the moon did. So as a lot of the events that happened on the moon, how it formed, can probably also be, one, preserved on Earth, and two, we can use Earth as a natural laboratory to try and understand some of the processes that happened on the moon. And one of the best ones, as we said, with impact cratering, the Earth does not have as many as the moon, unfortunately, because since we are on a dynamic planet, it's constantly being modified, eroded, covered, and just wiped away geologically. So right now, we only have just over 200 confirmed craters on Earth. When on the moon, right now, I think the number's gone somewhere above 30,000, and the number just keeps growing every single day. But we're going to focus in particular where this arrow is pointing on, which is where we start to move towards the work I've been doing, which is looking at a particular impact structure called the Mestaston Lake impact structure, which is based in Newfoundland, Labrador, Canada. Now, the reason this impact structure out of every other one on Earth is very unique is because it targeted crystalline rocks that are the most chemically analogous to the lunar crust. So if we really want to understand lunar craters, this is probably the best crater on Earth we have to try and understand how it probably modified crustal material, melted it, shocked it, and then distributed it around. Now, to do that, we need to look at types of minerals within these rocks that can actually withstand the intense pressures and temperatures that impact events can form. And this is why I look at a particular mineral that's called zircon. It's a mineral that's formed of zirconia, silica, and oxygen. And it's an accessory mineral because it's usually one of the first minerals to form in a magmatic system. And it's one of the most stubborn minerals to a geologist to ever witness, because you could probably crush this under a building, throw it in a volcano, or have a tsunami wipe it away. Nothing will happen to that mineral, at least physically what you can see. It's able to retain a lot of information, which is why it's one of the gemstones in geology, because it is the key to understanding a lot of processes. And for us in particular, what we're interested in is what pressure and temperature conditions can this mineral actually record for us during impact events. So I use a technique that's called electron backscatter diffraction. Now, essentially what this does is it fires a very focused instant beam of electrons to this mineral at an instant, once it's been tilted in a slab, which is called a thin section, which is just a very thinly sliced piece of the rock. Imagine if you're going to a deli and you're asking for a slice of pastrami or salami. That little slice is a piece of rock, and it's then called a thin section. And what we're wanting to do is these extreme pressure and temperatures can be recorded in the orientations of this mineral and the minerals that were formed prior to the mineral that we've been able to witness, which is why we use long backscatter diffraction, because it's one of the few analytical techniques we can use to actually get this information. Now, for me, I had to dive in around these types of samples going from Mestaston and look for as many types of zircon grains as I could find from many different types of samples, because if we want to really understand all these conditions, we have to find as many as possible. But to quickly jump forward, I want to quickly bear with me here when it comes to this figure on the left. It looks a little bit intimidating, but the main thing I want you to all take away from it is that all the different colors that you can see that looks almost like this wormy texture that's surrounding this bigger grain. These minerals, these are the crystals that we're very interested in. These are called zirconia, which is what forms when zircon dissociates or breaks apart when it becomes zirconia and silica. These minerals have already been proven by a previous research group that they can actually record the highest rock formation temperature on Earth, and where the only other location we're going to get temperatures that high would be in the Earth's core. And so we know that geologically, it had to have been an impact crater is the only other geologic process capable of producing these conditions. Now, what I really want you to take away from this is these two little features up here called pole figures. This particular pattern that I've circled here tells us that these crystals actually transformed from a parent mineral phase that formed at temperatures greater than 2,370 degrees Celsius. In any other geologic process, no other process can produce temperatures that high unless this mineral was plucked from the Earth's core and thrown to the surface, which is impossible. So we know that impact cratering can actually produce extremely high temperature conditions, which it already was proven too, but usually they would assume around 2,000 degrees and then call it a day. But this actually proves it could actually be higher. But what my work mainly has confirmed the work from previous authors that it is possible. But that's for temperature though. So temperature, we know it's ridiculously high, which is also nicknamed to be superheated because it means all rocks around it are going to melt above the liquidus. Now, again, bear with me with this figure here, but the main thing I want you to take away is just this little pattern that you can see here, which is aligned with this pattern here and these two dots here. Now, what we were able to find in our samples is this rare high pressure mineral that's called rhyolite, which is what happens when a zircon grain, as I showed you before, is severely impacted at pressures greater than 30 gigapascals. Now, to give you some kind of reference about what a gigapascal would be like, the deepest material that is crushed and compressed by 2 tectonic plates, you'd be really lucky to get maybe 1 to 2 gigapascals of pressure. And that's from 2 tectonic plates slowly crushing rock beneath the surface and then uplifting it in a mountain range. So an impact crater just says dwarfs that effect immediately with one swift impact. And that's why this mineral is a great mineral for telling us this is an impact crater, because again, there's no other geologic process that can produce conditions this high. Maybe in the Earth's core, right in the center, but again, impossible for it to get to the surface. So what we were able to show is that not only can we actually find craters with these ridiculously high temperatures, we can actually record these really high pressures. Now, a lot of this isn't new to the literature. They've been studying these types of high pressures for decades, since even since the 60s and 70s. But mainly what we were able to show that you don't have to have an impact crater with no melt or an impact crater with full melt to get either or of this information. You can find all this information within a single impact crater. You just have to know where to look. And that's the beauty of these zircons. Now, it all comes down to finding the right zircons, but that's when you have to keep counting as many as you can find, because the more, as we know as scientists, the more data you have, the better your results will probably end up, fingers crossed, in the end. And then one of the questions I actually started to ask, bring this back to the moon, is that can we even find these types of zircon and zirconium minerals in lunar samples? They're very likely, because there's already been a couple of papers that have been released that have shown they can be found. One by Zing et al. 2020 was able to find that rhyolite mineral I mentioned before in a lunar meteorite. It's not been found in Apollo samples yet, but that's mainly just because no one's actively tried to search for them, which is something I'm actually planning to do past my PhD time. And another paper by White et al. 2020 was able to confirm that from the Apollo 17 sample 72535, this was a troctolite, actually may have actually crystallized from a giant impact melt pool, because of this Medallier crystal that recorded that same pattern that we found and previous authors in 2017 found, showing that temperatures exceeded 2,307 degrees Celsius. So they knew it could not be magmatic, because normally those temperatures at best would maybe exceed 1,500, but won't exceed values this high. So it does show that we can find these samples in Apollo samples. It's just we need the time to actively look for them. And if we can find even more, we can learn so much more about how impact craters on the moon in particular have modified its surface and probably impacted its geology and evolution. Now, for the whole presentation, I've constantly mentioned terrestrial analogs. And you're thinking like, well, terrestrial analogs are a huge help for us to learn about a natural satellite. Because we have to remember of the Apollo era, it's what they were used to train the astronauts. They were going to be sent to the moon to look for samples, but they had no idea what to look for. And the best way to do that was to bring them to sites on Earth, which are not perfect examples or matches, but with closest relation to what they might find on the moon. Testing equipment, testing how to sample them, identify them, catalog samples, pick them up, identify them, store them, and document them, and bring them back to Earth. It's the same thing for science. If we want to understand a planetary body, we can use remote sensing data. If we have samples, amazing, we can learn a lot. But terrestrial analogs are always going to give us that extra help until we can actually send a human back onto the surface of the moon to do what a lot of rovers and remote sensing satellites cannot do: confirm what's actually going on there, or what's actually there. And this is why we use Mestastin. It's the best thing we have right now to try and understand lunar craters. And if we complement it with numerical modeling, Apollo samples, and remote sensing data that's actually studied lunar craters, we could probably gain a lot more about what's actually happened. And this is just a quick little summary slide, but the main two things I want you to really think about is not really what these underlying questions actually point towards. Like, number one, I do say that can we find more of these zircon grain zirconia crystals throughout the entire impact structure I studied? This could tell us a lot about, do these extreme temperature conditions only happen in certain locations, or is it homogeneous throughout the entire crater? Again, there's a lot of speculation. It's probably going to be heterogeneous, but no one's really looked to actually confirm this to be true. And can we find high pressure and temperature indicators in other terrestrial craters and lunar impactites? It's very likely that we can. There's a lot of work that's been done in terrestrial impact structures. but lunar impactites still need a lot more work. We have all the samples at the Creation Laboratory. We just need to get cracking and look for these particular grains and other minerals that can also provide a lot more information. So I just want to thank you all for listening, and I'm happy to take any questions.
Fantastic, Gavin. We're all clapping our hands and we're all on mute. So, yes, fantastic presentation. Someone just had their hand up for a question. Someone want to start us off?
I don't see anything from the audience here. But that doesn't mean that their brains aren't working to figure out a good question to ask. So,
I have a quick question for Gavin.
Sure.
You were showing some of the astronaut training areas. Have you visited the one in Sudbury or seen any of the ones where the astronauts did go through?
I have been to Sudbury, but I don't think I went to the. I may have been to one of the sites, but I can't remember which one it was.
I don't
off the
think
top of my head.
I don't think they made it into Manicouagan, but did they go to the one in Newfoundland where you've been studying the zircon samples?
I don't think the Apollo astronauts did. I know a lot. There have been a couple of NASA and a lot of the Canadian Space Agency astronauts are taken there by my supervisor, Dr. Gordon Ozinski, to do a lot of analog training, because it's just one of the best locations we can do lunar analog work, if at least to study like compositionally and how it could actually have impacted the lunar crust.
That's fantastic. Thanks. This was great.
Yeah. Beatrice Hines mentions just a comment. Thank you, Gavin. Beautiful presentation. She follows many of these programs, and she's an avid amateur astrophotographer. So,
I have a quick question then for Gavin. So, when you first saw these minerals, as far as like a thin section goes, I know how beautiful they can look through like petrology microscopes and whatnot. What was your first like feeling of that you were looking at something so old, and whether it's from Earth or from space?
Well, we know that they all came from Earth, but the really fascinating one, I think it's where I showed the image of a redite grain. We did not know that grain was in that sample until we were running electron backscatter diffraction analysis at the Johnson Space Center. I had no idea to me, it was just a good sample, but at first I didn't find anything that interesting until we started looking deeper and realized, hold on a second. I don't think we've seen this mineral there before. So that was probably one of the best discoveries that we did find, because I don't really mention in my presentation, but for this particular crater, that mineral has never been found before. So it's not the first to be found on Earth, but to be finding it at a crater like Mist Aston was actually a huge deal, because it did show that this mineral, which a lot of literature says does not like high temperature conditions because it breaks down to zircon at 1200 degrees, we can actually find it in areas where the melt was so hot. So it was an interesting find.
Oh, fantastic. Absolutely fantastic. Great.
okay. Well, up next would be Professor Karim Jaffer. Karim is heavily involved in the outreach activities of the Royal Astronomical Society Montreal Center. He is at John Abbott College. He is an educator of astronomy that I wish I had when I was younger. I think his talks are inspiring. Even the pitch and sound of his voice makes me pay attention. So it's a real gift, Karim, and we're happy to have you on Global Star Party yet again.
Thank you, Scott. That's really kind. And I'm happy to be here. This is an exciting day for many reasons, but the Apollo missions hold a special place in, I think, a lot of our hearts. And so I wanted to do a little walkthrough of not just the Apollo missions, but also the context of where these Apollo missions came into play. Before I do, I just want to point out that we have all of these beautiful mission patches here, and I own one, just the Apollo 11 myself. But if you take a look at our host's dress today, she's modeling all of them, which is just color me jealous. I have a tie that has the Apollo 11 landing, and I have a moon crater tie that I use when I do moon crater sketching workshops. But there's a fascination with these missions because it's the one time that we've actually stepped foot on the moon. And I know the last couple of days, a lot of us have seen, especially in the East Coast and in the Northeast of the US, Canada, we've seen the moon covered with the smoky haze from BC. And last year it was covered with the smoky haze from California. And the moon just holds a special place for a lot of us, also as an observing target for most of us. So what I'm going to talk to you about today is the Apollo missions, and it's going to be based on a few things. It's going to be based on some of the interviews done of Jim Lovell by David Eicher and Richard Talcott on Astronomy magazine, the autobiographies and biographies of some of the astronauts, including First Man by James Hansen, who I had the opportunity to meet 2 years ago during the 50th with David. He was at the RASC General Assembly that year, and we had a chance to chat. And he told us a lot of really amazing stories, not just of Neil Armstrong, but also of the entire Apollo mission and program. And so I want to share some of those with you. But before I do want to take a moment, because this is a global star party and we have members joining us from all over the world. I do want to wish an Eid Mubarak to anyone who is celebrating. It is Eid al-Adha, the Eid of sacrifice, of generosity, of just that entire spirit of improvement, of it's a family time. And for me, today is also special because just like Seth, my son, has his birthday today. And so 2 years ago on the 50th, we spent my son's birthday celebrating the moon landing at a festival at the Aga Khan Museum. And so we were there right from early morning. We were being interviewed by Breakfast Television, and he was showing them the sun through a Coronado. We've done crater sketching workshops, and so we taught people how to crater sketch. And so 2 years ago, we got to really embrace this astronomy outreach and the celebration of Apollo as a family for my son's 16th birthday. Now, you'll see these are pre-COVID times, right? There's no masks on anyone. We're all pretty close together and enjoying each other's company. This year, it's a little bit more subdued. We're at home, but he seems to still be enjoying himself with his Dairy Queen treats of pizza. And so we've had a good time just celebrating his birthday. And now I get to share the Apollo missions with the world. I also want to mention that the RASC and the RAC Montreal Center in specific has been continuing a lot of programming, and the Global Star Party audience is invited to come to any of our public events. We have one coming up on Saturday, July 31st at 4 p.m. with a member, fellow of the Royal Astronomical Society in England, Mary McIntyre, who's going to teach us how to do stunning star trails. And she's actually a co-panelist with me with Astro Radio. And if you want to tune in on Thursday, we have our monthly radio quiz. And I have not done very well in these radio quizzes because it's astronomy and music, and my music knowledge just isn't quite up to par yet. And then at our national RASC, we have a couple of things going on. We have the Creation Station, which I've shared with you before. The deadline is extended to July 31st, end of this month. And so kids ages 5 to 12, if you have stories, drawings, please do submit them. We'd love to share them with the world on your behalf. And we have the Insider's Guide to the Galaxy, a YouTube program that's restarted now towards the end of the summer to share with people just the way in which you can observe the night sky, no matter what your level is, whether you're a beginner, whether you are consider yourself an amateur or even a professional astronomer, there's something in there for everyone. Now, when we talk about this exploration of the solar system, and specifically the exploration of the moon, this has been in our pop culture from the very start. And we know that there are books and there are stories and there are legends in all of our myths, from no matter what culture you're in, of the moon and why it has such a place in the sky, why we only see one face of the moon, why we see it go through the phases, which were shared really well earlier on in this evening's program. In our own pop culture here in North America, we've seen a resurgence. After Apollo 13, things had kind of died down a little bit. And then we had the From the Earth to the Moon series. And Tom Hanks, who was the fictional character in Apollo 13 based on real life, then gave us our actual narration for From the Earth to the Moon, which really kind of shed light on some of the stories behind the scenes of these space exploration programs. And then 2 years ago, with the 50th anniversary of man landing on the moon and stepping foot, we had First Man come out as a movie after the book came out by James Hansen. And then we had the movie Apollo 11, which gave us a little bit more of a documentary style view of that mission. So I think a good place for us to start is the actual Apollo 11 mission. Let's take a look quickly at the launch and then the landing and those first steps.
2, 1, 0, all engines running. Down 2.5, picking up some dust. 30 feet, 2.5 down. Take shadow. 4 forward. 4 forward. Drift into the right a little. 1.5. Contact light. Okay, engine stop. Houston, Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot. Okay, Neil, we can see you coming down the ladder now. I'm at the foot of the ladder. The limb footbeds are only impressed in the surface about 1 or 2 inches. I'm going to step off the limb now. That's 1 small step for man, 1 giant leap for mankind.
So we have the landing in Tranquility Base, the Eagle has landed, and we have the view from Tranquility Base. And this is the view looking back at the Eagle from the first excursions out from that area. Now, this picture of that first boot print, and that first boot print that was captured by Neil Armstrong, even before Buzz came down, it's actually an interesting story here because it's not the first boot print that Neil made on the moon. When Neil was coming down off of the rungs and he stepped onto the moon's surface, the first thing he did was give a report of what that surface was like because they weren't sure if he would break through the crust or if he would be supported. And so he talked about how fine it was and the fact that it seemed to be hard underneath and that it was leaving a print. And then he looked around a bit and then he was going to set up the camera to be able to take more pictures. And the first picture he was supposed to take was of the boot print. And when he turned around, he realized he had walked through the initial boot print. So he had to find another spot to take a fresh boot print so that we have that pristine image of the astronaut's boot on the moon. It's also important to note that first step onto the footpad, he actually jumped back up to make sure that he would be able to get back into the lander. And the reason was, and this is really interesting, the landing system was actually designed here in Quebec. And that landing system was designed in such a way that it could collapse a little bit when Eagle landed on the surface. But Neil was such an incredible pilot that when he actually found the location to land, he landed too softly. And so you can even see that there's an extended part there that was supposed to move back up into the leg area and compress by almost a foot, and it didn't happen. So their bottom rung was too high above the surface, so they actually had to hop onto the pad and then onto the surface. And so they had to make sure that they would be able to get back into the lander itself. Now, after Neil landed, it was actually a full 18 minutes before Buzz made his way down onto the surface of the moon. And one of the first things that he said was what a magnificent view it was. And then he talked about the magnificent desolation, the idea that there was nothing. It was absolutely barren. And that was one of the big takeaways for them. But they found that they could move around very easily on the moon's surface. Now, they had been testing out the whole movement in the suits in 1/6 gravity on those types of vomit comet style aircraft, they found it easier to move, even though their weight with all of that material had dropped by almost down to 15% what they were used to carrying around. There was a plaque on Apollo 11 on the lander that's still there on the surface of the moon. We came in peace for all mankind. Now, David, early on, when he gave the quote from Neil, he said, "One small step for a man." And Neil is adamant that that's what he meant to say. He just doesn't know if he actually missed the or if it was caught up in static, because when you hear it, when we heard it on the video, it's very hard to make out that in front of man. Now, this image is similar to the one Gavin showed us recently of those Apollo landing sites. And if we overlay them with some of the other landing sites of the Surveyor missions, as well as the Russian Luna missions, what we can see is that the vast majority of these landing sites are all very clustered close to the equator. And that makes sense based on simple trajectory and what's feasible in terms of actually being able to target and land safely on the moon's surface. You'll also notice that the Apollo 12 mission is very close to the Surveyor 3, and it was actually able to visit the Surveyor 3 site and actually get the camera back for study. Since those original Apollo missions, there have been many more explorations of the moon. We could talk long and hard about the different countries that have visited the moon, the missions that they've done. I know we've joked previously in the GSPs about Israel having the tardigrades on the moon. There's a lot to be said about the strategies being used right now to explore the moon. But what I want to do is I want to kind of talk a little bit about the context in which we really first reached the moon. So in 1942, a German V2 rocket was the first one to really reach space. Now that boundary of space, the Kármán line, is 100 kilometers from Earth's surface. The rocket was designed by Wernher von Braun, who later worked with NASA. But one of the things that's come up in the news recently, of course, is Richard Branson with Virgin not quite reaching that Kármán line versus Jeff Bezos today, who a lot of us watch Blue Origin reach that Kármán line and go past it, and so successfully actually reach the boundary of space. In 1947, we had the first animals enter space, and they were fruit flies. Anybody who has done even undergrad labs in biology would remember that you study fruit flies because the DNA of fruit flies is actually very similar to the DNA of humans. There's a lot of similarities in the DNA structure. My sister gives me, used to explain this to me, and I tried my best to understand it. I did have some difficulty with it, but what I found really interesting with the fruit flies was that they were given a supply of corn to eat, because at that time in 1947, we had no idea what space would do to life. Life being subjected outside of the atmosphere to the rays from the sun without the shielding that the atmosphere gives us, the ozone layer, how it protects us from the UV, from the X-rays, from the gamma rays. A few weeks back, we had talked about spectroscopy, and we had seen the curves of the fact that the radio waves, very, very, very little bit of optical gets through, radio waves get through, some microwaves get through, but the vast majority of the EM spectrum is actually shielded from us by our atmosphere. So when you move past the atmosphere, what's the effect on human life, on any type of life? So after the fruit flies, the next thing to send up was a rhesus monkey. And so Albert II was the first monkey in space. And he went up in a specially adapted V2 rocket that went past the Kármán line and then came back down. And they studied him, and he seemed to have no ill effects. And then in 1957, Russia launched a satellite into space, a satellite that could orbit the Earth, transmit back and forth, and the space age had really properly begun. November 1957, the Russian space dog Laika becomes the first animal to orbit the Earth and go around in orbit in Sputnik 2. The USA was very, very close behind. The first USA satellite, the US Explorer, went up in January 31st, 1958. And that success launched the idea behind NASA. And so NASA was established on July 29th, 1958. In 1959, the USSR was ready and sending satellites towards the moon. Luna 1 missed the moon's surface in a flyby. Luna 2 crashed onto the moon's surface because they hadn't even bothered to try to devise a way to land. They just wanted to see if they could get there and what would happen. Luna 3 actually went around the moon, took pictures of the far side, and then returned. In 1961, the first human in space, Yuri Gagarin, and a lot of us celebrated Yuri's night back in the spring. Yuri made it for one complete orbit of the Earth and landed about 2 hours after launch. Again, they hadn't actually designed Vostok 1 to be able to land. So he had to bail out and land with his parachute because Vostok 1 was designed to crash back into Earth. 1 year later, 1962, John Glenn becomes the first American to orbit the Earth, and he did so 3 times. He was the 5th person and 3rd American in space, joining Alan Shepard and Gus Grissom. And you'll notice that those 3 were all part of the first Mercury mission, the first astronauts chosen by NASA in its inaugural call for astronauts. 1962 was also the year Canada joined space with Alouette 1, Canada's first satellite. And as seems to be the case with a lot of the Canadian satellites, it was built for scientific and communication purposes. For Alouette 1, it was actually built to study the Earth's ionosphere. Even though we were the 3rd country to get a satellite into space, we were the 4th country to operate a satellite in space because the British had actually had a satellite constructed by NASA for them. That preceded Alouette 1 by 5 months. Now, John F. Kennedy became president just before these first couple of milestones of reaching a man from the US to orbit the Earth and getting those real hooks into being able to successfully and safely launch multiple satellites into orbit around the Earth. But his perception was that the US was losing the space race because by then Luna missions had already gone towards the moon. So he was convinced that there needed to be some decisive achievement. And he came up with 3 possibilities. We put a laboratory in space, which Lyndon B. Johnson and James Webb and Dr. von Braun all said that they were very certain that the Russians would do that first. Orbiting a man around the moon, again, they felt that that might not be the easiest thing to get to, but if we were going to aim for that, then why not actually attempt to land a man on the moon? It was the most expensive option, but it was the one that was chosen. And the budget, the cost estimate was $22 billion to achieve it within a few years. The moon speech that he gave, he planned by the end of the decade to put a man on the moon. But within a year, the cost estimates had doubled. They had reached $40 billion. And the military withdrew their support of the idea. And so Kennedy ordered a review of the program. And he tried to propose joint ventures with the USSR, but the USSR was hesitant. They announced that they didn't want to send cosmonauts to the moon. And then Russian aides actually were trying to convince Khrushchev to accept the deal, but in order to steal US technology. All of this was for moot because the report on the Apollo program finished after the JFK assassination. And so the whole Apollo program actually became a memorial to JFK, and it gained momentum, not lost it after that. So in 1969, on July 20th, Neil Armstrong, and then 18 minutes later, Buzz Aldrin, took that one small step and became the first men on the moon. The first words that were said was the Eagle had landed from Tranquility Base, and Apollo 11 worked perfectly, getting them there and bringing them all the way back because all of those Apollo flights leading up to Apollo 11 had built a system that was able to safely land a man on the moon and then bring them back. And then soon after, we were able to explore the moon even further. And as was alluded to by Gavin, we had the lunar rovers come down in Apollo 15 and then the 16 and 17 missions, which actually allowed them to do more scientific achievements and more scientific studies and surveys of the surface of the moon. That was designed and developed in 17 months by Boeing. So I want to shortly go through these different Apollo missions and just highlight a few things for you. I've got a lot of text on here. I'm not going to go through all the text. You can feel free to come back to this if you're interested in any of these. But the first Apollo mission was the tragedy. It was Apollo 1. Gil Grissom, Ted White, Roger Chaffee, they died during the pre-flight test malfunction. All the efforts of the ground crew were for naught, and the 3 astronauts all perished in the fire. As a result, the next 5 test missions were all then changed to unmanned systems to ensure that this type of a tragedy would not occur again in the Apollo program. Apollo 7 was the next crewed mission, and this one was simply to orbit the Earth and test out all the various systems, including the Saturn rockets itself. Now, the Saturn rocket, the ones that were created to take the Apollo pods all the way to the moon and give them enough of a speed that they would get to the moon, those ones were actually having difficulty. So this other type of Saturn rocket was used for the Apollo 7, and they had the crewed mission happen safely. It was a 3-person crew, and it was the first live TV downlink to ensure that not only communication, but also video could go back and forth between the Apollo astronauts and the actual mission control. Apollo 8 was the first manned flight around the moon. Now for this one, it's really interesting to note that James Lovell, who was the pilot, was not actually scheduled to do Apollo 8. He was scheduled to be on Apollo 11, and Michael Collins was scheduled to be on Apollo 8. James Lovell was supposed to be the one on Apollo 11 who never would go down to the moon, but would actually stay in orbit, the role Michael Collins ended up having. But Michael Collins had emergency neck surgery, so he wasn't able to do Apollo 8. So James Lovell was moved up to Apollo 8, and he was backup for Apollo 11. We'll talk about that momentarily. The Saturn rocket performed admirably, even though the previous 2 versions of the Saturn V had actually had problems. This Saturn V went beautifully. The flight to the moon, the duration was 6 days, 3 hours, 42 seconds to obtain 10 orbits around the moon, including they did a reading of Genesis on Christmas Eve. And that reading of Genesis was chosen because Genesis was considered to be the excerpt from the Testament that would actually be closest for most major religions around the world, so that everyone watching and everybody listening would feel a connection to the mission itself. One of the things from Apollo 8 is actually Bill Anders convinced James Lovell to let him bring along his camera with a telephoto lens so that he could take pictures. Because James Lovell was simply adamant about going through and marking territory and using the maps and really just observing as much as he could. And he didn't see the use initially of taking pictures. But that iconic picture that was shared earlier of the first Earthrise is one of the ones that we actually remember from the Apollo 8 mission. Now, I have some schematics here for Apollo 8, but I'm going to move past those. The first view of Earthrise was actually taken by the Lunar Orbiter 1. But then this one was taken by Apollo 8. It was the first humans to witness the rising of the Earth. Now, I just want to mention to you something James Lovell said in his interview with David Eicher and Richard Trotter in Astronomy magazine. He said, you know how when we go out at night and we see the moon, we can block the moon with our thumb. And we can do this during an eclipse, or we can block the sun with our thumb if we're wearing the safe eclipse glasses, because if you're not wearing the eclipse glasses, don't look directly at the sun. Well, James Lovell said that at one point he reached out with his thumb to block the Earth, and it occurred to him that every single human and every achievement was behind his thumb. Everything anybody knew was all hidden by his thumb, and everything behind him was unknown. And that moment to him kind of captured that real perspective of how small we are in the entire scope of the solar system, let alone the universe. These days we get amazing resolution Earthrise. And anybody who hasn't seen it, I encourage you to watch the YouTube from the Japanese Kaiyuga spacecraft. This is now 14 years old, but it's still breathtaking to see the Earth rise with this zero atmospheric distortion over a high res shot of the moon surface. Now, as the Apollo 8 went around, they were trying to identify markers to use for navigating that first landing, which they knew was coming up. They weren't ready for the first landing yet, but it was coming up. Apollo 8 was actually originally considered to be the mission to test out the lunar module in Earth orbit, but the lunar module wasn't ready yet. So instead, they ended up being the first to go all the way out to the moon. So Jim Lovell and Bill Anders, they didn't want to lose this opportunity. So they were taking pictures of as much of the terrain, as much of the surface as they could. And they saw this little triangular region, which was a mountainous region on the edge of the Sea of Tranquility, which they felt would be useful for navigation. And when they looked at all their charts, it had no name. So then Jim Lovell named it after his wife, and he started calling it Mount Marilyn. And that name stuck throughout the Apollo program and all of the NASA documentation, but the IAU refused to give that name until 2017, when they finally named that structure Mount Marilyn. Now, this is important because only 30 craters of the 1,600 craters on the moon are named after women. So to name a mountain after a woman was actually an incredibly rare event for our moon. This is the side view of Mount Marilyn, which was used by Neil Armstrong to navigate the Eagle as he landed it on the Apollo 11 mission. Apollo 9 was the first testing of the lunar module piloting in low Earth orbit, and they tested out coming in and out of the lunar module and ensuring that all of the systems were a go. Apollo 10 was a mission to test out landing without actually landing. So they went all the way to the moon. The lunar module was released. That's called Snoopy. And it went all the way down towards the surface, then came back and reattached, but it didn't actually land. Snoopy was then released. And very recently, starting in about 2007, there was an effort made in the UK by Tom Hawes, I believe, to try to identify Snoopy in its solar orbit. And they believe they've identified it, but we have to wait now another 13 years before it passes close enough to Earth for us to see if that object that they see is actually Snoopy, the Apollo 10 lunar module. The Apollo 10 debrief, you can see many, many famous people in here. You can see Jim Lovell, you can see Neil Armstrong, you can see Buzz Aldrin. I mean, this is a capture shot of really walking through exactly what was going to happen when they get to the moon. Now, Apollo 11, we have the crew, and then we have the backup crew. Michael Collins was happy to be the command module pilot, even though it meant that he would never actually land on the moon, because he thought at some point he would get a chance to go back, but he never did. One of the sides of the Apollo 11 mission, which Gavin referred to, was the actual scientific setups that were begun. There was a solar-powered seismograph that was plugged in. There was a reflector dish that was plugged in so that we can actually at any point accurately determine the distance between the Earth and the moon. And then the ascent of the lunar module coming up was actually captured by Michael Collins. Apollo 12 was a mission that was able to go and not only explore the ocean of storms, but also be able to examine some of the previous orbit or some of the previous landers that the US had sent, including the Surveyor missions. Now, Apollo 13 was meant to be the first full scientific mission. But as we know, Apollo 13, just after it had started moving towards the moon, there was a loud sound. And that loud sound was an explosion that happened 200,000 miles away from Earth. And that explosion was absolutely terrifying to everyone on Earth, finding out and realizing that there was a ruptured oxygen tank and that they would no longer be able to potentially even return. But much to the credit of the crew of Apollo 13, they kept their calm. they went overtime, the scientists here on Earth, trying to determine a way in which they would be able to come back. And what they were able to do is speed up the Apollo 13 module to have it go around the moon faster so that it would be able to get back with a small course correction and return to Earth. But in order to do so, they had to spend 4 days for 3 individuals in their actual command module. Now that command module was not meant to have more than 2 people for a couple of days maximum, the lunar module area. Sorry, not the command module, the lunar module. And so they didn't have enough oxygen, so they had to work out a way to bring oxygen in from another part of the actual Apollo 13 unit. But what was really devastating was they had no way to filter out the carbon dioxide. So they were going to be poisoned if nothing could be figured out. So with duct tape, cardboard, and an old sock, they worked out a filtering unit that was able to keep them from being poisoned by their own carbon dioxide to allow them to make their way all the way back. Now, once they released the actual module, you could see the ruptured oxygen tank in the pictures that they took. So you can see that tank, and it is incredible that this didn't actually cause the entire mission to be a disaster, that they actually made it back. And even here on Earth, amateur astronomers were able to see the oxygen cloud coming out of the Apollo 13 spacecraft. It's just incredible that they made it back, that they were able to survive, and that they were able to actually live to tell the tale. Apollo 14 took over the actual plan that Apollo 13 had, and they did the scientific mission on the moon, including regolith and lunar rock sampling that brought us up to a much higher degree of variety in the types of rock that were being sampled. So 382 kilograms of basalt breccia rock samples were all brought back, but not all of them are even open now. Some of them are still locked away under vacuum sealed canisters, because as technology advances, these samples can be actually investigated with better tools to learn more about them. And so there's specific sets of samples that are at a time being opened and being analyzed in labs across the US. Apollo 15, 16, and 17 were the ones that had the rovers that allowed them to really enhance their range and what they were able to investigate on the moon. There's a lot to be said about all of these, but I just actually want to come back to Apollo 16 briefly to tell you one last story before I wrap up. Some of you have heard the story of the wedding ring for Ken Mattingly. Ken Mattingly got married just before the Apollo 16 mission. And as they were heading out towards the moon, he lost his ring. Now, you might think, how does he lose his ring? Well, back then, they hadn't worked out a way for astronauts to safely go to the bathroom. And so they actually had to strip off their entire spacesuit in order to go to the bathroom and then put it all back on. And because he was newly married, his ring fit wasn't very good and it came off. And they searched the module and they could not find it. And then on their way back, just before they re-entered Earth's atmosphere, they did a spacewalk, and Ken Mattingly was the one who did the spacewalk. And so as he was out doing the spacewalk, Charles Duke was going out to be the second and then to bring him back in. And they were going to get one of the devices off of the command module before they actually separate off the two units. As he's walking towards the door and the opening into space, he sees the ring floating around. So he reaches out for it, but he can't quite get it. And the ring is floating out into space. And it bounces off the back of Mattingly's helmet right back into the actual Apollo 16 module. And Duke catches it and is able to give it back to Mattingly. So he's able to actually come back with his ring safe and sound. That's one of those stories that makes you just realize that there's a level of unknown that just leaves you in wonder. Apollo 17 ended with a plaque placed on the moon. Here man completed his first explorations of the moon, December 1972. May the spirit of peace in which we came be reflected in the lives of all mankind. In crewed missions to space exploration, we've had the Mercury, the Gemini, and the Apollo missions. Since then, we had Skylab. We had a joint one with the Soviet Union. We used our space shuttles throughout the atmosphere and through low Earth orbit. We set up the International Space Station, which is still ongoing. We now have private enterprise entering into space, and we are currently working on a program to bring humans back to the moon again. And with that, I thank you for your attention, and let's chat.
Wonderful, wonderful. There were, just as Gavin transitioned to you, Karim, there were some questions directly to Gavin.
Sure.
And
Is he here still?
I'm not sure.
Yep, there he is.
Oh, there he is.
Gavin, how are you, man? So there was one of the questions was what's new on your horizon?
Oh, what's new? On top of defending, I would say from our presentation, I'm actually planning to look at quite a few Apollo samples that are believed to have formed from impact craters that we actually obtained before the pandemic started. And originally, we're planning to analyze them in 2020, but since that all fell through, we've now had to delay it to the coming fall term. So that's the next step for me.
Mm-hmm. Great. I'm kind of scrolling through here as we've had a lot of comments. Do you see another one there?
Yeah, there was one for are those moon pictures yours?
No. I got all those from the Lunar and Planetary Institute higher education database.
And then another one was reminds me of the, oh dear, how do you pronounce that? Astroblem? Astroblem. Okay. In the Trans-Pecos region of Southwest Texas. Did you examine the shocked minerals in that area before?
I have never been to that region in Texas before, but anywhere with the shocked minerals, to be honest, I would definitely want to go visit in the field.
Oh.
Yeah, I think we lost Gavin there.
Gavin, I think we lost you there for a moment. We were able to hear that at least you have done field work before. Oh, hello, you're back.
No, I
He's being attacked by the bandwidth monster.
That's right. The Goonies of the internet are out there to get us. Well, okay. Let me look for any kind of questions for Karim. That was, by the way, Karim, that was a great overview of the Apollo program.
Thanks, Scott.
Yes, I'm so excited for the Artemis program too. All of us here at NASA Goddard are just so crazy busy with planning for Artemis and getting all planned and figured out. So
we hosted a talk back in October about the Lunar Gateway and the role of the hopeful Canadarm3 that's going to be able to move around. Oh, it's just gorgeous. I can't wait to see those robotics in play.
It's gonna be great.
Well, I don't
Here's a
see.
question. Have all
Go
of
ahead.
the landing spots for the Artemis project been picked out yet, or are we still figuring those out?
We are still figuring those out. So it's interesting is that there's also a lot of robotic lunar rover missions starting at the end of this year, well into 2023. And so obviously we would already have our landing sites for the ones launching in November 2021. But there are a few that have at least narrowed down their landing sites. Most of them are to the lunar South Pole, because that's where we would want our Artemis 2 is going to be our next crewed mission. Artemis 1 is going to be kind of like our test, our dress rehearsal, if you will. It'll be uncrewed.
I'm kind of
Okay.
hoping that the Changi 4 data is eventually shared with us so that we can learn a little bit more about the far side and what China's discovering there with their rover.
Absolutely, absolutely. So far, within just honestly the past 2 weeks, the Journal of Geophysical Research has published like a boom of Changi 4 and Changi 5 papers. So
Fantastic.
those are interesting to read.
Here's a question. What is the criteria for a landing spot? What do you look for to make a decision?
So one of the things to note is that the Apollo missions, it was very much human controlled landing. So it was joystick landing, trying to find the safest spots to land. And so the pilots had been trained and they worked through all the, most of them were fighter test pilots, but the lunar module was a different type of a beast. Right now with the Artemis program, we now have proof with Perseverance that guided landing with feedback and AI to actually explore and analyze the surface before the landing is committed to is all feasible now, right? Even the sky cranes, everything that we used in Mars, if we can find a way to slow them down enough, it's feasible. And since the moon isn't quite as far away, we can slow them down even with propulsion. Whereas with Mars, you want to limit the amount of mass that you take with you. So you wanted to use the atmosphere of Mars as best as you could to try to just slow down and catch as much drag as you could. So I think the answer to what determines a safe landing spot has changed now in this age compared to what it was in the 60s and 70s.
Well, I'd still imagine that there'd be some sort of emergency human override possible. If you've got a crewed mission, you use the best of both worlds. You can nail it down, but I could see if there's a glitch or an emergency, I could see, Neil Armstrong like kind of taking over and saying, okay, we're gonna go in manually, kind of like we do with I think airplanes today. Everything's just about automated. The plane can land itself, but there are cases where, of course, there's wind where there's no wind on the moon, so that sort of thing isn't going to happen. But I could still see a manual override switch just in case.
Are you worried about a HAL type of setup?
No. I guess we'll see how it goes when we're actually there, being able to pinpoint landing sites and making sure they're not ginormous rocks as they're coming down. I remember part of what Armstrong and some of the other landers did was make sure they didn't land on a bed of rocks. And so my guess is that sites would be safer sites with all the data that we're getting with the moon. I would imagine safer sites are being picked to where there would be much less need of, an emergency change in order to land, not land on a bunch of rocks.
But
I have a 3D
right?
moon just like that.
Exactly. And with the Lunar Reconnaissance Orbiter, we now have a 3D map of almost every spot on the moon. And so it's not just a case of what we can see with our telescope on the near side of the moon to try to determine the best locations, which is what they did with the Apollo missions. We now have the Lunar Reconnaissance Orbiter there still analyzing and mapping everything constantly, right? So we have that advantage.
It's down to seeing where all of those rocks are now and not having any surprises when we get to the lunar surface.
I was reading the story of when Neil went, so when Buzz was putting out one of the pieces of scientific equipment, Neil actually had a moment to himself. And so he went over to a nearby crater that he had bypassed when he was landing Eagle that had looked to him to be too treacherous to go anywhere near. So he had moved away from it. And that was the original planned landing spot. So he went back to it. and he saw that the sides looked like the side of like one of those dirt hills back where he was with his family and where he had been with his daughter who had passed away. And so according to the story that Hansen shared, Neil sat there and said, I felt like just sliding down like a kid just because I know my daughter would have wanted me to. But then I thought, what if I can't get back up without Buzz's help? And what if it sacrifices some of the outcomes of the mission? He was very practical. Like everything he did was, this needs to be done. Let's do this. And this was the first moment that he just kind of stopped and just thought. And so now, was this really what he thought? Because he was such a quiet man. And when you read his interviews and when you see how much he actually shared, it's hard to believe that he shared that much more with a couple of individuals who are telling the stories. But one of our local members, Pete, or actually one of our RASC Montreal members, Pete, who's in the UK, he knew Neil and his brother, and he said that a lot of it really was Neil. He just didn't see a reason to open up to the media. So he'd open up to individuals he got to know, but he wouldn't open up to the media with answers. So according to James, that was what went through his mind. I would have
Very
loved to hear the story of him sliding down a crater.
Yeah, of course, rupturing anything on that suit might have been a bit of an issue as well.
Yes.
So I imagine he would have to consider, so if I break something on the way down as well. Although that it probably looked soft enough to safely slide down. I saw some of the footage they had on YouTube. I think it was it may have been Aldrin tripping and falling, and with all the dust that was kind of clinging to his spacesuit. I think, Neil, you all right? I'm fine. And he gets back up. So
they have those videos from the rover where they're getting out of the rover and they slip and fall, and then they they make TikTok and Vines out of it. It's awful.
Never mind what happens to the actual footage of itself is was definitely worth watching. I remember falling asleep to the first landing footage, and I remember them going out gathering rocks. They had data on the vitals of the astronauts. I remember seeing the astronauts returning to the lunar lander and finishing their day. And I think Aldrin was like the first to go up, and then Armstrong came along. And they reported everybody had great vitals, everyone was in good health, and it was quite an accomplishment. Just not only the landing, but the entire first day that I remember seeing. I obviously have a lot more footage to go through if I want to watch it all, but still just inspiring for myself.
You should be able to finish just in time for the Artemis program to start sending us some videos as well.
Well, that would be end of year, so I have till the end of the year. Is that it, Caitlin, or even sooner?
Oh boy,
Are we putting you on the spot, Caitlin?
Well, unintentionally.
I love the chat about Artemis, and Lunar Reconnaissance Orbiter is such a gorgeous mission. Really give us a lot of data. We're still going through the data. The exciting part was the Lunar Reconnaissance Orbiter was able to make a slight maneuver change just so then they can get the lunar eclipse that happened not too long ago and get data off of that. So that's been really exciting. We haven't gone through the data yet, but I'm on the Diviner Science team, and we're all excited about it.
So does this mean my dream of a picture of what the eclipse looks like from the vantage point of the moon with the sun, with the Earth blocking the sun, might soon be realized? That's a picture I would love to take if I could, but I've heard that there are reasons the lunar orbiter couldn't take that picture due to I don't know what all the reasons were, but my dream picture I would love to see is from the moon's vantage point, what that looks like.
Oh, for sure. I think they weren't able to do like a complete eclipse moment though, but just to get the thermal variations though. But I don't know what the camera team did either. So
Okay.
we're still
Yeah.
just kind of going through the motions of, hey, look, there's data. What do we do now?
Yeah, I had heard that during one of the eclipses, I think 2017, I had heard that the lunar orbiter shut down because of the temperature. Once the shadow, I guess, Earth's shadow hits the moon, and it's, you know, the red from all of the sunsets all over the Earth that I've heard of, supposedly is hitting the moon, but the temperature at that point is so low that the lunar reconnaissance orbiter wouldn't be able to operate properly. At least that's what I remember reading or hearing. So my question is, what's the truth in all of that? And for now, are they having to shut down that orbiter whenever there is a total lunar eclipse?
Oh, I think it depends upon what part of the orbit are they going to be in. It's all in the geometry too, though. So if it misses the eclipse, then it misses the eclipse. This one was just at a great angle where it was grazing. And so it wouldn't have affected any like burning the eyes of the orbiter.
Hey, before we get too far into our program, I promised that we'd try to show some live views through a telescope. And so Jerry Hubble right now has the moon in his telescope that he can share with us for a couple of minutes before we go to a 10-minute break. And then we're going to come back to Caitlin Ahrens, where she can give a little bit more of her presentation, and we can ask her some more questions. So we're going to, Jerry, are you ready?
Yep, I'm ready.
Okay.
Let me, I'm going to bring you to the observatory desktop and to see the live image of the moon. And then I'll quickly share another picture I have. Do you see that?
Yes, we can.
That's a live image, and I've got the virtual moon atlas up also to show you the different craters that we're showing on the image. The bright one there, of course, is Tycho. And then we have some interesting craters down here. I guess it's pronounced Haensel, is right here. I don't know if you can see my arrow there. It is right there. And then the crater on the map is here, Haensel. And then you've got Schiller, which is this really long crater here. It's really an interesting crater to look at. But this, the telescope is set up for deep sky imaging, and I like to do full lunar images and stack them and get really pretty high resolution images with full disk. The focal length is not, suitable for getting really close up, but you can see how steady the sky is right now from this single frame. This is just a single frame. So the sky in my location is really, if there's some high haze, that's what helps to make it steady. And also this time of year is the greatest time the best time for doing this type of imaging, any kind of deep sky imaging too, although the transparency isn't good. The seeing is very good. So I want to also show real quick this other image that I did. This is a stack actually of the images that I did last year. Let's see, that just went away on me. I think I'm gonna have to skip that because it just failed on me for some reason.
It's not good. And by the way, you notice my virtual background. I felt left out. Everyone else had moons in their virtual background, so I threw one in mine. So I had to change.
It is all about the moon and Mars. but this program is about great leaps, and there's I think some of the greatest leaps are humanity's will to get things done. Some of the things not too long ago would have been considered absolutely impossible. So it is. I'm always stunned when I think of what has happened over the decades, just in my own lifetime, and certainly remembering my grandmother talking about people, seeing her grandmother and grandfather in horse and buggy days. So it is our technology and rate of discovery is really stunning. So, and it's been said many times by a lot of different people, but we are in the golden age of space exploration and astronomy right now. So, great time to be alive. I will segue into an intermission. We got a 5-minute countdown, then we got about a 5-minute little video about Apollo 14, and we will be back with Caitlin here in about 10 minutes. Jerry, thank you very much.
Sure, thank you.
And for you in the audience, thanks for all your participation so far. I asked the audience which of them would go on a one-way trip to Mars, and actually several people answered that they would do it. So the desire of people to explore is very strong.
The answer to that question of Artemis 1 having cameras and instruments, yes, absolutely.
Hey, Maxie, you doing well?
Hey, what's up, Karim? Excellent presentation.
I had a question for you. What's your latitude?
My latitude is 34 degrees.
34? Okay.
34, yes. And in longitude is 60. But my city is in 60 longitude.
Okay. No, we're looking at, we're hoping to do an event in September with a club in New Zealand, and they're at 45 degrees latitude south, and our club is 45 latitude north. And so we're looking at showing some of the circumpolar in our region that the others could never see.
Yes.
Right. So for you, you have, other than the Southern Cross and a couple of, what's your favorite circumpolar in the south that you love looking at?
Well, obviously the region of Carina.
Yeah.
But also the Magellanic clouds.
Yeah.
Magellanic clouds.
Those are beautiful.
If I had to say in Spanish, it's very easy to me. Magallánico.
How do you say it in Spanish? Magellanic clouds.
Well, the name was Magallanes.
Okay.
So the clouds are las nubes de Magallanes. The Magallanes clouds. Very shortly.
I need to learn that.
That works perfect. You don't have to change the name for us. We're happy with it.
Right.
Oh, okay.
It's similar enough to how it's pronounced in English, Magellanic.
Magallanes. Well,
Magallanes. So,
there are 12. That's in Spanish from Spain. It pronounces like with how to say it. The rain, lluvia.
Okay.
Here in Argentina we say lluvia, like a S and an H.
okay.
Lluvia. It's very
Yeah, language.
the differences of the
Well,
language.
my wife and my son both speak some Spanish, and so I love every now and then when they just decide to chat in Spanish. I just sit back and listen. I don't get any of it, but I just enjoy.
I think it's very easy, but we have some words similar. So basically, I think everyone can learn it. And I remember.
Oh, I'll have to in a couple of years when I come to visit. I'm going to learn as much as I can.
You're going to be an Argentinian.
That has become my most important life's goal.
On the lunar surface, you have the ability to gather samples that can tell us so much about the origins of our solar system, and the samples returned gave us that information. That was what Apollo 14 did that was so trailblazing.
Looks good here, flight. Good agreement. Man, we better back off here and think about this one, Houston. Roger.
They continue to believe that this mission might never get started, and Mission Control was pretty convinced it wouldn't either. First attempt, dock, couldn't get a hard dock. Second attempt, third attempt, fourth attempt, fifth, and a sixth attempt. 2 hours. But it's that spirit in Mission Control, in the crew, the faith and the confidence in their training, and they're able to work together as a team to get that mission going.
I got a hard dock, Houston. Roger, Al, that's great. Super job, Stu. This is really a wild place up here.
In the aftermath of Apollo 13, nothing was taken for granted. It took a lot of work back home to really reprogram that software, to really understand what had happened there.
We're on the surface. Okay, we made a good landing. That was a beautiful one. We landed the slope, but other than that, we're in great shape. Yeah, right on the landing site. Looks like you're about on the bottom step and on the surface. That's bad for it, old man. Halo's on the surface, and it's been a long way, but we're here.
Apollo 14 was an incredibly ambitious scientific mission. One of the things they had with them that was incredibly important was something called the Met, or the rickshaw. Basically a cart intended to carry both those scientific experiments, those payloads, but also to return those lunar samples. And so that allowed that crew to travel further from the lander than any crew had previously.
We're really going up a pretty steep slope here. We got a ways to go yet.
Like any good navigator, the astronauts brought with them the maps that they needed. But there was a problem with these maps. These maps had been shot from the air, and on the ground, that lunar landscape looked quite a bit different.
Nothing like being up to your armpits in lunar dust.
They found themselves in valleys that were deeper than they thought. They found themselves working up hills that were higher. This was an exploration at its finest.
We're going to try a little sand trap shot here. That looks like a slice to me, Al. Here we go. And one more.
The samples returned from Apollo 14 were incredibly important. They told us so much about the formation of the solar system, so much about the material that makes up the moon.
Okay, shall do a loop. Okay, make it smooth. And around we go. Go through style.
The return trip to Earth was a time to rest, a time to reflect, but also a time to continue science. A major portion of that journey home was conducting microgravity science, something that today we do on the International Space Station every day. That was a new way to think about what would the value of space be. Apollo 14 achieved all the science that it had hoped to achieve, and it pressed the boundaries of space exploration in ways that future crews would build upon. And as we prepare to go back to the moon, we definitely follow in the footsteps of these brave crews that went before us and build upon the scientific information that they returned.
Well, we're back. I hope that that little break was, you were able to get refreshed there a little bit. We have much more to come here, starting with Caitlin Ahrens. Caitlin received her Bachelor of Science degree in Physics and Astrophysics and Geology from West Virginia University in 2015, and she got a PhD in Planetary Science at the University of Arkansas in 2020. She's currently at Goddard Space Flight Center doing a postdoc there, and she is working on applying the LRO diviner data with a myriad of other remote sensing data to investigate the volatiles of the lunar surface. So, Caitlin, I'm going to turn it back over to you. You are, it seems that you are also neck deep in lunar dust as well. So,
yeah, for sure. And it's not just the lunar either, though. So I do all sorts of stuff all across the solar system. Just last week, I was doing some Mars work. Gavin and I are actually going to be doing some Io, the Jovian moon data in a couple months, which is exciting. I have a fabulous intern this summer who's doing some Ceres asteroid work. So I'm all over the place. And I still dabble in Pluto. For those of you who knew me before, I used to do a lot of New Horizons data on Pluto. So now my main job, though, is certainly on the moon. So I don't have much of a giant presentation for you fine folks tonight, or this morning, whatever time zone that you may be listening in on right now. Hey, why not? But there are ways for you fine folks of this planet Earth to actually have fun with lunar data and lunar maps as well, and just some really fun lunar images as well. So I'm going to share that screen. So we're going to start with this one. So this is obviously the Astronomical League. So there are several observing programs on their website. I like to particularly go through the alphabetical, and they have numerous programs here. So many programs, and they keep adding them nearly every year, it seems like. I can barely keep track of them anymore. But if you want to really hone in on your observing skills for the moon, I personally have done the lunar observing program part 1. There's also a part 2. I haven't done that one yet. And then fairly recently is the lunar evolution observing program. So if you're not familiar with these observing programs with the Astronomical League, they would give you a set of challenges, and I can use this one as an example. But you would be given a set of challenges, whether some of them are through binoculars or some of them through your naked eye or a telescope, but you would essentially have some sort of list, observing list to go through and check off, like date and time, what was your transparency of seeing, and so on and so forth. Some of these observing programs, you do need a camera of some sort. Some of them have sketching. I'm currently finishing up the meteor observing program here. It's a really fun program. For any youngsters out there, there's Sky Puppy. That's also a really good one as well. So definitely encourage all of you fine folks out there to just kind of have fun with all these observing programs. Onward to the next one. So I'm actually helping our main editor, Brian, on this fantastic little adventure here, the Encyclopedia of Lunar Science. Who'd have thought that I'd be involved with an encyclopedia, but it is a huge undertaking, to say the least, but it will be updated fairly soon. But there are some stuff already freely available to read on the site here. So this is through Springer, the Encyclopedia of Lunar Science. Hopefully we're going to get done by the end of this year. 2020 unfortunately delayed us quite a bit. So at least early 2022 should be okay. Now, the next one, the Lunar and Planetary Institute. Fantastic website. You get all the Artemis reports going on, different kinds of workshops. This is a workshop that they're sponsoring right now called Brains Across the Solar System. All sorts of news, all the updates with the Venus mission going on. Fantastic. But what's neat, they have educational resources and whatnot, but going through their lunar science and exploration, you can actually go through a lot of the original Apollo image atlases, all the really pretty panoramas. My favorite, though, is the Lunar Sample Atlas. So all the different kinds of meteorite samples that have been collected through Apollo. It just goes on for pages and pages and pages and pages. Oh, to the point where my computer can't even keep up with the download. Let's see. So I'm just going to pick a random one. So let's just say Apollo 15, and I just pick a random sample. So here's the site of which it was collected. Maybe some up close pictures. That one wasn't really that pretty though. There's some really pretty ones here and there. Some of them are like microscopic, thin sections with some of their images. But you can truly just spend hours and hours and hours through that website. So really pretty. Next one, LROC is the Lunar Reconnaissance Orbiter Camera, LROC. This is called Quick Map. All one word, Quick Map, LROC. That's all you have to Google. The first website that's going to bring you should be this. This is a really fun way to just explore the moon and with data that's been collected. Now, not all lunar data has been uploaded to this. It's a still fairly new program though, but if I wanted to do certain overlays like nomenclature, there we go. Let's get out of that. I want to go to the South Pole because that's where my main domain is. This is where I currently reside, is the lunar South Pole. So if I wanted to look at Kaguya maps, if we wanted to, look at plagioclase there, it's probably, well, it's not polar. I should have remembered that. Clementine though would work. There we go. You could change the coloring. Let's make it rainbow. Make it pretty. There we go. So all of the FEO abundance weight percentage there. So yep, all of this is entirely fun and free to use. You could do different kinds of geologic maps instead. If you wanted to see like where all the cool swirls are, we would need to go back to cylindrical view though. Swirls, where all the really pretty lunar swirls are. Yeah, basically over there. Let's get rid of the little pink stuff there. There is a swirl. Isn't that pretty? You can really go in deep with that. And at the bottom here, it gives you your latitude and longitude, your meters per pixel data from there as well. So really, really neat and interesting website that a lot of us lunar scientists also use for a quick reference too. When we're like, there was a really cool crater. Where is that located? And we use QuickMap as truly a quick reference on some really cool stuff. This is also another region I'm working on currently as well. So woohoo. The last thing I want to show you fine folks is the Apollo 11 in real time. The website here is apolloinrealtime.org/11. And what this does is that you can truly experience the entire Apollo 11 mission from T-minus 1 minute to launch. You could go to like, what is it currently doing it now, and you just follow it through the rest of its time. It is a fantastic, almost interactive documentary with the Apollo 11. Now, is the team trying to do other Apollo missions? Yes, in a sense, but this was a huge undertaking by a fantastic team from many different NASA centers as well. So, and mostly by Ben Feist as well. So highly recommend checking that out. It's really fun. Yeah, all right, and that's it. So some really fun ways to still play with lunar data. Don't think that like, oh, the lunar data is just for us scientists. No, you guys could join in the fun too. You know, who knows? So have fun with that. Unfortunately, I'm getting to a point where
into a pumpkin, right?
I'm going to be turning into an Apollo pumpkin here pretty soon. So, because we have a lunar conference this week, which means time zones, I have to wake up really early, unfortunately. So, but it was fantastic co-hosting and guest hosting it with you tonight. I hope I get to see everybody again very soon. Also, for those of you still listening, be sure to check back in tomorrow as well. Tomorrow is the 7 months of science, where Scott and I also host yet again. But this time at 8 p.m. Eastern, we will have Dr. Abel Mendez of Arecibo, Puerto Rico. And he's going to give us a fantastic talk on astrobiology and the search for life in the universe.
Wonderful. That'll be a very, very interesting presentation.
Yeah, awesome presentation. I remember I talked with you, Caitlin and Karim. You were talking about what we know about the lunar surface, and I'm seeing that as a prime example. Just the website you just shared, pretty much know everything about the lunar surface. And that where we were talking about directing landings. Well, I can see how you can do that with all the data that you've gathered. So that's definitely something worth looking at. So yeah, I appreciate the hosting. I need one of those shirts for outreach. I think that would be awesome. I'm gonna have to get one, but it'll probably be a full shirt. I don't know if I can do.
Got a dress, right?
I think we should get a dress.
And
yes.
you see I'm wearing a Michigan themed shirt. Of all the Apollo missions that I like, you could probably guess which one would be my favorite, that I would really need to do some more research on, because I don't want it to just be a favorite. I'd like to know a lot more about, it's things that it achieved. But Apollo 15, the all University of Michigan crew that went to that was on Apollo 15 and Hadley Rill, and I even try and point it out. whenever I do just take my pictures of the moon and look for that landing spot in particular. So I've taken it on as a project to learn more about that particular landing, since my alma mater has a huge part in that. So
I think
again,
you'll need
thank
to
you.
build. I think you'll need to build a rover model. It's the first lunar rover. You've got to build one.
All right.
Sorry, lunar buggy, not even a rover, a buggy.
A
Right?
buggy. There you
As
go.
a member of RASC, I have to accept the challenge because I just joined. I didn't realize what I was walking into here, but now I got, so I tried to do, and I don't know if you can see it, a drawing of what I saw out of the plane, Comet Hale Bob. That's my
Nice.
initial sketch of what I saw, because I wasn't taking pictures back then. Now I have to design a buggy. So I've got
There
my
you
work
go.
cut out for me.
You're going to be busy.
Yeah.
Wonderful.
Well,
Wonderful. Well, thank you very
all
much.
so much. It was great seeing all of you, and hope to have you tuned in tomorrow. Scott, I'll see you tomorrow as well.
All right.
Have a good morning, good night, good afternoon.
Thank you.
Bye,
Thank you
goodbye.
very much.
Excellent
Thank you.
presentation. Bye.
Great. Well, Maxie, we're going to have you take over. Cesar Brollo was supposed to be with us, but perhaps he's having internet issues or something. So, but we're always excited to see Maxie's images. And also, I know that you've been like staying up late because you've been taking images of planets and
Yes,
all the rest of it. So we'll have you.
I
Thank you for coming on for this little bit here to share
well,
some with us.
now is well, hello everybody. First of all, now we're at 12 o'clock here in Argentina. It's maybe a little late, but yesterday I I went to bed maybe 4:30 a.m. and wake up to work 7:30. So I only slept 3 hours.
Cool.
No, basically, because we are in planetary season, I will try to do some pictures of Saturn and obviously Jupiter, but I couldn't do too much because the results and the scene was very pretty, and I'm using right now a monochromatic camera. I'm not using the cell phone because I give it to my brother because he brought him. So I try to do some pictures with that. I'm still working on, but let me show you if I can find the files that I did with. Wait a minute. No, I think I deleted today. But no, because I don't like it. So
gone.
Yeah, no, but I'm sharing with some friends here. Well, let me download it and download this. Okay, I found some practice images. Well, let me show you my screen. Okay, do you see it?
Yes.
Well, basically, what I do is try to do some pictures in light red, green, and blue filters. And with the videos, I stack them and pass it by AutoStacker, Registax, and other programs to get some info. But it's very blur, the image. This is the derotation, and I don't like this. So the only image that maybe can work is this. You can see some two moons. I think it's Io and Europa. But when you do the sorry. No, eso está la preliminar. When you do the process, you can see the rotation of Jupiter.
yeah. Nice.
Maybe this is only 2 minutes in every video that I record, but it was well, he's in UTC. There was 3:40 a.m. This was almost 3:50, and then 10 minutes later, because I was taking videos in every channel, and I was practicing with the processing. But this was last night. I also did some Saturn. I only stack some images so I can get this. This was
nice.
earlier. This was stacking only the frames RGB. This was the monochromatic camera. This is IO, I think. But then more later, it comes these 2 moons. But this was getting zoomed with some 2 Brollo lens, 3x and 2x. So basically, this is what I did last night. I was fighting with the cold weather, but the weekend I tried to do some deep sky images, but also I did some pictures of obviously the moon, because it was a crescent moon here, well, obviously in every part of the world. But I wanted to do some a realistic moon when you see it through a telescope, not from a single image. So I took some pictures with a single. Well, you can see the shadow. You don't see it, but see the details and everything. This was taken in one over 1,250 seconds, but then I start to increase the speed. This is once about 125 seconds, then one about 10 seconds. Sorry, if you don't, if I don't express very well with the numbers of exposure.
Fine, Max. You're
yeah,
fine.
1/10 of a second on a camera. Yep.
Yeah, exactly. So trying to this time I get well, this green layer was the coma reductor because the shine of the moon reflects it. So but when I stagger this goes out. But in this case you start to see some stars in the image. If you have, there is another one. There is another one. Then I stacked it manually in Photoshop. So let me get, this is the TIFF image. Trying to get no a dark background, but try to give some info or details in the process, and also try to see the dark part.
Yeah, that's the Earth shine on the moon.
Yes, But well, this is how you see it with a telescope. When you are, if you have a Dobson, a refractor, a Maxwell, this is how you see it. So sometimes you take some pictures and you only see this part, and you see, oh, but I want to see all the ball, you know, and or try to capture all that. This is more without some thin details, you know. It doesn't very with a big structure, but it's more delicate. It's more like for a square to put it on the wall. But when I started to do some deep sky objects, I was pointing. No, I was obviously fighting with the collimation in the F4, like all the nights that I put it. So I tried to do some pictures of M8. This time I did 3 minutes pictures. See? This is, well, the Lagoon Nebula, obviously. But in 3 minutes, it isn't not the same like I did in 5 minutes, because you can see some stars, you can see the structure of the nebula. Obviously, it's very pinked, but not like the 5 minutes pictures, because the sky was very polluted. So basically, when I stacked it, I tried to do it very detailed in the process, so I can get this.
Wow, nice.
In this time, the clouds of the gas and the dust is really pop up of the image. And you know, in this case, the background, I leave it like this in this orange color, because I think this is the real color of the Milky Way. In some parts, when you see very yellow or browned, I think it's all of this. So maybe, obviously, I have the light pollution that gets me all of a lot of information. So when I process, I lost everything. But for doing this in my backyard, I think, okay, obviously I want to
pretty good.
get, yeah, I want to have a lot of information to work it, but also I have a singular camera and my Nikon D80. So then I take some almost 3 hours pictures, and then how I put all the equipment outside. I wondering what part of the sky I want to capture. So I in Stellarium searching some places, and then I found this. This was the NGC 6729. It was in Corona Australis. It's more in my region, like in yours, in northern skies. And I found it. I put it with the telescope. Well, this is when I start to capture. You can see the stars in this case, but here's a globular cluster. This region, honestly, I didn't know that exists, because you see only the stars, these few stars are shining, but there is some places there is no stars. They are like behind the stars. So when you process the image, and it's obviously stuck, this is
And where did you say you pointed?
Corona Australis.
Okay.
Now I'm going to Stellarium to show you what it is.
Okay.
And this is the region. This is not the smoke. This is gas and dust. Very very dark place. This is a reflective nebula. And in this place, it's like the Hubble Nebula, the Variant Nebula, is something like this, because this is the I read it that has the most nebular near from us, from the solar system, is in here, in this place. These stars are surrounded by these clouds that they are forming some new systems. And this place is almost 500 years, light years from us. And this global cluster really contrast with the rest of the place, you know. This is a beautiful place.
Yes.
That is, I love that. That's
It's really
awesome,
great.
Maxi.
Yeah.
That just being a really,
Well done.
I love that little nebula that's almost like a Hubble's variable nebula down there.
Mhm.
Really,
Yes,
really nice.
that nebula, yes. It's in Monoceros, that nebula, I think.
Yeah, yeah. Really neat. I love the variety.
Well, this is a stellarium, you know. There is the north. Let me put some, what?
I think we have to, because we can't see your stellarium. It's probably in full screen. You have to exit
Yes.
full screen for whatever reason.
Okay,
Then
okay.
now we can see it.
You can see it?
Yes.
Okay. Well, this is Cygnus, the constellation El Cisne. This is my north.
Yes.
Above Cygnus, I have
yeah.
Altair.
Now you know why we get lost when we go down to the southern hemisphere. So
Yeah, we expect the Dipper in that spot. Instead,
Yes,
you've got
we
Vega. We expect that to be the Little Dipper, but it's Vega, it's Lyra the harp instead. So yeah,
You know,
I'm in
it's
for
above here.
and so interesting. You can see M13 on the horizon, but then somewhere wherever Centaurus is, you see that cluster, and you can compare just how diminutive M13 is compared to Omega Centauri. All we
Yeah.
get is M13, so it's our largest.
Well, this is my southern sky, and obviously here's the octante, the octans, the constellation of the octans, and in this place is where I got to get my polar line with some, I think this is no, well, some kind of these stars, and everything is passing by through this. You can see, well, the geographical south is not the same like the polar. Celestial polar is not the same. So everything is going around this, like this. And obviously here's the Magellanic cloud, the big one, and up here is the small with the global cluster 47 Tucana. But the place that I took in Corona Australis to get more.
We're still frozen on the other on the north.
Mm-hmm.
Oh, sorry.
So I think
now.
Yeah.
No.
Where are we?
You have seen
So
the moon?
it shows.
No,
we don't see the moon here. Yeah, I think if you escape the full screen for Stellarium, yeah, there's the moon. Now we see the moon. We see Lupus, M23, Herschel 36.
Okay, you see Hercules.
We see the. We don't see Hercules being upside down to what we're used to seeing.
Ah, yes. Right there.
Or at least in the north.
No, well, you're seeing I'm moving the sky now.
No, I think it's because it's full screen. If you go into a windowed mode, then we'll be able to follow along. I had the problem presenting with Stellarium where it wouldn't move. But then I exited full screen and then everything caught up.
Let me see if I can fix it because it's a interesting part, I think.
Yeah, I'd have to change my latitude and longitude in my Stellarium to match what you're seeing, and see all of the things from the south that I wish I could see, but would have to look through the earth in order to see them. You think Explore Scientific could design something that allows us to just look straight through the earth? Yeah, put that on the.
You can develop it right now. You know, when we get
Yeah.
to the beta test version, I'll send you one, and you can
I'll be happy to beta test that for you.
Yeah.
If I don't see crux, then I'll report that there are some problems.
There's a problem.
Couple of issues.
Okay, now I think. Well, let me.
Let's see.
This is the background again, I think.
Yeah.
No?
So
well, maybe if I only share Stellarium now.
Okay, so we can see the entire. Let's see. Yeah, the south.
The moon?
We're seeing the moon. We're seeing the south. What we call south.
Southwest.
West. Yep.
The southwest. El
Southwest.
oeste. Yes.
Yep.
You see the moon and now Scorpius.
Yes,
right?
we see. Yep, we see. It's in widescreen mode for us. It's showing a field of view. It's showing a wide field of view for us right now.
Oh no! So I think it's
I'm
very.
thinking
we have to give Maxi some slack. He's only had 3 hours of sleep.
That's true. Yeah. I have Stellarium, but mine of course is based in the north, so all the constellations are all different. I've got all the northern ones, and the summer triangle for us is so low on your horizon, but it's through where the Milky Way goes through. So it's the winter triangle for you all. But it's always a joy to see that, just knowing that the sky, there's so much in the sky, and it's a little different from the hemispheres. We only get to share a couple of the constellations that are hovering around the ecliptic, and we sometimes, like I said, hopefully Explore Scientific will get those goggles so you can just see right through the earth to the southern hemisphere, and we'd get to see it. But beautiful photo, beautiful image. It gives me
this passing by all nights long above my head,
Yeah.
because Corona Australis is very near from Scorpius, and Sagittarius is a region very near in the Milky Way, and passing by through my head all night. And that's why I went more later of MH, because I had in 40 degrees, but in this case, the Corona Australis was in 60. So the light pollution, it doesn't affect me too much in that altitude.
Yeah, it's probably a very tough target for us.
Yes, maybe
Northern
very
hemisphere, because it's so low to our horizon.
Exactly, very
I'm trying to think of what that globular cluster name is. It's
well. Let me.
M22.
No. No. Wait.
Okay, so it's nowhere near.
I'm searching in my mobile. Here's the moon. Corona Australis. Acá. And no, this wasn't.
Probably an NGC object if it's so low. All the messier objects were Northern Hemisphere named.
NGC 6723.
Okay. I think that's one we can see up here. But it has to be at the exact right time. Like most objects that are.
Well, I have Andromeda only 4 hours.
Yeah. We have Andromeda for 7 months. It's near Cassiopeia, which is near, it's circumpolar for us. So Andromeda only disappears when Cassiopeia rakes very low to the ground and is on the horizon, and that probably it coincides with when you see it in the southern hemispheres, when it drops out of sight for us.
Yeah.
But we wait a few hours and it just rolls back up again. So we image it a lot up here.
Well, basically, I think this is my presentation. Well, obviously today is not now in Argentina, but because we are in the 21st of July. But today, obviously, is the anniversary of the moon landing of the Apollo 11. But also is in Argentina for this date, this historical date. We celebrate the Friendship Day. You know, this night with because obviously the pandemic situation, we can't meet together with our friends to celebrate this day like friends. This is some in this region, maybe in some another countries, maybe not. But here in Argentina, it's very to have a friend is like a brother. Maybe obviously in every part of the world, but we have this day to celebrate because it was in the same year of the Apollo arriving on the moon, and odontologists proposed to celebrate the Friendship Day in the same day like the man landed on the moon, to celebrate the humanistic and the friendship of everyone in this particular day.
Very nice.
So
Very nice.
basically, maybe you don't celebrate, but I have to say it because I want to have a happy Friendship Day or Friends Day to everyone.
Happy Friendship Day, definitely.
Happy Friendship Day, Maxi.
Feliz Día del Amigo, Maxi.
Feliz día, Cesar.
All right, Cesar.
Okay, I give the posta to Cesar and leave it with him. So thank you again, obviously, to invite me and to be part of the GSP. I tried to watch it very early, but I had some things to do. So when I was dinner, I was hearing everyone. So excellence, everyone, and well, I'm still here for a little while.
Okay, thank you, Maxi. Thank you very much. Cesar, why don't we, I know that you got the moon live in your telescope. Why don't you give us a couple of minutes on your live movement image, and then we will transition directly over to Cameron, Adrian, Bradley, and then we have Chuck Allen, who's waiting in the background there to give a presentation for the Astronomical League. So, are you there, Cesar?
Yes,
There we
Scott.
go.
Hi, how are you?
Good.
Well, just tonight was a nightmare with the connection, with all the connections, but I'm happy because all work in a way as Sherry Hubble Lab that is all for the system of the connection for the new one. Who's the name? The new part of the software, the new firmware that resolve everything. But when you start to connect everything again and make to things work again.
Yes.
Come on, I made everything I made with mistakes, but me, not the firmware. And when I started to connect again, but this one now works like a small observatory. And well, tonight we have a little of wind in Buenos Aires, not a little. Shake. That say Cameron that say yes. Cameron said that I am 100 miles per hour because it's yes. The wind came with me every time, and I try to share my screen because it's the screen of the computer outside, and if you agree, Scott, I don't know, but only a few seconds of moon in my screen is okay, or do you prefer that I show you this later?
No. Let's see.
Okay, I have it.
Let's show a little bit, and then we'll transfer
okay.
to Cameron.
I tried. Yes, I tried.
Yeah.
You can see?
I think so.
We see it coming up. There we go. There's the moon.
All right. Yay. Nice.
Yeah, very shocking moon.
Yes.
We see the wind.
Yes. But the problem is that it's a long refractor, f10.
Oh.
And in the balcony, suffer a little the wind, but the mount is working very nice with it's the first time that I don't use anymore the Explorer stars with the table. If not, all is connected with the Quart du Ciel and synchronizing with Quart du Ciel and tracking, and it's very easy. Now I'm using the tracking of the camera, but I can show you because I love this. It's beautiful.
What aperture, Cesar? Is it 80 millimeters?
90 millimeters. 90. It's an old refractor, Celestron refractor.
You know, the steady. Actually, the seeing is pretty steady. It's just the obviously with the wind.
Yes, unfortunately, only the wind is at the rim, but the seeing is not horrible. It's okay.
Yeah.
Plus, you have the advantage. The moon must be almost overhead, right? I mean, for you.
Yes. And this time, it's over our head. Yes, absolutely.
That's a big advantage. Yeah. So you won't have the.
Yes, the problem is not of focus or seeing. If not, it's the movement of the wind.
Yeah.
Look that.
Oh.
Yes. Yeah.
But this is cool. You have ASCOM, set up so you control it through this interface. Nice.
Absolutely. I spend 3 hours because anything that I change, and when I understood the things about computer, not about the mount, that I made the things in the right way. When the firmware connected, all the old problems of the mounts disappears. The connecting, all became easy to connect.
And you felt like a hacker.
Come on. No, fortunately, I don't feel anymore a hacker because now it's easy, absolutely easy. It's the last firmware changed the things to resolve everything and make a more easy way to connect. It's my report to Sherry to say that me few customers that this was fun because they install the firmware before me and tell me, Cesar, this worked perfectly. Oh, excellent, but I don't try myself. I don't try it. I'll try. Well, tonight I could install the new firmware and resolve a lot of different things, small things that before was more complicated for me, or more users that was not familiar with the notion of computer or connections. Now it's more automatic, the system. I think that for me was when I connected all again with the firmware installed, was what is great, it's working. Yeah,
absolutely. It reminds me when you talk about that. Reminds me.
Look at tracking and look at tracking when synchronized, because my connection, my polar alignment is not so good. Despite the wind, the quality of the tracking synchronizing is very good.
Oh yeah. It just bounces back. The wind throws it off a little bit because of the long tube, right? And then it comes back very nice.
Yes, absolutely. Yeah. Well, this is all from me. Sorry that I couldn't be connected tonight, but it's a pleasure show something of the moon with a small telescope, with a small mount that work very friendly now. It's for encouraging for people that think that only need a big mount or a big telescope. Despite the wind, this image and the quality of tracking is excellent. Look this.
Oh yeah.
If the wind stop. Yes.
Also, it's comfortable. You're doing this all remote. Inside.
Yes. In my comfort of the living room. Yes.
Yeah. That's nice. That's really good.
And you can project it to a TV or something, and you say, "Oh, look at that moon."
No, yes, in my
and you're warm.
Absolutely, yes.
Nothing will replace going in the field, of course, when you're out there 100-mile-an-hour Cesar, right?
Yes.
But that's all the experience.
Sure, absolutely.
It's nice to have the option. Nice to have the option to be able to go inside or out. That's really cool.
No, yes, absolutely. In Buenos Aires, winter is humid and windy because we have the river plate. The river is so wide like a sea. I live only at 10 blocks from the right, from the river. It's like a sea, it's open. It's like a Lake Michigan in Chicago in winter, but not so cold, but it's windy. When the wind came from the south, or especially southeast, it's really humid and cold. Tonight is a mix of southeast and south, and we have humid here. Humid that feel the chilly, the chill wind. It's very low now. It's of course that it's not so like in the north of the United States or the Patagonia, but really feel very, very bad. Yes, I freeze it in the balcony, put in the focus. I freeze it and return. Come on, now I'm happy because everything worked.
Great, that's good.
Well, thank you to everyone.
Cesar, thank you, man.
It's a pleasure, Scott. Every time it's a pleasure to share with this team. Yeah. And thank you to Maxi that he filled my time. I have an Argentinian support me to
Maxi's only slept 3 hours, so he's
oh my god,
he's almost in a coma right now. So yeah.
No, yes.
Yeah, I recovered from my vaccine last week. But yes, that
well, it's good that you're able to get it.
Yeah. Maxi resolved everything with mate, no problem.
Every time, the mate is always.
Okay, all right, guys. Well, next up is Cameron Gillis. Cameron appears weekly, at least weekly, on our programs. Sometimes 2 or 3 times a week. He has a program called Camstronomy, where he's taken us on his personal journey of his personal sky survey. And he's observed thousands of objects and recorded and logged in that data. And he has taught others how to do effective logging of astronomical observations, both visually and photographically. So there are people who are learning the Camstronomy method now, and I know he's been an inspiration to many of you out there in the audience. And he's here with us now. Cameron.
Oh, thanks a lot, Scott. You bet. Thanks a lot. So yeah, I mean, well, first of all, before I share my screen and go through, I mean, you know, a wonderful show. It's so fantastic to celebrate with you guys this milestone of a lot of historical things happening today. Besides, obviously, the moon. Not, you know, that moon landing, Apollo 11. It's just absolutely incredible. And to think that it happened, you know, 50 years ago, more than 50 years ago, it's just amazing. And then now to be able to have people like, you know, billionaires like Jeff Bezos and Elon Musk, and, you know, not just one, there's 3, you know, and these are private companies, right? I mean, not even governments. And then you have the Chinese involved, you have Indian, you have a lot of probes out there. This is definitely, like Scott said, the golden age of astronomy, and it's fantastic, all the things that are happening. It's just an abundance of excitement. So it's really great to be here with you all, and fantastic presenters. And I always get a chill down my spine whenever I see that rocket launch of Saturn V and those boosters. It's almost a surreal image where you see the fuel coming out at, I don't know how many miles per hour, right? Just so much thrust, and it just goes by that camera angle, and it's almost like unreal. And the amount of
ice
power
that are coming off the rocket, and
the ice, that is just amazing to me. And of course, the moon, the sun, the Earth rise coming around the orbit, just some really wonderful things. And I really like Karim's statement, you know, a presentation about all the history and all the pieces, you know, putting it all together in a nice, well done presentation. So just kudos to everyone. And yeah, so with that being said, on the theme of moon, I wanted to start off. Obviously, I'll give an update on my Camstronomy survey, but the main thing I wanted to, since we're talking about moon theme right now, I just wanted to show you. These were some pictures of the moon I took with my my 4-inch Mac a year ago. It was 2020, April, and I was just thrilled to be able to. I got my smartphone, and then look at the detail. Look at the detail. If I zoom right in, you know, this is a pretty darn good, you know, image. Just to be able to take with my Mac. I was just really happy with what you can do with a smartphone and with a small telescope, you know, with a long focal length. So, you know, obviously there's some issues on the edge of the field, some atmospheric disturbance and some field edge curvature, but in the center, really nice quality. And then I was kind of hooked. I was like, hey, there's a lot of things we can do. So I zoomed in. Here's another zoomed in of the southern prairies. A little bit of vibration there. And then I love this area where you have these ridges along the Marana floors. So, and then
Excellent.
basically,
Excellent. You know, for the achromatic aberration, when you use a 25 Kellner eyepiece, the singularity, and some Mach 102, you don't have it, you know. But when you use a 15 plus or super plus eyepiece, that you see the moon has an atmosphere. But with the 25 Kellner, you will not have it. And I think that's the better configuration to get very good details and without achromatic aberration.
Exactly. No, I'm really impressed with the Mac. It's great. And I know, Scott, you have one for Alcon in 2021 here. That 5-inch Mac is whoever wins that is going to be very happy with it. I can tell you that.
I think Cameron, you're in a good running for it. You've answered all those questions successfully for a while. That might be yours.
I was eyeing a 5-inch versus a 4-inch. I like both. Obviously, the 5-inch, every inch of aperture with a Mac. Actually, I would really like the you know, there's the larger Mac, the 6 or 7-inch Mac it would be a beauty as well. Those have super focal length, and but anyhow, yeah, it's just love. I love the variety of telescopes. The nice, beautiful wide field refractor. You can't beat that for, you know, all sorts of observing. You know, scanning the Milky Way. You know, even framing the moon with Pleiades or whatever. There's this all the instruments. These are all tools that will really help maximize your enjoyment. So I rediscovered the Mac, you know, about a year ago, and very happy with it. And so here I love this, you know, where you see these peaks just getting the sunrise, you know, or the sunset in the shadow. I love that, and you can actually see if you watch this over time, you'll actually see them change, you know, over the period of hours. You can actually see some changes there. Okay, and then if we go, here's a zoomed in. This is an interesting area. This ridge here, very right, a little bit out of focus, but you know, if visually, you can imagine what it was like to be able to take care of that poor seeing vibrations. I'm going to keep going. Okay, then I have this one here. Let me switch over to another view. So this was last September when there was the harvest moon, I guess it was. And we have this mountain range. This is Mount Si, if you're familiar with the Seattle area, just east of Issaquah. And there's a nice area where I can view the moon rises. And it just so happened that this particular moonrise was going over Mount Si, and you know, I got my Mac 102. I was practicing with it and threw it together, put them, not a very good image. You know, you can see the edge, you can see the reflections of the infrared, but to be able to, this was just one of those moments where you just take a shot. And I got it all set up, and I was looking at the sky surprise. I didn't know exactly where the moon would rise, but it just happened. And I know, Adrian, you'll appreciate these types of situations. It just so happened that it happened to go right over Mount Si. So if I just look at this, I just took lots of pictures and then over as it progresses, as it was rising, and it just got centered right here. So this is probably the best shot. You can see the tree lines if I zoom right in. You can see actually the tree and this little crevice here. So it was that was really fun. I actually focused on, as you can see, I defocused the moon a little bit, and I focused more on Mount Si. So that was kind of a
that is what I call a real super moon. For me.
Yeah. No, the perspective you get because you're using the telescope. Yeah, I've often missed quite a few shots because I thought the moon would rise in one spot and it's clear over there, and then I'd run and scramble to go and get it. So I appreciate this shot just because it rose in such a great place for you to be able to get these images. That's how I'd like to frame the moon one of these days. It's a beautiful, that's a beautiful, and you've left enough of the moon in focus to see the seas, which, you know, it's unmistakable.
Yeah, you can tell it's the moon.
Yeah, you can tell it's the moon.
Yeah. Thanks. No, it was tricky, and I could imagine, you know, somebody more professional, you know, with all the right gear.
You do a composite. Yeah, you do a composite where you focus the moon, then you focus the mountain, and you splice the two together. But this is a good shot. I don't mind the you know, the moon can be a little out of focus. It's definitely the moon. It's not gonna, you know, you don't look at it and go, what's the purple streaks? What's this? All that. No, you have a great shot. I'm not one for nitpicking any shot that gets it mostly right.
Well, the other thing, you know, a big thing, Adrian, to me is also, I'm glad to hear, thanks, is the appreciation of the moment, right? You capture the moment, and, you know, even if it's fuzzy or whatever, it's like, okay, you know, it's like, oh, I remember that now, and it kind of in your memory, and it's nice to be able to share that.
Absolutely.
People can see.
Yeah, each shot you're sharing what you saw. We're there with you, looking through your telescope at the moon. We can always imagine a little more detail here and there, but the experience becomes so important. So yeah, you absolutely right, and that's what makes that such a great shot.
Oh, thanks. That's cool. So now switching to moon in the sky. Moon observation. So if I look at the sky survey, this is the situation right now in my latitude. Unlike Cesar, I don't have the moon overhead. I have the moon about let's see here, 17 degrees.
17 degrees, okay.
17 degrees off the horizon. So 15 degrees, 16 degrees off the horizon. So it's really low. However, I'm happy to say it's clear. So in the after party, I'm going to set up my my smartphone and my rig. I've retooled it for a smartphone, and we're going to do Cruise the Moon. I'll probably be able to set up in about half an hour or so. So I'm just going to get it skylined, and let's see if I can get it to share. But the other reason why I show this is going to Camstronomy. Tomorrow's episode, we're continuing in Sagittarius. So if I look at where we're at right here, we had done the northern part of Sagittarius with 15 objects down to the Lagoon Nebula. And tomorrow we're going to finish up Sagittarius.
That's cool.
Again, from what I can see of these objects, including some of the globular clusters, mostly globular clusters in this rich part of the sky. And it's really neat to see the different variants on the different globular clusters. So what I have is, I have 16 new images, and I'll just preview them. We'll look at them more tomorrow. But These are all the images we'll be exploring together tomorrow. But one thing I want to share from last week, and again, this is my previous technology before I took flats with the Lagoon Nebula at the end of last week. Then I added flat technology, and look at this. This is my new Lagoon Nebula image. So, you know, to quote the immortal words of Cesar, you know, come on, right? I mean, to be able to do this now, this is only 30-second stacks, right? And this was before the moon. Okay, now I want to show you another image. Let's actually, I'm gonna have to, sorry, I'm gonna skip through a bunch here. Yeah. So these images here I took, there's some lines. I have to figure out how to get rid of those with bias frames, but somehow there was some noise. But you can see all these pictures between the Lagoon Nebula, the Trifid Nebula, the Omega Nebula, and the Eagle Nebula. These were all taken, you guys, yesterday,
Wow.
with the moon at 3/4 full.
Oh, it's
with
great,
10,
Cameron. It's
and
a great
with 10
job.
and with 10-second stacks, only 10-second exposures, but with a UHC filter, and you can see they're all within 20 degrees up, and this is a very light polluted part of the sky for me, right? I'm looking south at Tacoma, and basically it's probably Bortle 8, at the minimum, down in this part. So this gives everyone hope, for if you, I've never visually seen anything like these pictures with any telescope, and to be able to do this yourself with a modest, this is just a non-cooled, that's why there's noise in it. So cooled camera will get rid of all these lines and stuff, but a non-cooled camera, light pollution, the moon, low to the altitude. I was never able to explore these objects in Sagittarius before I got all this technology. So, everyone out there, it's time to increase your game. Get on board with imaging, and in little small telescopes, imaging, and I'm walking through this journey with you. We're gonna all have fun, and you're gonna all be able to do this yourself. So it's really nice. Really enjoyable. So now that's basically my story. So like I said, tomorrow I'll go through the actual sky survey. But I did want to show you a couple more pictures since we're here. Here's the Bubble Nebula in Cassiopeia. So we got that one. Here's because I have it's an 8-inch Schmidt-Castle green. This is the eastern veil, the lower part, which you'll recognize this fork structure down here. This is the upper part of the eastern veil. I had to do a tile. This is a beautiful, the witch's broom, and you can see a good old photo bomb. So nice little reminder, that when you start stacking. And I thought about it too. Initially I thought, it will be nice. I don't worry about all the constellations of satellites that are being launched. However, I think that for casual astronomy, you're going to see a lot more of these, as a lot of these photobombs, especially when you're stacking, live stacking especially, and you can't get rid of them in live stacking. So I think it's going to take a number of years before the software is going to be able to dynamically do that on the fly. For sure, with post-processing, if you want to, you can remove these, no problem. If you do it offline, but I want to be able to, and I think more people will want to be able to do this as a pre-processing, so that you can filter out these lines. It's not bad right now, but you can imagine in a short order, in a couple of years, there's going to be a lot of these types of lines. But in the meantime, look at how beautiful the filaments are. I mean, I'm just this is wonderful. It's only a 30-second stacking, and it's it's there's lots of noise in it, but it's I love the color, and the multicolors of the red and the green filaments all there. This is a nice high contrast part of the veil, and the eastern veil, or the western veil, I should say. And then
it's amazing the structure of the gas structures they are very, very clear, very, very sharp. They are excellent.
Yeah, I'm pretty. It's not, definitely can be better, but this is keep in mind, this is an alta azimuth go-to, right? It's not equatorial.
Yes. Yeah.
I'm limited to 30-second exposures, and then the other thing I found out is I'm limited to 60 degrees elevation. Otherwise, it starts to crash. So basically, I there's all these interesting limitations, but I've worked around them, and then you also appreciate when you get new gear in equatorial mounts, for example, very basic. You're going to really be able to leverage and get the maximum for longer.
Yes, of course, and you need a guided system, but the Altazimuth system is easy for many people, and it's very, very educational system because it's easy. You don't need a polar alignment. I enjoy it a lot of time. Many Altazimuth mounts, like for example the same one that they use, the same model of the Evolution series. Well, I'll tell you that last week I had the 9¼ model, and when I put the wedge, the quarter wedge, I were very bad. I quit the wedge, and I'm still using the Altazimuth mode. But when I turn it to a quarter mount, I know that it's more work for polar alignment, but it's great. It's great thinking in use a filter with 1 minute single exposures.
Yes.
It's something that with the Altazimuth I never could make.
Exactly, and all for different things. Like for example, for planetary or lunar or visual or smartphone, this altazimuth is perfect, right? I mean, no problem. I mean, you can track, and it's very short exposures. So if I go, and then you don't mind the slight movements. But if you're doing long exposures, yeah, you pretty much you'll want to get a better signal to noise and to make a cleaner image. You pretty much have to go with equatorial. The other thing is when you go smaller aperture, I'm using 8 inches, so I'm taking advantage of the light gathering power of that right now. But when I go to my 80 EDA, I'm going to want to have it equatorial because I'm going to do wider field of view. Sure, it's going to be shorter focal length, but I'm going to have to take longer exposures, probably 3 to 4 times. So I'm going to probably go to 2-minute subs, for example, for those images. But last picture, just to finish up, and then I'm going to actually start to set up, if you don't mind. I'm going to. This is the Cocoon Nebula. Actually, a very difficult nebula to take a picture of. Out of all the ones I took, this one's a very tough one. And the other thing I ran into is, you know how Cesar, you're having the wind issue. Well, yeah. What's interesting is with the dew shield on my C8 on the Altaz, at around midnight here in Seattle, the winds change and they get kind of gusty. So what was happening is I was not getting a steady night. I was trying to take pictures and it was constantly like shifting. Like it would always have double stars, or it would be streaks, and it was like, so this one. But the Kuhu Nebula really needs to have a good solid set of stacks
Yeah.
to be able to get it, because it's pretty very faint. Sorry, oh yeah. And so I was able to get it one night. It was actually really clear and calm, so I'm pretty happy with this. This is 30-second subs, but to be able to get a little bit of the structure here and the surrounding dark nebulosity was good. And there is one more. No, I think I'll stop right now. Yeah, I'm gonna now, if it's okay with you guys.
There's always one more.
Let me make the one more. I'm going to get set up for the moon. It looks like if I take a look at where we are at. Okay, so if I look at now, 9:21. Yeah. So just to give you an idea of my window, it's pretty much I have trees. Here's where the trees are, and then I have my house here. So I have a very small window, but I can get this for about 1 to 2 hours in here. So moon is here. So I'm going to be able to polar align with Antares and Arcturus and where is it? And Altair. Those are the 3 stars I'm going to align. And then once I get set up, I'll be back online. So thanks everyone.
Great, thank you, Cameron.
Thank you, Cameron. Yeah. Thank
you.
Okay.
Excellent discovery.
Right.
As you're moving through this. And the flats. I'll be the last person in our group to finally get good flats and figure that whole thing out. But it's obvious. Cam just showed you. Flats help really take your image. You're doing a DSLR image, or you're doing. You've got lots of. There's a whiteout signal there. It really takes care of that. So.
Oh yeah, you know what it does? It's either one thing is the immediate effect, like you pointed out, Adrian, where it's like, okay, it flattens the image. Whoop-de-doo. Okay, that's good. You take out the corners, the big netting.
Yeah.
But the biggest dynamic range, you've changed your noise floor, and what you've done is when you do the stretch, you're stretching now from a better common point for darkness.
Okay.
So you can stretch out the nebulosity. So it makes things pop because otherwise you're stretching. You're limited by the corners of the vignetting, which causes the brightness or the darkness.
I've run into that.
Throws it off.
Yep, I've run into that.
Yeah.
All right, Scott.
All right, so we're to you at this point, Adrian. So
yep, I will go ahead, share my screen now. Just right here, you're seeing a lot of moon pictures that I've taken, and what this shows you is that for those of us like myself that enjoy hearing all of the things that are being done, the exploration, going to the moon, the study, the science, there's so much that there's so much about the moon to learn. And the only other aspect that for those of us that come from a humble background and are still trying to learn what we can about it, but there's one thing that you can always do, and that's you can see the moon for yourself, no matter where you are and no matter what you know about the moon, it's there. From a photography standpoint, a lot of photographers will just try and frame the moon. This composite image was an attempt where I basically took a shot of the moon. I was able to get detail, and then a shot of the branch that was in front of me. And I tried overlaying the in focus branch with the in focus moon. Now it's because of the way optics works, it's impossible to get that in one shot.
Nice.
But let's see.
I'm gonna got the moment of this is really cool. Wow.
Yeah, so let me show you. Actually, let me stop share for a moment, and I'll show you what I got most of these images with. I do wildlife photography, and sometimes your wildlife shooter, your full frame camera and a big 150 to 600 lens, you can take that same camera and just point it at the moon, and you can actually end up with a lot of decent shots of the moon. Or you can do wide angle shots as well. So this was one of those shots where I just took the camera, picked it up, and fired it right at the moon. So we just kind of go through these. Here's my
I like
attempt
that.
to do.
Very
That's
nice.
my attempt to do what Maxie was doing. I
Mhm.
stacked fewer images. I tried doing an HDR stack with this. And I'm going to use Maxie's method and take more frames to see what kind of detail I can get down here. But yeah, there's the moon as you see it through a telescope or even your own eyes. That's the the detailed moon. I have a lot of those where crescents are a wonderful chance to view these moons. I'm gonna go, let's see, go out of here. I'm gonna cherry pick a few moons. This one is it's a first quarter, and I'll see if I can highlight a couple things here. There's the Lunar X. Now I missed it so that where it's highlighted a little more. This is a feature known as the Lunar X that you get when these four craters and the way the sun hits them is it highlights this region, makes it into an X shape. And there's also a V shape, and it's up here. Before I could see it. Oh, there it goes. The Lunar V. So these are just two features that when you're going to shoot for first quarter and you try and shoot for the terminator line to be just a little bit more to the right, this V and this X stick out a whole lot more. But it's one of the targets, a photography target for those of us who that like to shoot certain things on the moon. From a photography standpoint, there are a lot of different things you can do. This one, I've heard it called a toenail moon, where there's just a sliver of it available. And so, you get this beautiful crescent. Now, if you combine it with some higher exposure shots, then you, of course, can get, you get the earth shine to go along with it. You've heard the term mineral moon, where I think the reddish parts actually indicate iron oxide and titanium oxide, where the bluish areas on the moon are. And I think a shot like this, maybe with a little more detail, made an APOD a few years ago. I honestly believe it was just bored astrophotographers saying, okay, it's just the moon. What can I do to jazz this up? And they went and just shot the saturation all the way up, and they got the colorful moon. And then I think we found out that that those colors actually did correspond to elements in that region of the moon. So it turned out to be what and this is just according to me. If there may be a real truth behind the color, or what these colors, how they were figured out. But my understanding is some astrophotographers decided to just jack the saturation up on their moonshot, and it turns out these colors really meant something. So the elements are there, but of course, when we look at the moon with our eyes, that's the picture I just showed. Looking at the moon with your eyes, you generally see gray. That's the binocular view, and you know, this is what you see through binoculars. So using the moonlight, well, a couple other shots I'll take. Using the moonlight, this is the other side, and I learned how hard it is to handhold a shot like this, why it's so grainy. The reason I learned is that recently the moon has been mired in let's see, no, this isn't, this is just a it rises at 3, this moon rises somewhere between 2 and 3 o'clock in the morning. In the northern hemisphere, you see this moon after you've done a night of imaging, and then the moon rises and you capture it's the other side with crater Copernicus, Aristarchus over here, and all of the things. There's a shining mountain that is supposedly a real tough target that's visible during third quarter that I've been told about. I haven't been able to get. Let's see, some special interest shots using moonlight to get beautiful nightscapes. Here's I think I've shown this in the past, where if you've got clouds, you can use the light of the moon to create a beautiful nightscape. So you don't have to start it just because you can't shoot deep sky objects. You can use the moon to your advantage. This is through smoke. Here's the this is a shot I took very recently with the haze and the smoke in our atmosphere. This is how the moon appears, and that is what taught me to what to do next time I shoot at a rising third quarter moon, which has a it's lit very similarly as it's rising, and I'll have to use a tripod and use similar settings to what I use to get the detail in this moon. So that's one thing I've learned. You learn as you go, better ways to use your camera equipment to pick the moon off. And then there's transits. If you get lucky enough, you'll get a bird crossing the rising moon at a park. So that transit worked out pretty well in these couple of pictures here. There's a transit of the moon over a corridor of the Lake Erie Metro Park where the Detroit River meets Lake Erie, and birds fly over it a lot. You see there's more birds. There's this tree, and I got a transit right there. So you know, being artful with the moon is something photographers do a lot. Here's an oversized moon, and I used it to make this scene with the beach. Now the real moon would be maybe, if half this size, maybe a quarter of the size of the moon is what you really see here. There's the scorpion right here. But it made for a pretty fantastic shot. Sometimes we do fantasy shots. We blew out the focus here, but this is Lake Huron. This is by itself was a nice shot with just the glow of the moon. I plop a big full moon in front of it. So there's a number of things you can do. This eclipse picture, well, the moon's visible, sort of. There it is, blocking out a part of the sun as the sun is rising. So this is, in a subtle way, you're still looking at the moon. It's rising at the same time as the sun. Moonset, one of the first few pictures I took where I was able to get earth shine and the moon setting, the sun has already gone down. I tried to revisit this shot and I ended up with this, where you have the sun's rays and then you have the moon in the distance. This is when I upgraded my equipment, but I didn't quite get the moonshine the way I wanted it to. And let's see, if you have dust on your lens, you can get this really cool effect with the moon, with this line. There's like a pillar coming off of it. And finally, Milky Way shooting. You don't have to give up your Milky Way shooting. You can get, this is the moon as it's setting, and the Milky Way becomes visible. And what I like about this image is it's sort of it's a proof of concept image I took. That's Jupiter right here, and I think Saturn is right here. So this is 2019, I believe, or yeah, 2019, when Jupiter was ahead of Saturn, ahead of the Milky Way. You can still do Milky Way shots even if the moon is in the sky, as long as the moon is low enough in the sky that the Milky Way isn't washed out. So it's still possible to do some Milky Way photography. Now, of course, once this set, the Milky Way gets a lot brighter. But I found this a really interesting kind of concept that you can still do, you know, night photography with the moon. So you can probably see a few of the other shots on here. Blue hour moon. You can do these tricks with your aperture and get, you know, these beach shots are, I absolutely love doing them because they end up turning out beautiful. Sometimes the moon rises, you can't get much detail. Depends on the settings that you use, and you know how you, this was done with a big lens as well. So you had choppy water and you had moon rising out of clouds. So framing the moon is a challenge in and of itself, and something that you know, that it's something that you can, when the moon is out, you can challenge yourself to see what kind of shots you can get. And last two images, here's a shot using the moonlight behind me. It's that same beach, but facing more to the north. And at darker places, you'll still pull the stars out of the sky. There may not be as many, but it makes for an interesting image because you have this bright light here. It almost, you're not sure if you're looking at day or night, depending on how you finish the image up, but it makes for some beautiful images. And then this image, I have not been able to repeat this, where I've had clouds, I've got some detail in the moon, and I've got the reflection over the lake. I've tried to do this again numerous times. I've looked at the settings and the lens and everything. I have not yet really been able to duplicate it quite the way that this turned out. Makes for a great oil painting, an oil painting look. So these are all the ways that I play around with lunar imaging using, there's a couple that I didn't show here, but this is a park where I take the pictures. There's that pavilion, there's that panorama. So there's just a lot of different ways that you can make the moon, whether it's big or small. You make it a feature in your landscapes and your duskscapes or nightscapes, or you shoot the moon by itself and you just try and get in as much detail. This is a moon shot, a full moon, using the light of the full moon to get this photo here. So whether you're using the moon's light or you're shooting at the moon itself, it's always fun to see what you can do to frame it, image it. Just looking up, everyone on the planet sees something like this, whether they know or whether they even believe that we made it to the moon. There's still people that are struggling with the concept that, yes, we as humans landed on the moon, but the moon's beauty is undeniable nonetheless. And part of what I do is try and capture it in as many ways as I can. And those were some of the pictures that I've taken. So hopefully you like them. And that will be it for my presentation.
Thank you very much, Adrian. Thank you. All right. We are going to move on to Chuck Allen, who's been patiently waiting here from the Astronomical League. Chuck, are you still there?
Yes, I am.
Great. Great. Thank you.
Okay.
Thank you.
All right. Hi, everyone. I'm sorry I had to be kind of idle for a while. I had to get 32 emails out tonight. Our convention's coming up and a lot of communications going on. So forgive me if I missed a few of the early programs. I hated doing that. What I want to talk about tonight are some of the leagues, the Astronomical League's ways of encouraging people to engage in both visual and photographic observation of the moon. So I'm going to share screen now and go to, first of all, a lunar reconnaissance orbiter image of the Apollo 11 landing site, since it is that anniversary time. There were some comments made earlier, and I think Adrian made some comments about the fact that with the Lunar Reconnaissance Orbiter, we can now see strewn fields, rock fields, and so forth, and make perhaps more safer landing sites for future astronauts to land. This Lunar Reconnaissance Orbiter shot shows both the LEM base, the landing portion of the LEM, and also a line of footprints that led to the crater they had to fly over just before the landing, and also some equipment. The rocky area that they didn't want to land in was over here on the right. You can't see the rocks really, but they could from the LEM, and that's when Neil Armstrong took over manually and moved further across this crater to this side here. I did have the opportunity, by the way, to observe 3 Apollo launches, Apollo 14, 15, and 17.
Wow. Okay.
Fortunately, a family friend of ours was Senator John Sherman Cooper, and he got us VIP tickets for Apollo 17. It was just an incredible experience seeing that launch at night. It was kind of moist and damp, and we got delayed with a 2-hour hold. I think it went up at about 1 a.m. or so, but it was worth the wait. It was incredible. Did kick a bus on the way out because as we were trying to get away from the Cape, there was a field full of about 300 buses, and they all had their engines running, and I was being asphyxiated and lost my cool for a second. So what we're going to talk about now are the League's observing programs for this, the closest of all natural astronomical objects to us. We have 3 programs. One's a basic lunar program with 100 observations required. The second one is called Lunar 2. It involves 100 observations as well. And Lunar Evolution, which requires 57. I'm hearing some static, Scott, from someone. It's pretty loud. Okay, I don't hear it now. Okay.
Yeah, thank you.
Okay, so the Lunar 1 program is basically one that directs people to observe major features on the moon's surface. It does not require sketching. It does not require imaging. And it can be done with a very small telescope. We're looking here at Mare. We're looking at mountain ranges. We're looking at principal craters on the moon that are visible.
That's Hadley's real. Hadley real.
Yeah. 18 of the objects are naked eye targets. 46 are binocular targets. 36 are telescope targets, although people are entitled, if they wish, to use a telescope for all 100 of the required observations. There are also, however, there's a binocular program. As you know, we have a master binocular observer progression. And to get the binocular certificate, you have to complete all 46 of these binocular targets using binoculars. But you don't need to do that to complete the lunar program. Among the 10 optional programs is actually measuring the height of a mountain on the moon, which is done using, of course, its shadow at a certain sun angle. The 2 primary targets that we recommend to people are Mons Pico, which cuts a very long shadow near the terminator when it's that time of the lunar day. it's close to a major crater, which allows for measurement of the length of the shadow versus the width of the crater. You take some angles from the mountain to the terminator, and you're able to determine the mountain's height. I think when I did it, I got it within 500 feet of the actual height. So it can be done fairly easily with a little minor trig, really. Mons Piton is also another mountain that casts a very nice shadow and can be used for this purpose. These are not required observations. The measurement of the mountain counts as 2 observations, and it's an optional that people can do in lieu of some of the others if they choose to. I think it's pretty interesting to do. The requirement basically is a 2-inch telescope. So a 50 or basically a 60 millimeter telescope, which is a normal small size telescope, could be used to do it. You'd be better off with 4 or 5 inch, I think, on some of these, especially when you get into the Lunar 2 program. Lunar 2 is a little more demanding. Lunar 2 gets into the observation of lunar domes, which simply will not show up unless you have the proper sun angle, and the lists that are provided in the program list the sun angle or the time of the lunar cycle that you should use in terms of how many days old the moon is to observe these optimally. Some of the rills on the moon are also very difficult unless the sun angle is just so, and this one is particularly difficult. It doesn't look like it would be, but they took this picture from a little closer than you'll be doing that. The Lunar 2 program requires 67 descriptions, and in addition to that, 27 sketches. And some of the sketches have to be repeated for certain objects down here, like Proclus near lunar midday, Proclus near lunar sunset, for example, to show the difference that different age of the moon makes in terms of the visibility of the object. Once again, though, a small telescope can be used. Personally, I don't think it's going to be very easy to do with anything less than a 5-inch or a real good 3 or 4-inch refractor, unless when you get into the rills. The rills can be very difficult. Lunar Evolution is a new program. It started off as a certificate-only program, but it's now a PIN program. And basically what we're asking people to do here is actually learn something about lunar geology and its evolutionary history. Here we have 3 craters that are very different. One with broken walls, intrusions on the walls, inclusions of other smaller craters inside. Here we have one with terraced walls, but a very flat lava-filled plain with very few inclusions. Here we have a nearly perfectly walled crater that has no lava fill in the floor. So what's the difference between these? Why are they different? What different eras do they represent? There are 6 primary epochs in lunar geology that come with particular descriptions. So what we ask people to do is to observe 57 targets on the moon and estimate, using verbal justification, what geological epoch they think that particular feature represents. Here is a USGS map of the moon that shows different geological epochs at different locations on the surface of the moon, for example. This is one of the resources that can be used in doing this program. The program is executed using a spreadsheet in which you simply make your estimated lunar epoch here and describe your reasoning for believing that it's whatever you put here. And then you look up the actual epoch and see how you did. Nobody grades this. You can be wrong on half of them if you want. You won't be, but it's just a learning tool to help you assess targets versus the particular geological epochs involved. 6 epoch sketches are required, one from each of the epochs. And here is one of David Whalen's incredible sketches. I'll show you, he went way above the call of duty on this and sketched all 57 targets. And he didn't just sketch them, he did this incredible job of sketching them, just to give you an idea of what some people do in executing this program.
Wonderful.
Very good shadowing.
Yep.
The program also asks you to observe all 6 of the Apollo landing sites and to sketch them as well. And In addition to this, the observer is asked to discuss the site and why it was chosen for that particular landing and what epoch each of those particular sites represents. So here you're looking into basically the justification for the landing selections, and that's a very educational process too. The League has a master observer progression, as you know, that goes all the way up to platinum. And the master observer requirement here involves 10 programs, including 5 cores. The lunar program is one of these. So it's a very important program to knock out en route to higher progressions later on. Those who are interested in imaging, and there are lots of people, especially on these GSPs, who do this, Master Imager Award requires that a person image all of the targets in one of the lunar programs, either the Lunar, Lunar 2, or Lunar Evolution program. So that is one of the basic requirements for the Master Imaging Award. Some of the resources used for this these programs, I should say, are Sky and Telescope's field map of the moon. They make one for mirror image for those using SETs, which is very helpful. In fact, it's critically helpful, trust me. And it gives a lot of detail and helps you find a lot of the objects. It's a very nice laminated 4-part fold out map, folds out to about 2 feet by 2 feet. It's really good. The Virtual Moon Atlas, which can still be downloaded from online, is also a tremendous resource because you'll notice up here when you cite, like in this case, Kepler-C, it shows you the geological epoch represented by that particular feature. So it helps you look up the actual epoch after you've estimated what you think it is during the course of the program. Another tool that's helpful in determining when best to observe things is the 29 Days of the Moon site, where you can click on the moon at a given number of days of age and see whether a feature is prominent or not. This is especially helpful if you're looking for rills or domes. I would like to conclude just with another pitch for the Alcon 21 virtual convention coming up. We have over 400 registrants. We have an incredible number of speakers and awards to give out. And just to give you an idea of the people who will be speaking, Dr. Jocelyn Bell Burnell of Oxford University, the discoverer of pulsars, Dr. Richard Gott at Princeton, of course, wrote the book Cosmic Web and 5 other books, Dr. Caitlin Ahrens, who spoke earlier, Dr. David Levy, Dr. Larry Crumpler of the Perseverance team, Kelly Beatty from S&T, Dr. Chris Gaynor, Dr. Brian Hayden. I don't know if any of you have ever looked at any of Alpha Phoenix's physics videos on YouTube, but they're incredible. He's just one of the most enthusiastic people I've seen on YouTube since Carl Sagan. Alan Dyer will be speaking as well. We have a SLU presentation from Paul Cox. We have a VLA virtual tour. We have the library telescope program and drawings. We give away 11 every year. And we now have $8,000 in door prizes for this convention.
Wow.
Registration, folks, is free, and you don't need to be a league member. Anyone can just sign up, give us your email address so we know where to contact you for mailing the prizes if you should win. We do not disclose the email addresses to anyone. And the International Star Party at the end, that comes courtesy of our host for this entire convention, who is none other than Scott Roberts, who is invaluable to the Astronomical League and has been for decades. And Scott, again, thank you for everything you do for us and for making this convention possible.
Yeah, you guys made it so painful. It was wonderful. What am I saying?
I would like to close by showing you one other person's effort, Mark G in New Zealand. Maybe some of you have seen this and maybe not, but I'd like to play this and hope the music plays. Can I give it a try? It's 4 minutes long.
Yeah, try.
Okay. This was filmed in New Zealand, Wellington, New Zealand, from a mountain 2 miles away from an overlook over the city.
Even if we don't get sound, we'll get visual here. So,
can you hear it?
No, but that's okay.
No, but we see the visual. It's probably
Visuals. We got music playing in our head. Let's check this out.
I hate that you can't see the music, hear the music.
No, it's not detracting anything from what we're seeing.
No.
Plus, if it's
sometimes when the music plays, social media knocks it out anyways because of copyright issues.
Well, I have permission to use this from Mark.
It's beautiful. Really sharp on the silhouette there.
I can hear a little bit. It's very faint, Chuck, but I can hear some music.
Can you?
This will also just encourage us to go on YouTube and we can play the presentation full with music and see it again.
That's cool. Pekka says the Symphony of the Moon. Cool.
Yeah, I'm sorry you couldn't hear it. It's got beautiful freeware music to it. You can find it on YouTube. By the way, it's called Full Moon Silhouettes. Full Moon Silhouettes. And
I think we'll do that, and then we'll be able to hear the music.
Yeah, I'm sorry about the music. I
don't
know why.
it.
Maybe I should. Wonder if muting my own microphone would help the sound appear.
Yeah,
The music
when you
is
share
something
it,
that
when you share it, Chuck, look at the little box on the left hand before you say commit to sharing it, and there'll be an audio box you can check. And
Okay.
see if that helps you.
You mean now?
Yeah.
Yeah.
Give
Give
it a
it a
shot.
try. By the way, Chuck, I recently became the Alcor for one of my astronomy clubs. So
Fantastic. Yes.
that means
It's great to have good people doing that. It really helps us, when the Alcors care. Every now and then we have some Alcors that don't do much, and that hurts our communication with clubs. And so thank you for doing that. Okay, where is this now?
all right.
Before you commit to sharing, so you unshare your screen.
Okay.
Click on the green button that says share screen.
Okay.
And before you hit the share button,
computer sound.
there you try that. Let's see what you get. There you go.
Now we can hear.
Success.
Wish I'd known that the first time.
Very nice.
Okay, thanks for listening to it again. Sorry, I didn't know that. Anyway, I spent something like 4 hours on Google Earth one night trying to guess where he took the picture from, the video, and I got it within like 20 yards.
Oh, that's pretty
He was
good.
about 2 miles away, basically on a sloping hill leading down to the city. And then there's a mountain on the other side where this overlook is. And he lined it up perfectly. Took some planning.
Yes.
Yeah, anything that good always does.
Yeah.
Yeah, there are so many. You take test shots for a concept, and then you go back and get the real thing.
Yeah,
So
well, plus he had to catch it when that moon rose right behind that overlook.
Yeah.
And
2 days either way.
Yeah.
Not gonna work. And you can position yourself, and there's got to be some room for you to be able to position yourself too. If there's a cliff where you need to go, you're done. So, well, good night, all. This has been a wonderful
All right,
star
Adrian.
party.
Thank you very much, man.
The moon. You made me change
Thank
my
you,
background.
Adrian.
Yeah, it's 1:04 a.m. Eastern time. I'm gonna have to get up and go to
Yeah.
my boring other job, but I look forward to next week, and hopefully the smoke. I think the smoke is beginning to recede in our area, so we will have a bit clearer skies to be able to enjoy here soon.
Yeah,
I hope. Oh, look at that! There's a live view of the moon right now.
Great.
So,
Guys,
yeah, good night.
I need to run. I've got a phone call that I've delayed.
Take care.
A friend
Thank
in
you very
Melbourne.
much.
Sorry about that.
Thank
Okay.
you.
Take care,
Thank
everyone.
you.
Bye-bye.
All right. Good night.
Bye-bye.
Good night.
Good night.
All right. Guys, we're going to take another 10-minute break. I think Pekka Hautala had mentioned that he would be on, so that would be great to have Pekka on for a little while. And then we can do a wrap up with our after party. So, get yourself another cup of coffee or stretch your legs, and we'll be back in about 10 minutes.
Okay.
Make that 5 minutes.
So I just got set up, Scott.
Yeah.
And so we can cruise the moon.
All right.
Let me just
Well, have why don't you give them 5 or 10 minutes of that, and
Yep.
and we'll come back Hollywood Square style here. So
sounds great.
okay. All right, and I'll
So
be
I'm-
right back.
You bet.
Yeah.
Okay, so I don't know if you can see my screen. Looks like it's in the corner here. Let's see here.
Excellent.
Okay, let me do some adjustments. I just was getting set up here. Yeah, here we go.
As
Let's go.
like I trying to take some pictures of near to the moon area, I started to try with M4 in Scorpius, but of course that I have a lot of light. This is your live moon image.
Yeah, this is a live moon image, just like what you were showing earlier, Cesar.
Yeah.
Except
yes, I can see.
now if I just do some adjustments here, see here.
I return
change
to the
ISO.
moon 2 to compare with you.
We'll go to ISO 100. I'm just putting it in pro mode. That will help a lot. Okay, so
Now
doing some adjustment. There we go.
okay. I'll
Changing the
try.
shutter speed. Whoops, that's a. Let's make it. A little bit slower here. Let me move this out of the way. Can I move this out of the way? Ah, yeah, good. Let me get this out of the way. Let's go view, optimize speed for now.
Okay, good. That will go move this out of the way. I wish I could get rid of this thing. Anyhow. Okay, so then we got, so let's change the speed here. We're gonna go, do some hard. Let's make it 1/250, 1/250th. That's pretty good. And then ISO 100. Now I'm going to change the quality, optimize for quality. There we go. So basically, I'm using Team Viewer. There, this is pretty good. Let me, and now I can zoom in. So let's move to the right here, and let's look at some of the craters over there.
This is with what telescope, Cameron?
This is with my 8-inch Macassegrain.
8 inches. Okay, okay. With the
at the native focal length. I'm using a 13mm Nagler with my smartphone.
Excellent.
And just using an S8. Whoops, let me just.
Yes, I'm in my setup, my new setup with using isolation because I returned to the moon in the center with my go-to. I am happy with my mount and my new system all made it all connected with Carte du Ciel. Carte du Ciel.
Ah, yes. No, that's a good setup you got going.
Yeah.
Let's zoom in. Move it.
Wow.
Oops, that's too far.
Now I have a wind again. Come on. But I took a lot of pictures tonight, and I have many.
Zoom right in. Oops, zoom, and I'm going to change the quality. So this is to make it respond fast, and then if I go view. Go to optimize quality. There we go. So you can start to see the seeing, right?
Yeah.
Seeing conditions, but you can see actually the ridge of this crater right here. Pretty good detail.
Yes, I think that this beautiful details. Beautiful.
Okay, and I'm gonna just, but I'm doing this over Wi-Fi. So I'm using Team Viewer, which is this thing here. So if I go optimize speed, that like lowers the quality, but it goes pretty fast. So if I zoom back out, kind of experimenting here, and I zoom back out. Let's go to another part of the moon. Let's go to. Let's zoom in Tycho.
Yeah.
The Tycho or Tycho?
No, I don't know because in Latin maybe we say let me see. No, we say Tycho.
Okay.
Because
so
it's Tycho is okay because it's hello Pekka, how are you?
Hello Cesar. Hello Cameron.
Hey Pekka, how you doing?
I'm fine.
All right.
Thank you. And you?
Good to see you, man. Yes.
Good to see too. Good to see too. Cesar also.
Yes, Pekka, how are you?
I'm fine.
Maxi abandoned us maybe half hour.
Okay. A good
yes, the guys.
Day.
Yes, the how do you say la pandilla, the gangs from the last time of the party, the after party. only we need to Maxi. Yes, and Adrian too. Adrian, go to bed.
Yeah.
Too.
Hello, Scott.
Pekka, how are you?
I'm fine. How are you, Scott?
Great. I'm good.
Thanks. Good.
Did you enjoy the program so far?
Yeah, absolutely. As far as the best one. I haven't seen this kind of show. I have watched TV in 50 years.
Yeah.
And this is the best show ever.
Thank you.
Because the topic is just, it touches everybody's heart.
Mm-hmm.
You don't have to be an amateur astronomer to realize that the topic is just great.
That's wonderful.
Yeah.
You wanted to talk. You did want to talk some more about this kind of the experience of.
Yeah, I thought that because I have a lot to thank Scott and Explore Scientific of a lot of things, and as we talked, you talked for a couple of months ago about how astronomy saves people's life.
Yes.
And it certainly that did mine for 15 months ago. And that's because I will devote this speech to ES members, followers, and customers. And my topic is a giant leap from this episode's topic, because I am not talking about the gears and photographs and so on, because this is about totally of sun and universe. I have made a memory list for me, because I can't hold it in my mind, everything I want to talk about, but I just want to say that the sun is not only the source of light we have. It provides opportunity to get some tan, yes. It provides some sun travels, yes. And it's vital for our life in Earth. So we should see sun as an ordinary star. It is an ordinary star. If we just travel far away and look at the sky, we will see our sun as an ordinary star. So that's why I'm got an solar scope and begin to look at our star and how beautiful it is and what life it is on that star. So when I was 8 or 9, I was on the library and read a book. There was an article of protuberances. Today we call them prominences. I don't know why. If there is difference of protuberances and prominences, but that was so difficult word to remember. So I just thought about it. Protuberance all the time. And after 46 years later, I took my first picture of it. Really, I can show it. 46 years I have thought about this.
You're going to try to share your screen, Pekka?
No, it's Cameron sharing. No. This is not good, but it's my first image of prominences.
Yes. I tell you by Facebook that I can't believe when I say, wow, first light of Pekka with your solar telescope.
Actually,
I was
yes.
astonished with your picture, Pekka.
Yeah, actually it is my first, yeah. And now let's see how there.
That's hard to do. How did you do that, Pekka? Because the prominences are pretty faint. You need usually a special filter. So how do you get that one?
Only the Lunar solar scope is a little bit different than usual telescope, because you have first you have the focuser, then you have the pressure tuning you have to fix. So you have to tune with 2 settings to get the prominences. You can see those, and then you, of course, you overexpose the surface.
Yeah.
But it's
I really appreciate that. That's a hard one, but very good to capture it.
Yeah.
Pekka. Good work.
I have this is the first surface picture, and
oh wow,
yeah,
it's
That's
too dark,
cool.
but it's my first H alpha picture, so
Nice.
it
Very
will
nice.
be better by the years. But
Starts with the first.
yeah,
yes,
you
you
have to get
started
the
very
first one.
well.
Yeah, you have
Really
to get the
well.
first one. Okay, and when I started astronomy, my biggest dream was to find that unknown star, because my dad always talked about the unknown island in the Pacific Ocean. No man has never seen that island, but there is a small island, and I was so targeted to find that star. So I keep looking at that star today. But okay, I do have rough times and days, and those times I close myself in my room and totally silence, and I begin to meditate, so I get to the point that there is no tomorrow, there is no yesterday, just right now, with no sound, nothing in my mind, and just leave. And I'm seeing the Earth and the Moon 3D, and they are just levitating and floating on that emptiness. And that feeling is like you get minus G-force in your stomach. You know, when you go down in the roller coaster,
right?
You feel that it's going around in your stomach. And that is the feeling I hope everyone can feel someday and one day when you are doing visual astronomy without no gears. You just look at the one point in the sky and let your mind just go and make the travel. You can see those stars just like car window passing by. And you can stop everywhere you want and just look around, downwards, upwards, and keep on, wherever you want. And you have to be in that stage in your mind that you can't just leave everything. And that feeling is like nothing else. So that is, you have to work with, I have worked on that and I can do it. And when I go to balcony and I see my mouth, I got this cold rushes and it turns in my stomach. That this mount gives me the experiences I need to have. And that's kind of love.
You not just want to have, but you need it. Yes.
Yeah, I need it. Yes, it's giving me the something. I don't know. I got the word, but when I see my mouth, I need. I am sorry that gives me what I need. So it's a weird feeling, but that's the connection I have.
It's athletes call it being in the zone. It is psychiatrists will call it being in the flow. But it is being in the present moment.
Yes.
And maybe some people have an experience of kind of almost losing any kind of sense of self-identity,
Yes.
Right?
Just exactly, because I leave literally my body on the ground and I float and I can see the blue planet we call blue planet, which we are destroying right now. And we know it, we are destroying it. But if you see the Earth and the Moon 3D, and there is no wires, there are no sticks, and you kind of see the contrast, and because space is 2D as long we got something behind, so we can relate the distance, and we can't do it when we just look at the sky. It's totally 2D. But if you get something behind the moon, some wall or something, you can relate it. It's directly 3D. But you have to do it with in your mind to get that 3D feeling.
Right. Book Davies is commenting on this. He says it's similar to the feeling of flying when you're playing an instrument and it's all going exactly right, perfect timing and pitch, and it's all right on. You know, the musicians also experience this this flow. You know, so it's
I think so.
zone. You know, so it's I think you can come at it many ways. Astronomers definitely do it, and astronomers have a few other tools too, because they understand that there are even things like when they're looking through the telescope, they're looking back into time.
Yes.
You know, we are seeing things as they were. You know, we understand our limited ability to see a certain range of things, but through our understanding of also of science, we know that we can infer that there is other, you know, there's a greater range of energy than what we can perceive, but we know it's there. We know that we're stardust, you know, we're made of stardust, you know, we're connected.
Exactly.
It's not like there's a wall or there's something separating us from the rest of the universe. You know? And so that, for me, that flow is also the feeling of connectedness, you know, and interdependence feeling, you know. So I understand that.
So when you first time get that negative gravity G-force in your stomach, then you realize what was that? And you know that feeling is like a roller coaster downhill. It turns your stomach up and down, really. And it's I can do that kind of astronomy all the time. That no gears, nothing, just in my mind. Make a trip there and there. But I do have some pictures to show you. I got some very nice clothes today. Let's see where I can share there. There.
Wow.
Oh, beautiful.
They were very strong today, tonight.
Are these called noctilescent clouds?
Yes, yes, yes.
Oh, beautiful.
So they were really symphony on the sky.
Oh, that's really nice.
And that's my contribute to tonight's topic.
Beautiful.
Yeah. So thank you, Scott, to give me this time.
Yeah.
Yeah.
The book makes one more comment. He says, we live to feel that feeling as much as possible. Astronomy does that for me too, especially just getting in awe at Jupiter and Saturn.
Yeah.
Yeah. Thank you for bringing that up, Pekka. Beautiful.
Thank you. Thank you for having me on.
Well, Cesar, how are things?
I have few seconds of a live moon shaking little with the wind, but we can. But it's so real. It's so real when you. I think. Let me check if you can see. Okay.
Yes.
Here. And it's so real with the wine, with the wind. Yes. But sometimes when the wind stops a little, it's a night. It's a night because the scene is not so not so strong. The scene tonight, but you know, in a windy night, you have a bad seeing, of course. But
But at the same time, too, we know it's a live image. You know, this
yeah,
is
it's a live image.
it's
It's
a live
live.
image. Yeah.
Yes, it's how the people that never watch it at the telescope is the idea that how they can see the moon. I don't know if you see the controls of the quart du ciel.
Yes.
Yeah, we can see.
Yeah,
That's neat.
it's beautiful, really. So it's great. Drive the telescope from my living room, but
Right.
especially
The comfort of your
with
home.
return to the sky map. It's great to center. While we was talking in the Zoom, I take a trip in the area of the moon to take some pictures from M4, M22. Of course, there are not pictures because with the moon so near in the sky, was full of light, you know. But was interested, center the telescope, choose the image. Very, very interesting for a next trip or visiting a lot of different objects in the night. Really is easy to enjoy and really well. Is the moon ever is a great object. And I never feel tired to enjoy the moon. Really is one of the best objects in the sky. Really.
I would agree with that.
Yeah,
I
absolutely.
recall a trip to Palomar Observatory. You know, of course, they have the big Palomar 200-inch, but they also have a telescope which is a 60-inch. It's the Oscar Mayer 60-inch. You know, I guess from the Oscar Mayer family, they donated the money for this observatory. Anyways, the San Diego Astronomy Association had a night on this telescope, and they had it aimed at the moon. And there was the eyepiece was sticking straight out the back of this massive 60-inch mirror, and the light looked like a spotlight hitting the observatory floor, you know. And almost all of the amateur astronomers of the group would not look through the eyepiece because they thought, oh, this will ruin my night vision, or maybe I can't see anything else with this telescope except for this latent image of the moon. I said, get out of my way. I want to see this. And it was beautiful.
Yes, absolutely.
We had a night. Palomar can get very, very good seeing conditions. It's one of the things it's famous for is how steady the air can be there. And looking at the moon with a 60-inch telescope, the surface of the moon looked like gentle rolling hills with craters on it. It was just amazing. Amazing. You know, so I'll never forget that view.
Absolutely.
Scott, I have a question to you.
Sure.
What date are you planning this Mount Wilson trip?
Wilson trip. Well, I already did a trip. Last weekend, we flew down to San Antonio, Texas, and we took a drive out to the hill country of Texas, which was we drove about 90 miles outside of San Antonio to look for a suitable site where we could see both the 2023 annular eclipse and the 2024 total eclipse.
Yeah.
And so we took with us one of our friends that and her family owns ranch land out there, and so they took us out to an old private airplane landing strip, which is not used as a landing strip anymore, but it's been cleared off. It's flat, you know, and it goes something like maybe half a mile in, okay, and it's about 80 feet wide. So this would be a great place for us to have some eclipse parties there, and so we're currently in the planning stage to do this.
Okay.
Yeah, we would have to rent the property and all the rest of it, and bring in some facilities. But it is very close to a town called Lakey, Texas, which is kind of an old West Texas, well, Hill Country, Texas town, which is pretty cool actually. And people there are very nice. And we went out, and even though we had the first quarter moon last weekend, I had one of those light meters that you can read how dark the sky is. I aimed the light meter at, away from the moon. I mean, the moon was so bright that you could read a book. I mean, you could see your shadow very clearly on the ground. You didn't need a flashlight at all. But I aimed it at the dark part of the sky away from the moon, and I was still getting a reading of 20. Okay. The light meter only shows darkness up to 22. Okay, so it is pretty dark. It is pretty dark. And when we get to dark, of course, during the eclipses, we'll be doing dark phase of the moon. It'll be very dark out there. So, these events will not only be to see the eclipse, but to do deep sky observing and to have a good time in the hill country of Texas, which is beautiful. And for those that want to go into San Antonio, San Antonio has a great old marketplace, a Mexican marketplace that's been there for something like 100 years, so it's very cool. And then there's the river walk, and so there's things to do, and all kinds of experiences.
I just need a guide.
So I will, as soon as we get everything all arranged and everything, we plan to make this available. We do not plan to, during eclipse expeditions, a lot of times people charge exorbitant fees, I think. I got to experience that in the 2017 eclipse when we went to Casper, Wyoming, and hotels that were, not hotels, motels, okay? Motels that were normally like maybe $60 or $70 a night were $600, $700, and $800 a night, okay? So charging like that is really crazy. We heard of places where they were charging $150 to $200 a night just to put your tent on the ground, okay?
By the way, Scott,
we're not going to do that.
Scott, by the way, about the light meter, did you know that there is an app for that, for your iPhone?
No, I did not know.
Okay, you can get the name from me right away.
Okay. We'll share it with the audience here.
Yes, because it's a part of EDA. Let's see there. There is two. There is a dark sky meter.
Oh, wow.
And then loss of the night.
What is it called?
Loss, LOSS, of the night.
Oh, okay.
That is for the light pollution.
Okay.
I think. But there is two apps you can measure the darkness of the
I
sky.
will compare. I will actually try it.
Yeah. And those are iPhone apps.
So dark sky meter apps. Very cool. Very cool. Yep. So
correct.
So we're excited about putting together these events. We also have planned for next year the Mount Wilson 60-inch star party. So we will use a 60-inch telescope, and that would be combined with the tour of the Jet Propulsion Laboratory. So that'll be a nice weekend. And then we are planning the Arizona Dark Sky Star Party with David Levy. And so, we'll try to get as many people that come on to Global Star Party to actually be there. That would be a lot of fun.
I will try to be there.
Yeah. You'll love that. That is
yeah.
a place called Kartchner Caverns. And Kartchner Caverns is one of the most spectacular caverns, caves. And it's absolutely pristine and beautiful. So you get to do that. You'll go experience beautiful dark skies, and in a 5-star facility. It's just very nice.
Oh my God.
And then we are planning also to have a tour of the mirror making lab at University of Arizona as part of that trip. So
yeah. Good.
So, yeah, Cesar would love that.
My
tourist
visa is 90 days, so I have plenty of time.
Okay, all right.
But then I'll only get back to Sweden one day and back again.
Oh,
for 90
I see.
days.
I don't think you have to go all the way to Sweden. You can just go down to Mexico and spend a day.
Yeah, exactly.
So
yeah,
easy.
Yeah.
Yeah. Wonderful. Yeah, both the Texas event and of course the Arizona Dark Sky Star Party and Pasadena. Those are all close to the Mexican border. So, and if you're staying for an extended period of time, I know you just have to be out for a few days, and come back in. So, wonderful.
Yes.
Anything else Cameron, is there anything else you'd like to share? He's sharing it now.
Yeah, I'm sharing, and it's looks like I lost the connection here. Let's see what's happening here. This was the last view of the moon I got before I lost my connection. I guess I don't know what happened there, but basically you can see the clouds are coming in. Let's see here.
This with TeamViewer, is that what you're using?
Yeah. I was just using TeamViewer, so let me just try to.
Yeah, what a fantastic tool these things like TeamViewer are,
Yeah.
Is that what you use, Cesar, as TeamViewer?
No. I choose Chrome Desktop.
Chrome Desktop. Okay.
Chrome Desktop work very well between computers. I use it different. For example, a few weeks ago, when I used it touching my cell phone, but watching outside the screen computer is a great way. But I used the table with the Explorer Stars application without a connection, direct connection with the sky with an Skype map. But the difference is that tonight I used Carduciel directly connecting my computer outside with a serial port and the camera to the serial port too. I don't see now my computer is closed, the notebook, and it's very I can change this using ASIAR Pro or this type of system that are for Wi-Fi for camera too. But many people, and especially in Argentina, where the people don't like to spend a lot of money in gears and gears and gears. Many people have an old notebook that work very, very good only for managing or driving a telescope. And you have it in a old notebook to be outside, the option of having a driving for image, driving the mount, and this is very easy. This tool, like a use camera or me, are free. You don't need more that your own Wi-Fi connection. Only putting an old notebook with Windows 10 outside or in your observatory, but me or Pekka, that we have balcony observatories. It's a gray well, Cameron, I don't know, but Cameron have a backyard. Do you have a backyard, Cameron?
Oh yeah, yes. Sorry, yeah.
Yes.
I do have a backyard. It's just a small backyard. It's kind of like a corridor. Yeah.
Yes. Yeah. And the resource of to having a old PC outside with or PC or notebook that support Windows 10 and only with 2 or 3 programs. For example, the program of if I use Canon T3 or that is the same that 600D is an old camera.
It's the best one. Cesar, it is the best one. Absolutely.
Absolutely. And I think that is coming a time of not cooled cameras that the same that use Cameron or Maxi, reflex camera anytime cheaper, where the people is coming and the cell phones every time much better and more able to take much better pictures, like Cameron show now in the screen. Wow,
Cesar,
I can see the clouds.
Cesar, if you have a possibility, do your 600D full modified.
Yes, my camera is modified. Yes,
it's full modified or astro modified. Is it full or astro modified?
It's my old camera Canon 600D600. It's have removed. It's modified because have removed the IR filter.
Yeah.
And work, it's easy to have red colors.
Yes,
from the space, hydrogen, you know.
Cesar, if you have a full modified, then you take everything off. You have a just plain sensor. And
no, yes.
You get all wavelength. You get everything in. But then if you have an astro modified, then you put an ACF filter in front of, and then you can get focus with your ordinary lens. But with full modified, it's hard to get focus with the ordinary.
Yes, my autofocus don't work anymore.
Yes,
but
no, not even sensor cleaning works anymore.
No, yes, anymore too. Yes, because I am a optician, and for me, it's
but you get
it's a daily work. Clean optics and clean sensors.
Yeah. So I have full modified and I have astro modified and then ordinary 600D.
Yes.
And I won't change. If I change, it will be Canon R.
Yes, but you have a treasure because it's very easy to get, especially something that people like us that we are fighting with light pollution, but we have each time we have more problems with light pollution. Something that I advise to the people, but of course that is only advice to amateur astronomers or astrophotographers, is that don't is continuing still fighting with against the light pollution, but all the spectrum of the LEDs are more in the blue. That is very bad really for the health of the people, but it's great for astrophotography because it's easy to in the histogram, it's easy to clean the blue colors or the blue channels, work more easy with the red colors from the nebulas. But of course, that don't say to the old people this, because the people start maybe starting to think that the light pollution is good for astronomy, but really not. It's really bad, and this is something of the color, but in the quantity of light, for example, in the south of Buenos Aires, a city that the name is Avellaneda, the major don't have much better idea that put double line of lights over the way, the road, and really you feel that you feel pain in your eyes when you drive at night. You have so quantity of light, unnecessary, because it's, you know, in Argentina we have a problem, especially in Buenos Aires and in the metropolitan area, of unsafety, you know, robbers, steel. We really is a big problem in all of South America, but outside Buenos Aires especially, you have a problem about criminality, you know, and the problem is that you don't resolve only with light.
No.
People say the measures don't think. Yes,
it's the opposite, because you help the criminals to see, to do
absolutely. They are more happy to
to see,
to have more to see you and rob you. Yeah, absolutely.
But my recommendation for you, Canon 600D, install Magic Lantern. Have you heard about it?
Yes,
because then you can take a movie about 60 frames per second.
Yes.
So it's better than ZVO's cameras. Sometimes
it's real. My son installed actually will remove the Magic Lantern. My daughter actually is studying something about design of light, image and sounds in the university, and he used a lot of different cameras, and sometimes she used to make some movie shorts for his studies, and she normally used Magic Lantern in her own cameras.
Good firmware, because you just have it in your card, not in the phone, in the camera.
Absolutely.
So you can always you don't do anything about the camera.
Yes. I'm turning to start to use more CCD cameras that still using my reflex camera, because this camera is near to the end of their own existing because I have maybe is from the 2014. It's really old for a camera, and you know that amateur astronomers use a lot of cameras. The people know actually that they don't like to buy a pre-owned camera from amateur astronomer because we destroy it. And we say, how many shots have? 1 million. I don't know, because in each night you say yes, okay, 100 shots for Orion Nebula, 300 shots for M8 or or galaxies.
1,000 exposures is nothing.
Yes. How many exposures have? 3 million. I don't know. The age of the universe in years. I don't know.
Exactly.
Yeah.
Right.
The people go away when I say, okay, can you sell you my camera? No. But between amateur astronomers don't feel worried about the camera that work properly. My camera, when I post great pictures or good made pictures, many people tell me, "Hey, man, can you sell your camera? Can you sell me your camera?" No, because it works properly, and it's easy to found that the people, amateur astronomers, are interested in buy cameras that are very used, but they know that work properly without. For example, in my camera, comparing with the same cameras of this in the same models, my camera ever had very low noise. I don't know why. Comparing with the same model in from the same year, pictures that I used less darks that friends that have the same camera. In my camera, I don't know why. Maybe the Japanese men that working in this making a better work this day. I don't know what, but it's fun because they are not so. And this camera, it die with me because it's working. It's still working.
Cesar, your camera after 6 months. You know how it works. It takes some time to know it, because I have 4 Canon 600 and I only know how one works, and then I crap the other.
Yes, maybe totally one is better than another one's. Yes,
and they are exactly the same.
Yes, I don't know why, because it's something that you say, come on, it's electronics or optics, but especially we are talking about the electronic of the camera, and two cameras don't work in the same way. It's incredible.
You have to learn each of them separate.
Yeah,
this one functions like
make more noise than another one.
Yes, exactly.
Totally real. You never listen this, Scott, that you vote or you compare the same camera from the same model from the same year.
Okay.
And not all cameras work in the same way.
That's true. Even before digital,
even
before digital, that was true as well. So one of the things that we would do in the days when we were calibrating film and our chemistry and you do all the darkroom work, we were doing zone system calibrations.
Yes.
We would go and characterize our cameras and look for places inside the camera where the light would enter, but we would take flat black paint and make areas inside so there was no shiny spots inside of there that would improve contrast. And then we would actually measure the shutter speeds. It says it's 1/500th of a second, for example. Well, that wasn't always true. Sometimes it was like 1/350th of a second or 1/600th of a second. So you had to know what these real shutter speeds were. And then you could make other calibrations as well, even to the F ratio, which was of course better. And most of the time, the lenses were the focal length printed on the lens, but not always. Once you start really working with the camera, now with digital, I am sure that there is variation in the sensors and maybe some electronic noise differences. I don't know, but but I would say that but once you know what your equipment's doing, then you can control some things.
Yes, it's incredible because little difference while they was manufactured, they make big difference in the results of the camera. Each camera.
Yes, that's right. That's right.
It's like paint. You can't get too.
While we talk, I share the moon because
Yeah.
If you agree.
Yeah, Pekka, we used to buy, after we had done our calibration work
You can see, no?
the
The moon,
equipment,
yeah.
we would also buy bulks of
We
film
agree,
that had the
Cesar. Looks good.
same manufacturing number. So
It's like wallpaper. You have to have the batch number. You have to have the date.
exactly.
It has to be exactly the same.
Yeah.
Even then,
With
it
digital,
can be
okay,
variation.
okay, you're working with the same sensor all the time, so.
Yeah. But the shadow time, it's just one small fraction of the second, because I have a mirror flipped. And the mechanic can be, if I have one camera that gone 3,000 exposure and next one 6,000. And there could be some slides of differences on the exposure time. Anyway, but it's fun.
Yeah.
It's not science and like that. So I keep it in fun level and enjoyable level.
Yes.
There's a lady down in Chile who's watching right now. Her name is Chio, and she knows Rodrigo Zaleda very well. Explore Scientific one time donated a telescope through North Optics, and and Chio's class got the benefit of that, which was really cool. And so she says she has some photos of the moon of Chile to share. So, all right, Chio, let's see. Let's have you. I will give you the login. If you want to join us and share your images, you can do that.
Yeah.
Let's see.
If you like, it's still sharing the screen. Scott told me, to keep the.
No, it's okay. We'll
Okay.
see if Chio comes on.
Okay.
Oh.
And today, the director of the San Miguel Observatory, he received 4 students, 4 kids, because actually the observatory is not still open to the public, but he received 4 kids with emotional problems, that are for special. They are special kids that maybe something like autism or and the kids that they bring the helmets like astronauts made by themselves, and they was really happy and so happy. My friend Santiago Mayesi told me that it was really he had an emotion about this, because the kids was astonishing only to see a telescope. That we don't have ready the things, but it's so important this that to see when you can make something for the people, for especially this kind of kids that they prepare their own cardboard helmets like astronauts to visit the telescopes, and come on. And
Yeah.
No,
cool.
yes. Was Santiago told me that was he sent me the picture that unfortunately I don't have. Next week I'll prepare a small presentation for the things about the observatory that that how the things are now. And I'll show with this picture because it's amazing. It's amazing. Really something that touch your heart.
Yeah. Jeff Wise
your
is
heart. Sorry. Yeah.
Jeff Wise is saying in the audience, he says, I'm doing an outreach tomorrow morning with third graders, solar observation through several telescopes. That's totally cool.
Yeah.
Wow. Yeah. I want to do that to the kids, and I will to do everything in my power to be able this winter to get kids with their parents to my home, and parents can take a cup of coffee or tea or something, and we could take look at through the telescope, or I stream it in my 55-inch LED TV from the camera, from the scope, and maybe 2-3 kids at a time, and talk about the solar system first and so on. But that's my call to do that, get that to the kids, because school here don't have time with that kind of education. They are trying to hold them from drugs and crimes. So the topic is that kind of in school. So one cannot do everything, but everyone can do something.
Absolutely.
Right. That's right.
Yeah.
So I will try with the kids to keep them from the streets somehow. Maybe I catch one that will be interesting.
That's right. Well, it just takes a spark sometimes.
Yes, just one small spark.
Yeah.
Yes.
And it can
their whole
go there.
lives change. That's right.
And the glow can be there for 20, 30, 40 years and just poof, like it does for me. It was there for 46 years. And I did astronomy. I read all the time, and looked for the documentaries and so on. So I kept going on. But for 15 months ago, it was like a supernova.
That's awesome.
Just poof.
Yeah, absolutely.
And now it's everywhere. It's in my mind all the time. And I just not do that and that. I spread it out like Ida and everywhere I can be, and give a helping hand to tell them in the easy way how everything works. And
absolutely.
But the thing what is very difficult to educate and tell, how do they levitate in the space, the planets? They are so heavy, they are massive. So how are they just floating there, levitating in nothing? And to explain to kids nothing, it's like it's quite
nothing is everything.
Yeah.
So it's fun. It's because you see those smiling faces, and they are so pleased to get more. And I have seen that when they are begin to ask some simple questions, then you have got their interest.
Yeah.
Those who make questions, those are interesting in the topic.
Yeah.
The other one,
Absolutely.
they are just quiet and look at their phones and so on. But there are a few who asks why don't they? How come? Can you show? Okay.
Very good. Very good. I think it's I think a lot of amateur astronomers and professional astronomers feel a responsibility to educate yeah, everyone,
Yes.
that is willing to pay attention, but especially the young people, because
But I think
it makes such a huge difference.
I think, Scott, that the biggest problem we have is the parents, because they are afraid, because they don't have the knowledge about space and astronomy. They don't know nothing. And if somebody gets to learn their kids astronomy, they will be afraid, what is this? Because they don't
even know. Oh,
they
wow.
don't even know what they are teaching to my kids. So we are kind of we have to balance it with the parents and older ones knowledge as well at the same time, so they know what is sun. Okay, it's just ordinary star what you can see in the night sky, but it's very close to us.
Right.
So
as if any star is ordinary, so
yeah.
Right.
But you have to find a way how to put the cards on the table.
Yes.
But that's fun. That's really fun to make some, like my first. This is the. You see,
yes, I remember.
There is the
you showing
moon.
us this. Right.
So they are in scale.
Yes.
Dr. Barth.
But if I
how
use
far
this,
apart do they have to be?
Yes.
Yes. You need
the sun.
That's awesome.
You need a soccer field or something. So.
Yes, I have.
Yeah.
But the sun with this Earth scale will be 6.6 meter high.
Yes, it's incredible.
And to get a yellow ball, which is 6.6 meter high, a balloon. Where do I get that one?
Yeah. You have to have it made.
So I have to shrink this Earth to something small, but then the kids must have something to see and understand. So this is it's not so simple. There are many things that learn kids.
Yes, I like
the frame of reference.
Absolutely. Anytime that I can see the special program of Daniel, how is the last name of Daniel, the lecturer, the professor of physics, Scott.
How do you know?
How do you know? How do you know is amazing.
For me,
you're
talking about
Daniel.
Yes. Daniel is a genius, and I remember the first time that we in a program that I talked about the eclipse from las grutas from Patagonia, and I was astonished with Daniel with the ideas that he had for teach to the kids about the moon phases. Come on, it's a great thing to see how you can have a lot of resources to teach something.
This is got something I have to buy.
Yeah. Honey.
I just shared with Pekka and the group, and I shared it also in the live chat here. This is a giant inflatable 6-meter size inflatable sun.
That's exactly what I need.
I know.
Yes, Pekka. Why
it's
not?
Only $820.
Sure. Honey, I received something new.
It's got free shipping to the United States, probably to Sweden too. So there you go.
So this is in China.
Yes.
Okay.
AliExpress is from China. Yes.
Then it will be cheaper that I take a flight ticket to China and then roll it back to Sweden.
Yeah.
Bring an extra big suitcase to put that thing inside.
Yes, you need a container because I need inflated.
Oh, if you need a container, it's going to be a problem.
Think if the sun is going burst.
Yeah. Sure.
Right.
Okay.
That's very cool.
Yeah,
Well,
thanks a lot.
gentlemen,
Wow.
we have a big day tomorrow. It was wonderful to have you all on tonight, and thank you for being in our our after party. Pekka, it was great to have you back on again.
Thank you, Scott. It
I
was
think
a very
everybody here
pleasure.
missed you. So
Yeah, good
uh,
to see you again.
yeah,
It's been
yeah.
Yes,
And
with,
tomorrow, Cameron, we have your program on Camstronomy. So we'll be on with Cameron tomorrow afternoon. That'll start at 4 p.m. Central, and until that time, keep looking up. Thanks for sharing all these experiences and knowledge about the moon. Is very appropriate for July 20th. I think we're going to do this every July 20th because it is such a special day, for planetary, solar system exploration. And I found a video from Goddard Space Flight Center about the Apollo 11 experience, which I'll play, as we close out here. It's about a 20-minute long video. So for those of you that might want to sit back and watch that, maybe it'll help lull you to sleep with dreams of the moon in your head. But it was really wonderful, and I don't know if any of the other presenters might be still watching, but I do want to thank Caitlin Ahrens and Miss Ehlmann and Gavin and David Levy and Seth Shostak and all the other great speakers that we had on tonight. It was really wonderful, and we'll be back on next Tuesday, of course, with the 56th Global Star Party. So I'll be thinking of a basic theme, but until that time, we'll see you next time. Okay.
Yeah.
And,
Thanks. There's always something new going in the world of astronomy.
Every second. That's right.
Every second.
Every second, yeah.
Yes.
That's right.
Yeah,
And what
I love
an amazing time right now too, with this, ushering in the era of space tourism as we've watched over the last month. So it really is
the youngest and oldest humans in space too.
Yeah, that's
and
right.
solar spots are going to going to be much more.
Solar activity is going up. That's true.
Yes.
Going back towards
right
solar
now.
maximum.
Now that you, Pekka, have your new land solar telescope, we are awaiting your image.
That's right.
Let's see what it's today. It seems to be quite good. Let's see. I will share this for you. There. So this is for today. So there are.
Oh wow!
Yes.
There.
How many sunspots, Pekka?
Many.
There is 4 groups.
4 groups.
Oh, yeah.
Yes. So this is the new one that came yesterday.
If you agree, Pekka and Scott, I can talk with physics, solar physics specialist in solar physics. That his name is Mariano Buzon. That he is working with us in the Observatory of San Miguel, directing all things about how about why it's important recover and restoring an old solar observatory.
Yes.
Because the old data we are recovering from the old films and comparing with the new image and making the history of maybe we can recover the last 50 years or more of solar sunspots, prominence, and still making with the same instruments.
No, that's cool.
It's really cool. If I'll talk with him if he can be able to make us a presentation from his vision, why it's very important recover and restoring this kind of observatories like Observatory of San Miguel, and of course the work of amateur astronomers over solar image.
Wonderful. Yeah. I talk about you often, Cesar, with, the work that you're doing in restoring this historic
Thank you.
observatory complex. And really, I can't wait to see it one day. So
Yes. And we are, yes, really, I'm really awaiting to start to work strongly because we are waiting the position from the majority, from the government of San Miguel to have the, because Air Force, is all about bureaucracy. San Miguel government need to receive the keys really for to start to work strongly in the recovery and restoration,
Yeah, you need long
because it's about legal issues where we don't start to make something that save small things, but really we are awaiting to that the government of San Miguel they need to have the keys to really the possession of the observatory.
Yeah. Well, hopefully that all comes together very soon. So
yes,
because you and your team are the right guys to be in there to be getting that ready. So we don't want to see any more vandalism.
Yes. We removed the objective to save the Carl Zeiss telescope because if somebody broke the lenses, you lost everything.
Sure.
While you have the objective, you have the most important part. The back focusing system is in bronze, but today it's possible to remake again, or we can receive the donation of the part that maybe in one part of the world can exist, maybe.
Right.
Well,
yes.
We are hoping about this. Yeah.
It'd be a shame for it to disappear. Or to be so damaged that you couldn't fix it. So.
Yeah.
Yeah.
Well, we couldn't have a better person leading that, Cesar.
Thank you.
That's what I think. That's what I think.
Thank you.
Yeah.
All right, gentlemen. Well, thank you very much. Chio, sorry that you weren't able to log in, but next time. And Pekka, Cameron, and Cesar, you guys have a great night. Take care.
Thank you. The same.
Good night. Good night, Pekka. Good night, Scott. Good night, Cameron.
Bye, everyone.
Good night, everyone.
Ciao.
Bye-bye. Ciao.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
All is in readiness for the launch of Apollo 11 from Cape Kennedy. Mission Control at the Cape reports the countdown is proceeding on schedule. Astronauts Armstrong, Aldrin, and Collins have suited up and ingressed a command module aboard this 363-foot-high Saturn Apollo configuration. Weather is satisfactory at the Cape. It is estimated that about 1 million tourists are now converging toward the beaches for the launch.
12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11. Tower cleared.
We got a roll program. Neil Armstrong reporting the roll and pitch program, which puts Apollo 11 on a proper heading. Plus 30 seconds. Roll complete and pitch it. program. One Bravo is a abort control mode. Altitude's 2 miles. Oh, 11 Houston, you're good at 1 minute. Downrange 1 mile, altitude 4 miles now. Velocity 2,195 feet per second. Plus 135,003, 554487. Minus 05484, minus 4 balls 1, plus 66232. You with me? Go ahead. 180-239-001. Apogee is NA. Perigee is plus 00175. 66458 737 661 9er 24 2087 167. Foresight stars shallow. Left 008 down 27 minus 2605 minus 02500. 11229er 33993 0125535. Still there? Keep going. Okay, Denham in Vega 067283 337 no H. PLI plus 4 006.
Up here you see the orbital elements again. Apple. This is John Wharton, who operates the computer. We're all flying Mercury and Gemini 4s.
Madrid AOS. Madrid AOS.
Early communications was noisy but readable. Mission Control was able to hear the voices of the crew shortly after the tracking station at Madrid, Spain, acquired the telemetry signals.
Apollo 11 is getting its first view of the landing approach.
The Apollo 11 lunar module Eagle has begun its descent toward the surface of the moon. The descent stage engine of the Eagle was fired at about 9 minutes after 2 p.m. Central Daylight Time. The engine burn time was less than 29 seconds. The engine firing places the lunar module into a slowly descending orbit. Meanwhile, astronaut Collins in the command module Columbia maintains a constant vigil on the descending lunar module. Communications have remained good with both Eagle and Columbia. The planned touchdown is for 3:17 p.m. in an area called landing site number 2.
30 feet down, 2.5. Picking up some dust. 30 feet, 2.5 down. Straight shadow. 4 forward. 4 forward. Drift into the right a little. Ready? Down a half.
Showing the actual position of the spacecraft on the world map. And you can see Cape Canaveral has started tracking, and we will start processing that data.
Okay. Contact light. Okay, engine stop. ATA at a descent. Mode control both auto, descent engine command override off. Engine arm off. 413 is in. We got you down, Eagle. Listen, Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
The lunar module has been on the moon since 3:18 p.m. Central Daylight Time, following a near letter-perfect descent and landing. The lunar module, while on the surface of the moon, is being referred to now as Tranquility Base. Astronaut Neil Armstrong and Buzz Aldrin are preparing to step onto the lunar surface this evening. Preparations for the extravehicular activities are running a little behind schedule. A special display has been set up in the auditorium of Building 8 at the Goddard Space Flight Center during the flight of Apollo 11. A wide variety of displays includes models of the Apollo 11 command module and lunar module, an animated Apollo 11 mission profile, and information on the manned space flight network, the vital communications link required for the Apollo missions. Goddard employees are invited to bring their family and friends to see the display. Hours of the open house are from 10 a.m. until 8 p.m. daily throughout the Apollo 11 mission. In addition, visitors may watch operations of the real-time computer center, NASCOM, and SCAMA through the viewing windows in Building 14.
NASA brings together the scholars and scientists of our university, the research and technological skill of our great industry, the will for peace, and focuses them on whatever job needs to be done. You are inside the lunar module, the LM, or LEM. The craft is flown from a standing position, the LEM pilot to the right, the command pilot to the left. These are the commander's controls. His right hand is on the attitude controller, regulating pitch and yaw and roll.
Astronaut Neil Armstrong and Buzz Aldrin are preparing to step onto the lunar surface. Armstrong will leave the cabin first. TV viewers around the world will be able to see Armstrong be the first human to set foot on another celestial body.
Goldstone, Apollo. Goldstone, Goddard voice. Would you maybe on net one for voice check, please? Oh, roger.
Okay, I just checked, getting back up to that first step. That hasn't collapsed too far, but it's adequate to get back up.
Roger, we copy.
It's a pretty good little jump.
Buzz, this is Houston, F2, 1/160th second for shadow photography on the sequence camera.
Okay. I'm at the foot of the ladder. The LEM footbeds are only depressed in the surface about 1 or 2 inches, although the surface appears to be very, very fine-grained as you get close to it. It's almost like a powder. Ground mass is very fine. That's one small step for man, one giant leap for mankind.
That's one small step for man, one giant leap for mankind.
Surface is fine and powdery. I can pick it up loosely with my toe. It does adhere in fine layers.
Honeysuckle, Goddard voice, net 3.
To the console and inside of my
Roger, Honeysuckle. How's your TV looking now?
I only go in
Roger, and we're starting to get the
maybe
commercial
an eighth
picture
of
now,
an
thank
inch,
you.
but I can see the footprints of my boots and the treads and the fine sandy particles.
White House, Goddard voice. White House. Roger, White House, Goddard voice. How do you hear me?
You're loud and clear, sir. How many?
You're loud and clear also. We'll be extending this circuit now into the Apollo net at Goddard for the presidential call to Tranquility Base.
Roger, thank you.
Thank you. Goddard voice out.
Still a view of the camera for a minute. Neil and Buzz, the President of the United States is in his office now and would like to say a few words to you. Over.
That would be an honor.
Go ahead, Mr. President. This is Houston out.
Hello, Neil and Buzz. I'm talking to you by telephone from the Oval Room at the White House. And this certainly has to be the most historic telephone call ever made. I just can't tell you how proud we all are of what you... For every American, this has to be the proudest day of our lives. And for people all over the world, I am sure they too join with America in recognizing what an immense feat this is. Because of what you have done, the heavens have become a part of man's world. And as you talk to us from the sea of tranquility, it inspires us to redouble our efforts to bring peace and tranquility to Earth. For one priceless moment in the whole history of man, all the people on this earth are truly one. One in their pride in what you have done, and one in our prayers that you will return safely to Earth. Thank you, Mr. President. It's a great honor and privilege for us to be here representing not only the United States, but men of peace of all nations, and with interest and a curiosity and with a vision for the future. Honor for us to be able to participate here today. And thank you very much, and I look forward, all of us look forward to seeing you on the Hornet on Thursday. Look forward to that very much, sir. Columbia, this is Houston, over. Like it's a little difficult to dig through the initial crust. Very interesting. It's a very soft surface, but here and there where I plug with the contingency sample.
Two groups at the Goddard Space Flight Center are waiting for samples of the moon rocks that will be brought back by astronauts Armstrong and Aldrin. The scientists, headed up by Dr. Isidor Adler of the Theoretical Studies Branch and Dr. John Philpotts of the Planetology Branch, will be among some 140 experimenters from the United States and foreign countries to receive the samples after they have gone through quarantine and prepared for distribution by the Lunar Receiving Laboratory of the Houston Manned Spacecraft Center.
Samples out here, the hard rock samples, have what appear to be vesicles in the surface. Also, I'm looking at one now that appears to have some sort of phenocryst. Hey, Neil, didn't I say we might see some purple rocks? Find the purple rocks? Yep.
At approximately 11:53 p.m. Central Daylight Time tonight, astronauts Neil Armstrong and Buzz Aldrin began preparations to re-enter the lunar module.
The Eagle lifted off the surface of the moon at 12:54 p.m. Central Daylight Time today.
Apollo 11 is on the way home.
Apollo 11 is streaking toward a splashdown in the Pacific Ocean. The speed will rapidly increase to a maximum of about 24,800 miles per hour. 400,000 feet above the Earth, the spacecraft will begin to encounter the atmosphere. At that point, the heat shield will begin to heat up.
596, this is Sydney. Go ahead. Good morning, ladies and gentlemen. Captain Brown speaking from the flight deck of Qantas 596. It does seem that we're going to get a very good view of Apollo 11. I think, here they come, on the left side, two of them, one object brighter than the other. See the two of them, one above the other, brightest one lowest? One's the command module, one's the service module. They each weigh 6 tons. They're just picking up heat now. The bottom one's leaving an incandescent trail. You see it flashing? That's a trail of epoxy ablative resin coating. See it brightening up? What a spectacle. It's passing a beam us now at nearly 300 miles. There it
The goes.
Apollo 11 with astronauts Neil Armstrong, Edwin Aldrin, and Michael Collins has splashed down in the Pacific Ocean. The historic voyage to the moon and back ended at 11:50 a.m. Central Daylight Time. The landing took place at a point about 900 miles southwest of Hawaii. As the spacecraft re-entered the atmosphere, one of the recovery planes sighted the spacecraft glowing in the early morning sky. Shortly before splashdown, another of the instrumented aircraft spotted Apollo 11. Then the spacecraft was spotted briefly behind the clouds by those on the recovery ship Hornet. At 11:45, the Apollo 11 crew reported that the chutes had deployed. At 11:48, the Hornet reported visual sighting. Then the Apollo 11 itself reported.
Apollo 11, this is Hornet.
Hornet, over. Hello, Hornet. This is Apollo 11, reading you loud and clear. Our position 1330, 6915.
Helicopters immediately began to hover over the Apollo 11, and then the swimmers dropped into the water for the recovery.
Hornet, Goddard voice by ATS. So Hornet, go ahead. Roger, you're loud and clear. How do you read me? Copy you loud and clear. Roger, we're going to be monitoring this circuit for the recovery sequence. We'll also be extending this circuit onto the White House.
Roger, understand?
White House, Goddard voice.
Oh, White House.
Roger, how do you hear me?
You're loud and clear.
Roger, you're loud and clear also. We'll be extending this circuit into the Apollo net at Goddard. Thank you very much.
President Nixon waving to the astronauts. The curtains have been drawn. There they are in the rear window. The President signaling for applause from the crowd. Astronauts gather in the window.
Neil, Buzz, and Mike, I want you to know that I think I'm the luckiest man in the world. And I say this not only because I have the honor to be President of the United States, but particularly because I have the privilege of speaking for so many and welcoming you back to Earth. I can tell you about all the messages we've received in Washington. Over 100 foreign governments, emperors and presidents and prime ministers and kings have sent the most warm messages that we've ever received. They represent over 2 billion people on this earth, all of them who have had the opportunity through television to see what you have done. All this we pray as our thanksgiving rings out to thee in the name of our Lord. Amen.
Amen.
So Scott, who puts all these together for you? All these are awesome, well edited.
Great.
You gotta have something that's bookend.
That was awesome.
Yeah.
Totally awesome.